Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. In today's session, we are going to discuss NEET 2025 physics paper and we have a total of 45 questions here. So let's start with the first question. The question is, a parallel plate capacitor made of circular plates is being charged such that the surface charge density on its plates is increasing at a constant rate with time. The magnetic field arising due to the displacement current is. So we have a parallel plate capacitor made up of circular plates. So these are the circular plates like this. What else is given? The surface charge density is increasing at a constant rate with time. That means d sigma by dt is constant. Okay, sigma is the surface charge density. Now we have to find out what will be the condition of magnetic field that is arising due to the displacement current. Now we know that the electric field is equal to sigma by epsilon naught and the electric flux is equal to the electric field into the area. That means sigma by epsilon naught into area, right? This is the electric flux. Now let's find out the differentiation of the electric flux, that is d phi by dt. d phi by dt. So if we differentiate this value, what do we get? Area is constant, epsilon naught is constant. So d phi by dt will be equal to area by epsilon naught and d sigma by dt. Okay, this is the value of d phi by dt. Now why we have differentiated the electric flux? Because the displacement current is directly related to the d phi by dt. Okay, we know that the displacement current that is id is directly proportional to the rate of change of electric flux, that is d phi by dt. And if you look at the value of d phi by dt that we have differentiated, that we have calculated, it is a by epsilon naught d sigma by dt. Here a is constant, epsilon naught is constant, and according to the question, d sigma by dt is also constant. It is already given in the question. That means this complete value of d phi by dt is constant. Okay, and we know that displacement current is proportional to d phi by dt, so both will be constant. This d phi by dt is constant, so displacement current will also be constant. This will be constant since d phi by dt is also constant. Okay, so we have come to the conclusion that displacement current is constant and uniform between the plates. Now look at the diagram of this parallel plate capacitor that I have drawn. We have two circular plates, right? And we have concluded that the displacement current will be uniform between the plates like this. Okay, the current will be constant and uniform. So does it look like a cylindrical wire? Yes. So this parallel plate capacitor will start behaving like a cylindrical wire. Okay, so let's write it down here. The parallel plate capacitor will start behaving like a cylindrical wire. Okay, like a cylindrical wire. So what will happen to the magnetic field? The magnetic field will also behave similar to that in a cylindrical wire. So if we talk about the cylindrical wire, then we have different magnetic fields inside the cylindrical wire and outside the cylindrical wire. So inside the cylindrical wire, what is the formula for magnetic field? That is equal to mu naught I by 2 pi r square into small r. Here capital R is the radius and small r is the distance. Okay, so from here we can say that inside the wire the magnetic field will be proportional to the distance r. Okay, now at the surface of the wire, at the surface or periphery, this small r will be equal to the capital R, right? So here the magnetic field will be proportional to capital R. Okay. And outside the wire, outside the cylindrical wire, the value of magnetic field is mu naught I by 2 pi small r, where r is the distance. So here the magnetic field is inversely proportional to r. So these will be the conditions of magnetic field at different points. Okay. So inside the wire, it will be proportional to R. That means as the R will increase, the value of B will also increase. That means the B is non-zero. It is not zero. Okay. At the periphery also, it is not zero. And outside the wire also, it will decrease. It is not zero. It will decrease. So let's check the options. The first option is the magnetic field due to the displacement current is non-zero everywhere with maximum at the imaginary cylindrical surface connecting peripheries of the plates. So this is absolutely correct. We know that at nowhere inside the wire or outside the wire the magnetic field is zero. Okay, it is non-zero everywhere, but it is maximum at the imaginary cylindrical surface. So B is proportional to small r. It will increase with r, and at the periphery or at the surface where the small r is equal to capital R, the value of B will be maximum, right? So this is absolutely correct statement. The second statement says that it is zero between the plates and non-zero outside. No, it is not zero. Then third is zero at all places. Not at all. It is non-zero everywhere. Okay. The last option is constant between the plates and zero outside the place. Again, zero outside the place, incorrect. The first statement is correct. So option A will be the correct answer. Next question, an electric dipole with a dipole moment 5 into 10 to the power minus 6 coulomb meter is aligned with the direction of a uniform electric field of magnitude 4 into 10 to the power 5 Newton per coulomb. The dipole is then rotated through an angle of 60 degree with respect to the electric field. The change in the potential energy of the dipole is. So what is given in the question? The dipole moment, that is P, is equal to 5 into 10 to the power minus 6 coulomb meter. Then the electric field vector E is equal to 4 into 10 to the power 5 Newton per coulomb. Now this is the dipole is rotated through an angle of 60 degree with respect to the electric field. That means if initial angle theta initial was 0 degree, then the final theta final is 60 degree, right? We have to find the change in the potential energy of the dipole. That means delta U. So we know that delta U is equal to final potential energy minus initial potential energy. And what is the formula for potential energy? U is equal to minus P cos theta. Okay, this is the formula for potential energy. So final potential energy means minus PE cos theta final minus initial potential energy, that is minus P cos theta initial, right? So minus Pe cos theta final, minus minus will become plus Pe cos theta initial. Okay. Now let's take Pe outside the bracket. So Pe, here we will get cos theta initial minus cos theta final. Now initial theta is 0 degree, right? So cos theta initial will be equal to cos 0 degree, that means 1. And cos theta final is cos 60 degree, that is equal to half. So let's put these values. Pe under bracket we have cos theta initial, that is 1, minus cos theta final, that is half. So 1 minus half will be equal to half, right? So here we'll get half P, right? And what is the value of P? It is given in the question 5 into 10 to the power minus 6, right? Minus 6 into the electric field is 4 into 10 to the power 5 Newton per coulomb. Now let's solve this. 2 into 2 is 4. Then 5 into 2, 10. 10 into 10 to the power 1, right? Minus 1. So here we will get 1 joule. 1 joule will be the correct answer. Option D is the correct answer. Next question, a ball of mass 0.5 kg is dropped from a height of 40 meter. The ball hits the ground and rises to a height of 10 meter. The impulse imparted to the ball during its collision with the ground is, the value of g is given 9.8 meter per second square. So suppose this is the ground, okay. We have a ball of 0.5 kg here and it is at a distance of 40 meter, okay. It is dropped from a height of 40 meter. So what will be the distance traveled by the ball? 40 meter while coming down, okay. So it will come down from here by traveling, after traveling a distance of 40 meter. So from here we can say that h1 is equal to 40 meter. After this hits the ground, then it again rises to a height of 10 meter, okay. So it will rise to a height of 10 meter. That means h2 will be equal to 10 meter, okay. Now while coming down it will have certain velocity, let's say it is v1, and while again moving up it will have certain velocity, let's say it is v2, okay. Now we have to find out the impulse that is imparted to the ball during its collision. So first let's find out the value of v1 and v2, okay, the velocities with which it hits the ground and then it rises back. So v1 will be equal to under root 2gh1, because the formula for velocity is under root 2gh, okay. So v1 will be equal to under root 2gh1. So let's put the values. Under root 2 into g is acceleration due to gravity, whose value is given in the question, 9.8 meter per second square, into h1, that is 40 meters, okay. So if you solve this you get under root 784, that is equal to 28, and the unit of velocity is meter per second. So v1 is equal to 28 meter per second. Similarly we can find out the value of v2, that is under root 2gh2 under root 2 into g, that is 9.8 meter per second square, into h2 is 10 meter. So under root 196, that is equal to 14 meter per second. So v1 is 28 meter per second and v2 is 14 meter per second. Now we can simply find out the impulse, because we know that the impulse is nothing but the change in momentum, okay. So impulse is equal to the change in momentum delta p, that is equal to m v final minus v initial, okay. Momentum is equal to mv. So change in momentum will be m into v final minus v initial, or v2 minus v1, m v2 minus v1. So let's put the values. What was the mass m of the ball? It was 0.5 kg, right? So we can write half for that, 0.5, and v2 is 14 meter per second and v1 is 28 meter per second. So v2 minus 28. Why minus 28? Because on moving upward the velocity is taken as positive, okay, whereas on moving downward the velocity will be taken as negative. Since the direction is opposite, if one is positive the other should be negative, okay. So on moving up the velocity is 14 meter per second, and while moving down it will be written as minus 28 meter per second, okay. So let's solve it. Half into, here we'll get 42, 14 plus 28, 42, and here we'll get 21, and what is the unit of impulse? It is Newton second. So 21 Newton second is the impulse imparted. So option C will be the correct answer. Next question. The intensity of transmitted light when a Polaroid sheet placed between the two crossed Polaroids at 22.5 degree from the polarization axis of one of the Polaroids is, I naught is the intensity of polarized light after passing through the first Polaroid. See, this question is not difficult, but it can be quite confusing if you do not pay attention. Okay, so you have to be very attentive while solving this question. Let's try to understand the question first. We have two Polaroids, okay, and these Polaroids are crossed, okay. We have two crossed Polaroids, and we know that when the Polaroids are crossed, it means the angle between them should be 90 degree, okay. The angle between the transmission axis of both the Polaroids should be 90 degree. So if one Polaroid is like this is the transmission axis, then the second Polaroid should be like this This is the transmission axis of the second one. Okay, the angle between them should be 90 degree. Now it is given that there is a Polaroid sheet that is placed between these two, making an angle of 22.5 degree with one of them. So suppose this is the Polaroid sheet. I am shading it to identify this. Okay, and this is making an angle 22.5 with the first one. So theta 1 is equal to 22.5 degree. Then what will be the angle between this Polaroid sheet and the other Polaroid? It will be 90 minus 22.5. This is the value of theta 2. So theta 1 is 22.5 degree and theta 2 is 90 minus 22.5 degree. Okay. Now here we have three Polaroids. So the light has to pass through all the three Polaroids one by one. Okay. And after passing through each Polaroid, the intensity of light will change. Okay. In the question it is given that after passing through the first Polaroid, the intensity of the light will become I naught. Okay. So let's write it down here. After passing through the first Polaroid, the intensity of the light is I naught. Okay. Then the light with intensity I naught will pass through the second Polaroid. Let's say this is first Polaroid, this is second Polaroid, the middle one is second Polaroid, and this one is third Polaroid. Okay. Then after passing through the second Polaroid, what will be the intensity? Let's say I1, the intensity is I1. So that will be equal to I naught cos square theta according to the formula, okay, Malus formula. So I1 will be equal to I naught cos square theta. And what is the value of theta? Here we are taking the angle between the first and the second Polaroid, that is theta 1. So cos square theta 1, that is equal to 22.5 degree. So I naught cos square 22.5. This is the intensity of light after passing through the second one. Then the light with this intensity will pass through the third one. So after passing through the third Polaroid, we have the new intensity, that is I2, that will be equal to I1 cos square theta 2. This time we will take the angle between the second Polaroid and the third Polaroid. Okay. So let's put the values. First, what is the value of I1? It is given here. Okay, I naught cos square 22.5. So I naught cos square 22.5. And then we have cos square theta 2. So cos square theta 2, that is 90 minus 22.5. Okay, so here you have to pay attention. This is the step where you might get confused because cos square theta comes two times. Okay, first cos square theta 1 and then cos square theta 2. Then here we have I naught cos square 22.5 can be written as 45 by 2. Okay, it will be easier to solve. Then cos square 90 minus 45 by 2. Right? Now here we have cos square 90 minus theta. So cos square 90 minus theta can be written as sin theta, right? So in place of this we will write sin square 45 by 2. So let's write it down. I naught cos square 45 by 2. Here we have sin square 45 by 2, right? Because in trigonometry there is a formula, cos 90 minus theta equals to sin theta. Okay, so in place of cos square 90 minus 45 by 2 we have written sin square 45 by 2. Now let's take 4 as the numerator as well as denominator. So it will be easier to solve the question. Let's see how. I naught by 4, and here on the numerator side also we'll take 4. So 4 cos square 45 by 2 sin square 45 by 2. Now this 4 cos square 45 by 2 sin square 45 by 2 is the square of 2 sin 45 by 2 cos 45 by 2. Okay, if you find the square of this, this will be equal to 4 cos square 45 by 2 sin square 45 by 2. Okay, so in place of this we can write I naught by 4, then 2 sin 45 by 2 cos 45 by 2 whole square. Okay, Again, we'll use the formula. We know that 2 sine theta cos theta is equal to sine 2 theta, right? Sine 2 theta is equal to 2 sine theta cos theta. So here under the bracket we have 2 sine theta cos theta. So that will be equal to sine 2 theta. That means sine 2 45 by 2. Okay. So 2 will cancel out. That will be equal to sine 45 degree. So I naught by 4 sine 45 degree square. Okay. So I naught by 4 sine 45 degree is equal to 1 by root 2. So square of 1 by root 2 will be equal to 1 by 2. So I naught by 8 will be the final intensity of the light. Okay. I naught by 8. Now let's see the options. It is given in the first option. So option A will be the correct answer. Next question is the kinetic energies of two similar cars A and B are 100 joule and 225 joule respectively. On applying brakes, car A stops after 1000 meter and car B stops after 1500 meter. If Fa and Fb are the forces applied by the brakes on cars A and B respectively, then the ratio of Fa and Fb is. So what is given in the question? We have two cars, car A and car B. The kinetic energy of car A is 100 joule. So Ka is 100 joule. Whereas the kinetic energy of car B, that is Kb, is 225 joule. While these two cars are moving, brakes are applied to stop them. So car A stops after 1000 meter. That means the distance travelled by car A, SA, is 1000 meter. And the distance travelled by car B is 1500 meter. So these things are already given in the question. Fa and Fb are the forces that are applied by the brakes to stop the car. We have to find the ratio of Fa and Fb. So we know that the work done is equal to change in kinetic energy. Change in kinetic energy. And work done is equal to force into displacement. So F into S is equal to change in kinetic energy, that is final kinetic energy minus initial kinetic energy. Another important thing that you have to keep in mind is that the direction of the force applied by the brakes and the direction of the motion of the cars are opposite to each other, right? That means if the car is moving towards right side, then the force applied by the brake is in the left side. Then only the car will stop. Okay. If the direction will be same, then the car will not stop moving. It will keep moving, right? But we have to stop the car, so the force has to be applied in opposite direction. Okay, so since the direction of motion and the direction of force applied is opposite to each other, therefore the work done will be negative. So before F into S, we will write a negative sign. Okay, so this will be the correct expression. Minus F into S equals to K final minus K initial. Now here eventually car has to stop. Okay, so finally, or we can say that the final velocity of the car is going to be 0 because it will stop, right? So final kinetic energy will also be 0. Okay, so in place of kinetic energy final, we can write 0. Okay, so minus F into S will be equal to minus K initial because K final is 0. Now minus sign cancelled. From here we can say that F into S is equal to kinetic energy. That is the initial kinetic energy of the car. Now here we have to find the ratio. So FA by FB will be equal to Ka by Kb into SB by SA. Because if we take S this side, it will be on the denominator side. So force will be inversely proportional to the displacement. Okay. Now let's put the values, then we will find the answer. Fa by Fb is equal to Ka by Kb. What is the value of Ka? It is 100 joule, right? So 100 by the Kb, that means the kinetic energy of the car B was 225 joule. This side, the distance travelled by car B was 1500 and the distance travelled by car A was 1000 meter. Now if we solve this, what do we get? We will get 2 by 3. So the ratio of Fa and Fb is 2 by 3. It is given in the last option. Option D is the correct answer. Let's come to the next question. The question is the current passing through the battery in the given circuit is. So a circuit is given which looks quite complex. We have to find the current that is passing through the battery. This is the battery, 5-volt battery. Okay. We know that the current is equal to the voltage divided by the equivalent resistance. This is the simple equation to find the current. Now voltage is given 5 volt, but R equivalent will have to be calculated. Okay. So here you can see there is a big square shaped circuit. Then on one side of this square shaped circuit, there is a rectangular circuit. So first we will solve this rectangular circuit. If you look at this circuit carefully, you will observe that this is actually a Wheatstone bridge. Let's draw the simplified diagram for this Wheatstone bridge. We have point A, point B, point D and point E. Okay, you can ignore point C and point F. This is point A, point B, point D and point E. Now there are resistances in between the 2 points. Okay, so we are drawing the resistances. Okay, so this looks like this. Now the resistance between A and B is that of 5 ohm. The resistance between A and E is 3 ohm. That between B and D is 2.5 ohm, and the resistance between D and E will be 1.5 ohm. Okay, so here if we divide 5 by 3 and 2.5 by 1.5, then we will get the same values. Okay, so if we find the ratio of 5 and 3, that will be equal to the ratio of 2.5 and 1.5. Okay, this will also come out to be 5 by 3. So since this is the ratio is same, we can say that this is a balanced Wheatstone bridge. Balanced Wheatstone bridge. Okay. So what will be the equivalent resistance of this balanced Wheatstone bridge? The 5 ohm and 3 ohm resistance are in series and 2.5 and 1.5 in series. So this is point B, this is point E. Here we have 5 ohm plus 3 ohm, that is 8 ohm resistance. Okay, and this side 2.5 plus 1.5, that is 4 ohm resistance. Okay, so 8 ohm and 4 ohm. Now these two resistances are in parallel, so the equivalent resistance of this circuit will be 8 into 4 upon 8 plus 4. That means 32 divided by 12. So it will come out to be 8 by 3. So the equivalent resistance of this circuit is 8 by 3. But this is the equivalent resistance of only this circuit, rectangular circuit. We have not calculated the complete resistance. Okay, we have another circuit as well. So let's draw this diagram again. We have this bigger square shaped circuit. So here we have 1.5 ohm resistance. Then here we have 5.5 ohm resistance. Okay, we are drawing the bigger circuit. Okay, here we have the battery of 5 volt. Then here 1.3 ohm resistance, sorry, 1 by 3 ohm resistance. And then here we have calculated the equivalent resistance, that is 8 by 3. Okay, now we have got the simplified version of the complete circuit. So all these resistances 1.5, 5.5, 1 by 3 and 8 by 3 all are in series now. So the equivalent resistance of the complete circuit will be equal to 1 by 3 plus 8 by 3 plus 1.5 plus 5.5. So let's solve this. Here 1 by 3 plus 8 by 3 means 9 by 3, that is equal to 3. Okay, plus this side we have 7. So 7 plus 3, that is 10. So 10 ohm is the equivalent resistance of this complete circuit, but we have to find out the current. So the current that is passing through the circuit will be equal to voltage, that is 5 volt, divided by the equivalent resistance, that is 10 ohm. So half, and the unit will be ampere. So half ampere, or you can say 0.5 ampere. So half ampere or 0.5 ampere will be the correct answer. This is given in the last option. Option D, 0.5 ampere will be the correct answer. Next question. 3 identical heat conducting rods are connected in series as shown in the figure. The rods on the sides have thermal conductivity 2K while that in the middle has thermal conductivity K. The left end of the combination is maintained at temperature 3T and the right end at T. The rods are thermally insulated from outside. In steady state, temperature at the left junction is T1 and that at the right junction is T2. The ratio T1 by T2 is. So before we start solving this question, you must have a careful look at the given diagram. Then only you will understand the question well. You can see that there are three different rods which are connected in series, right? They have different conductivities. First rod has the conductivity 2K, second rod has the conductivity K, and the third rod has the conductivity 2K. But these are identical rods. That means they will have the same length and same area of cross section. So if the length of the first rod is L, then the length of the second and third rod will also be L. Another important thing that you have to note here is that there are different temperatures at different points. Okay, on the left hand side, the temperature at this point A is 3T. Okay, let's say this is point A. Then we can write the point B for the next point, that is the junction of the first and second rod. Then the junction of the second and third rod is point C and the last one is point D. So we have mentioned these points to solve this question easily. Okay, we have four different points. Now you can see that the uh, temperature at point A is 3T. Then the temperature of the first junction is T1. Temperature of the second junction, that means junction of second and third rod, is T2, and then the temperature at the right hand side is T. So four different temperatures are mentioned here. So let's start solving this question. What is the formula for resistance? Thermal resistance, that is equal to L by K into A, where L is the length of the conductor, A is the area of cross section, and K is the thermal conductivity. So here we will have different resistance for the different rods here. We have three rods, so three different resistance will be there. What will be the resistance of the first rod? R1 will be equal to L by 2K into A. 2K, why? Because the thermal conductivity of the first rod is 2K. Okay. Then for the second rod, the resistance will be equal to L by Ka, because this time the thermal conductivity is K. And now for the third rod, the thermal resistance will be equal to L by 2K into A, again because it has the thermal conductivity 2K. So these are the individual resistance of all the three rods. What will be the equivalent resistance of the combination of the rods? That will be equal to R1 plus R2 plus R3, because these are in series combination, right? So R1, that means L by 2Ka, plus R2, that means L by Ka, and R3 L by 2Ka. So L by Ka is common in all. So we can take it outside the bracket, and under the bracket we will have half plus 1 plus half. So equivalent resistance will be equal to half plus half 1 and 1 plus 1 2. So 2L by Ka. This is the equivalent resistance of the combination. So now we have the individual resistance as well as the equivalent resistance of the combination. Now let's find the heat current. So what is the formula for heat current? Heat current is equal to the temperature difference delta T divided by the resistance. Okay. So if we find the heat current of the combination of the rods, that means heat flowing from point A to point D will be equal to temperature difference between point A and point D. So at point A the temperature is 3T, and at point D the temperature is T. So here the temperature difference will be 3T minus T divided by the resistance. What will be the equivalent resistance? 2L by Ka. So 2L by Ka. So Ka will come on the numerator side. So 3T minus T, that means 2T into Ka divided by 2L. So 2 will get cancelled. What will be the heat flowing from point A to point D? That will be equal to Tka upon L. So this is the heat flowing from point A to D. Similarly, we will find the heat that is flowing from point A to B and from point C to D. Okay, so let's find out the heat flowing from point A to B. Point A to B. So that will be equal to again the temperature difference. Now what is the temperature difference between point A and point B? Here you can see at point A the temperature is 3T and at point B the temperature is T1. right? So this time we will write 3T minus T1 in the temperature difference. 3T minus T1 divided by the resistance. So this time we will not write equivalent resistance because we are not talking about the combination of the rods. We are talking about only point A to point B, that means only the first rod. So here we will write the resistance of the first rod. What is the resistance of the first rod? L by 2K into A. Okay, L by 2K. So let's write that L by 2K. So 2K will come up. Okay. So simply we can write 3T minus T1 into 2Ka divided by L. So this is the heat flowing from point A to point B. Let's say the first one was equation 1 and this is equation 2. Okay. Now we will find one more equation, that means heat flowing from point C to D. Okay. This time let's find the heat flowing from point C to D. So what is the temperature difference from point C to D? Here you can see at point C the temperature is T2. At point D the temperature is T. So in temperature difference we will write T2 minus T. So T2 minus T divided by the resistance of the third rod, that means L by 2Ka. So L by 2Ka. So this time it is T2 minus T into 2Ka upon L. So this is equation 3. Now we have to find the value of T1 and T2 using these three equations. Now we know that all the three rods were connected in series. That means in series combination we know that the current flowing is same. Okay, so the heat currents will be equal. Heat currents flowing through each conductor will be equal or same. Even the combination heat flowing through the combination will also be equal to the heat flowing through the each of the conductor. That means equation 1 will be equal to equation 2 and that will be equal to equation 3. All will be equal. So let's equate equation 1 and 2 first. So equation 1 is equal to equation 2, we know, because the heat current will be same in series combination. So equation 1 is TKA by L and equation 2 is 3T minus T1 into 2Ka divided by L. From here we can find the value of T1. L will get cancelled, it is present on both the sides. Then Ka will also get cancelled. What is left here? We have T this side and this side we have 3T minus T1 into 2. That means 6T minus 2T1. Okay, 2 will be multiplied. These will be multiplied by 2. So 2T1 will be equal to 6T minus T, that is 5T. So T1 will be equal to 5 by 2T. Okay. So from here we can say that T1 is equal to 5 by 2T. Similarly, we can compare equation 1 and equation 3 to find the value of T2. So equation 1 will also be equal to equation 3. What is equation 1? It is TKA by L. And what is equation 3? Let's see. On equation 3, we have T2 minus T into 2Ka by L. So T2 minus T into 2Ka by L. Again, L will get cancelled, K will get cancelled, A will get cancelled. What is left? This side we have T, this side we have T2 minus T into 2. So 2T2 minus 2T. Okay. Let's solve this again. We can bring 2T this side. So T plus 2T, that means 3T equals to 2T2. So from here we can say that T2 will be equal to 3 by 2T. So we have found the value of T1 and T2 in terms of T, right? T1 is 5 by 2T and T2 is 3 by 2T. What we have to find out in this question? We have to find the ratio of T1 and T2. So T1 by T2 will be equal to 5 by 2T divided by 3 by 2T. So here we'll get 2 by 3T. Okay. So T will get cancelled, 2 will get cancelled. What is left? 5 by 3. The ratio of T1 and T2 is 5 by 3. So let's have a look at the options. In the first option it is given. Option A will be the correct answer, 5 by 3. Next question is, in an oscillating spring mass system, spring is connected to a box filled with sand As the box oscillates, sand leaks slowly out of the box vertically so that the average frequency omega t and average amplitude at of the system change with time t. Which one of the following options schematically depicts these changes correctly? So we have an oscillating spring mass system. Suppose this is the spring. Here we have the box that is filled with sand. Okay. Now the sand is leaking from this box vertically. Okay. So the amount of sand is decreasing in the box, right? The amount of sand is decreasing in the box. That means the mass will decrease. So the mass m of the particle is decreasing. Now we have to select the correct schematic representation. Okay, here it is shown in the diagrams. We have to find the correct option, right, with respect to the omega t, that is average frequency, and the amplitude of the system. So which one is shown correctly? Let's see. Here you have to simply remember some formula. For example, we know that the time period in the system will be 2 pi under root m by k, where k is the spring constant, m is the mass. Okay, and we know that the omega, that is the frequency, is equal to 2 pi by t. So in place of t we can put this value. So omega will be equal to 2 pi divided by 2 pi, and this side we have under root k by m. Okay, now 2 pi will get cancelled, so omega is equal to under root k by m. So from here we can understand that the omega is inversely proportional to root m. That means if the mass is decreasing, then the omega will increase. Okay, these are inversely proportional. So the graph of omega should be like this, in the increasing order. Okay, it will increase. The graph of omega will increase. Now what about the amplitude? So we have a formula for amplitude as well. We know that the total mechanical energy of the system, will be equal to half Ka square, right? Where K is the spring constant and A is the amplitude. We know that the total mechanical energy also consists of the mass, okay, the kinetic energy plus potential energy. So we have half mv square in the kinetic energy. So this total mechanical energy is also related to mass. So when mass will decrease, then the amplitude will also decrease, okay, because the total mechanical energy is proportional to the mass. It is directly proportional to the mass. So this amplitude is also proportional to the mass. So when mass is increasing, then the amplitude will also increase. And since in this case the mass is decreasing, so the amplitude will also decrease. So the graph of amplitude will be like this. Okay. So omega will increase and amplitude will decrease. Now let's check the options. In the first option, both are increasing, which is incorrect, because omega should increase and amplitude should decrease. In the second one, both are decreasing, again incorrect. In the third option, omega is increasing but the amplitude is constant, so this is also incorrect. And in the last option, omega is increasing and the amplitude is decreasing. This is the correct representation. So option D will be the correct answer. Next question, AB is part of an electrical circuit. The potential difference VA minus VB at the instant when current I is equal to 2 ampere and is increasing at a rate of 1 ampere per second is. So this circuit is shown. We have to find the potential difference VA minus VB. Okay. Now you can see that in this circuit we have an inductor of inductance 1 Henry. So the value of L is 1 Henry. Okay. L is the inductance. Right. Then we have a battery. The next thing is a battery of voltage 5 volt. Right. And then we have a resistor with the resistance 2 ohm. Right. So the potential difference in each part will be different. We have to find the total potential difference from A to B. Okay. Now we know that in case of an inductor, the potential difference is equal to minus L di by dt. Okay, this is the formula, minus L di by dt. So minus the value of L is 1 Henry and di by dt, that means rate of change of current is given in the question 1 ampere per second. So minus 1 into 1, that means minus 1. So the potential difference at the inductor will be minus 1. Okay, minus 1 volt. And then at the battery, now here we should understand the sign convention, that if we are moving from positive terminal of the battery towards the negative terminal, in this case we write a minus sign. Okay, but when we are moving from negative to positive, it will be positive sign. Okay, so here we are moving from positive sign to negative sign when we are moving from A to B. Okay, this is the positive sign, this is the negative sign in the circuit. So we will write a minus sign, so the potential difference will be equal to minus 5 volt. Okay, so here we have the potential difference minus 5 volt. Now at the resistor, again in the resistance you have to remember one thing, that suppose we have point A and point B here. We have a resistor in between these 2 points of resistance R, and the motion of current or the movement of current is in the direction from A to B. In this case, the potential difference is written as minus IR. And if we are moving from B to A, in that case, the potential difference will be equal to plus IR. Okay, so if the direction of current is same, then we write minus sign. If the direction of current is opposite, we write plus IR. Okay, so here you can see that we are checking from A to B, and this is the same direction as the direction of the current. So there will be minus sign. So in this case, the potential difference will be equal to minus IR, minus IR. That means minus I, that means current is 2 ampere here, and the resistance is also 2 ohm. So it will be minus 4 volt. So these are three potential differences or three voltages that you have to keep in mind. So let's start. We have VA, that is the potential at point A. Then we have the inductor. So what is the potential difference at inductor? It is minus 1 volt. We have seen at the beginning. So minus 1 volt. Then we have the battery. Here the potential difference is minus 5 volt. Then we have the resistance. Here the potential difference is minus 4 volt. Okay, and that will be equal to VB, the potential difference at the point B. So VA, here minus minus plus, so minus 6 and minus 4 will become minus 10. So VA minus 10 volt will be equal to VB. We have to find out VA minus VB. So VA minus VB will be equal to plus 10 volt. It will be equal to plus 10 volt. So option B will be the correct answer. Next question, a particle of mass m is moving around the origin with a constant force F pulling it towards the origin. If Bohr model is used to describe its motion, then the radius of nth orbit and the particle's speed v in the orbit depends on n as. So we have a particle of mass m that is moving around the origin with a constant force pulling it towards the origin. Okay, suppose this is the circular path of the particle mass m. This is the origin. Okay, the particle of mass m is moving around this origin. There is a constant force F that is pulling the particle towards the origin. Now here we have to assume that the Bohr model is used to describe the motion, and we have to find the relation between the radius of the nth orbit and the number of orbit n, as well as the relation between the speed of the particle v and the value of n. So we have to find two relations, relation between r and n and the relation between v and n. Okay, so we know that the force is equal to mv square by r, and it is given in the question that the force is constant. That means mv square by r is constant, right? We know that mass is always constant. So here v square by r will be constant. That means v square will be proportional to r, right? Or we can say that r is proportional to v square, or we can say that v is proportional to r to the power half or root r. Okay, so r is proportional to v square or v is proportional to r to the power half. So these things you can keep in mind. Now we know that according to the Bohr's quantization rule, the angular momentum is equal to nh by 2 pi. And we know that the angular momentum is equal to mvr. So mvr is equal to nh by 2 pi. Okay, so here VR will be equal to NH by 2 pi m. We know that the H is Planck's constant, which is always constant. 2 pi is a number, so it is constant, and mass is always constant. Okay, so H by 2 pi m will always be constant. That means VR will be proportional to N, right? Now from here we can find the relation between V and N as well as the relation between R and N. So let's put V in terms of R first. We know that V is equal to R to the power half, right? So we can put R to the power half in place of V. So this is the first method. So R to the power half into R is proportional to N. That means R to the power 3 by 2 is proportional to N. So we can say that R is proportional to N to the power 2 by 3. So this is the relation between R and N. Now we can find the relation between V and N by writing the R in terms of V. Okay. Second method, we know that VR is proportional to N. Now here we can write R in terms of V. We know that R is proportional to V square. This one. R is proportional to V square. So V into V square is proportional to N. So V cube is proportional to N. That means V is proportional to N to the power 1 by 3. So now we have the relations that are asked in the question. R is proportional to N to the power 2 by 3 and V is proportional to N to the power 1 by 3. Now let's see. In the first option, it is given R is proportional to N to the power 2 by 3 and V is proportional to N to the power 1 by 3. This is the same that we have calculated. So, or that we have found. So, first option will be the correct answer. Okay. Next question. In some appropriate units, time t and position x relation of a moving particle is given by t equals to x square plus x. The acceleration of the particle is. So it is given that t is equal to x square plus x. So what will be the value of dt by dx? Dt by dx. So here we have to differentiate with respect to x. Okay. So dt by dx will be equal to the differentiation of x square plus x. That means 2x plus 1. This is dt by dx. Now we have to find the acceleration of the particle. So before we find the acceleration, we need to find the velocity. So velocity will be equal to what? Dx by dt, right? But here we have the value of dt by dx. So this will just be the reverse of dt by dx. That means 1 by 2x plus 1. 1 by 2x plus 1. This is the velocity, right? Now dv by dx will be what? Why we are finding dv by dx? Because we know that the acceleration is equal to v dv by dx. So we have to use this dv by dx to find the acceleration. dv by dx will be the differentiation of this 1 by 2x plus 1. That will be minus 2 by 2x plus 1 square. Okay, 2x plus 1 whole square. This is the dv by dx. Now we can find the acceleration, that is equal to v dv by dx. So just put the values. What is the value of v? 1 by 2x plus 1. 1 by 2x plus 1. This is the velocity. And what is the value of dv by dx? This one. Minus 2 by 2x plus 1 whole square. Okay. So here we have 2x plus 1 and here we have 2x plus 1 whole square. So it will be 2 plus 1, 3. That means cube. So minus 2 divided by 2x plus 1 cube. This will be the value of acceleration. Minus 2 by 2x plus 1 whole cube. So in the first option we have a plus sign. So this is incorrect. Again in the second option we have plus sign. Incorrect. In the third option we have minus sign. But here we have x plus 2 whole cube, which is incorrect. In the last option we have minus 2 divided by 2x plus 1 whole cube. This is the correct answer. Option D is the correct answer. Next question is a model for quantized motion of an electron in a uniform magnetic field B states that the flux passing through the orbit of the electron is nh by E. Okay, it is nh by E, where n is an integer, h is Planck's constant, and E is the magnitude of electron's charge. According to the model, the magnetic moment of an electron in its lowest energy state will be. So we have an electron that is moving in a uniform magnetic field, right? Uniform magnetic field. Now it is given in the question that the flux phi is equal to nh by E. It is already given. The flux is equal to nh by E. We have to find the magnetic moment of the electron in its lowest energy state. Lowest energy state means the value of n should be 1. Okay, so here you have to keep in mind n is equal to 1. So this value we will put in the final expression. Another important thing that you have to keep in mind is that the final expression of magnetic moment that you will get should not have v, velocity or time t, because these are not mentioned in the given options. So if you get velocity or time in your expression, then you will have to convert them into something that is mentioned in the given options, right? You will understand this better when we solve the question. So let's start with the magnetic force. We know that the magnetic force in this case will be equal to the centripetal force, that is mv square by r. And we know that magnetic force is equal to qvb, where q is the charge. So here we are talking about the charge on the electron. So in place of q we can write e. So e v b, where v is the velocity of the electron, b is the magnetic field. So that is equal to mv square by r. So this v will cancel out the square this side. From here we can say that the velocity v is equal to ebr upon m. So this is the expression for velocity of the electron. Okay, I have already told you we will not be using the velocity v or time t in our expression. So we will convert them into something else. So in place of v we can write ebr by m. Then second important thing is flux. We know that the flux is equal to the magnetic field into the area. Okay, now according to this question, the flux is equal to nh by e, already given in the question. Okay, so nh by e is equal to b magnetic field into the area, that is pi r square. Okay, from here we can say that b r square will be equal to nh by e pi. Okay, this is another expression that you have to keep in mind. Again we will be using this expression in the to find the final expression. Okay, br square equals to nh by e pi. Then now we come to the final step, that is the magnetic moment, because we have to find out the magnetic moment. So what is the formula for magnetic moment? Mu, that is equal to the product of current and area, I into A. Okay, we know that the current is equal to charge by time. So here we can write charge, that is electronic charge, divided by the time in place of the current. Okay, into the area, that is pi r square. Now we will just come to the expression that is mentioned in the options. Okay, so in place of time again we can write distance by speed, isn't it? Distance by speed or velocity. In place of distance we can write 2 pi r, because there is circular motion. So 2 pi r divided by the velocity. So just see the first expression, v equals to ebr by m. Here we have written. So in place of v we can write ebr by m. Okay, so like this. So let's write it down here. We have e by t into pi r square. In place of t we have to write distance by velocity. So e by distance 2 pi r and velocity will go up. Okay, so here we'll get ebr by m, and here we have pi r square. Okay, so pi will get cancelled. 1 r here will cancel the square this side. Then what do we get? We will get half e square. We have 2e, so e square, then b, then 2 r's are there, so r square upon m. Okay, half e square br square by m. Now look at this second number. We have found the expression for br square. So br square is equal to nh by e pi. So we can write nh by e pi in place of br square. So half e square by m into nh by e pi. So 1 e will cancel this square here, and the final expression will be ENH by 2m pi, and n is equal to 1. Okay, because it is given in the question that there is lowest energy level, so n will be equal to 1. So simply we can write E into H or H into E divided by the 2 pi m. So this will be the final expression. He upon 2 pi m. So you can see it is given in the last option, option D, He upon 2 pi m. So option D will be the correct expression for magnetic moment of the electron. Next question. A microscope has an objective of focal length 2 cm, eyepiece of focal length 4 cm, and the tube length of 40 cm. If the distance of distinct vision of the eye is 25 cm, then the magnification of the microscope is. So it is given that the focal length of the objective, that is FO, is 2 cm. Focal length of the eyepiece, that is FE, is 4 cm. The tube length, that is L, is equal to 40 centimeter, and the distance of distinct vision, D, is equal to 25 centimeter. We have to find the magnification of the microscope. So we will use the formula magnification equals to L upon FO into D by FE. Okay, so let's put the values here. Length, that is the length of the tube is 40 centimeter, divided by FO, the objective's focal length, that is 2 centimeter. Then distance of distinct vision is 25 centimeter, and the focal length of the eyepiece is 4 centimeter. So here we'll get 4 into 10, 40, and then 2 into 5 is 10. So 5 into 25, that is 125. This is the magnification. Option D will be the correct answer. Next question is, there are two inclined surfaces of equal length L and same angle of inclination 45 degree with the horizontal. One of them is rough and the other is perfectly smooth. A given body takes 2 times as much time to slide down on a rough surface than on the smooth surface. The coefficient of kinetic friction mu k between the object and the rough surface is close to. Okay. So let me tell you that this solution is going to be quite lengthy. It's not difficult, but it's lengthy. So you have to pay attention. Okay. We have two inclined surfaces. Suppose this is one of the inclined surfaces and this is another inclined surface. Okay, the length of the inclined surface is same and the angle of inclination is also same, that is 45 degree with the horizontal. Right, now we have body that is sliding down the surfaces. It is given in the question that the time taken by the body to slide down the rough surface is 2 times the time taken by the body to slide down the smooth surface. So suppose this is the rough surface and this is the smooth surface. And let's say that the time taken by the body to slide down the rough surface is TR and the time taken by the body to slide down the smooth surface is TS. So it is given that TR is 2 times TS. Okay, it is already given in the question. Now one thing you have to keep in mind, that in case of rough surface there will be frictional force, whereas in smooth surface it is perfectly smooth, so there will be no friction. Okay, in case of smooth surface there will be no friction. Now let's discuss the forces that will be acting on the body. So this is the body that is kept on the rough surface. What are the forces acting on it? In the upward direction there will be a normal force. Okay. In case of smooth surface also there will be a normal force acting in the upward direction. Now this normal force is balanced by a downward force, that is mg cos theta. So mg cos 45 degree will balance the normal force. Similarly in smooth surface also this normal will be balanced by a downward force, that is mg cos 45 degree. Right. So these are same. Then in the direction of the motion of the body there will be force mg sin 45 degree. Okay, mg sin theta in both the cases. Now what will be the difference between these two cases is that in case of rough surface there will be a frictional force that will be acting opposite to mg sin theta, but in case of smooth surface there is no frictional force acting opposite to mg sin theta. Okay, so three forces are common in both the cases and one force, that is frictional force, is present only in the rough surface. Okay, now let's start solving the question. We will find the acceleration in both the cases. So let's find the acceleration for rough surface first. So for rough surface, the net force F net will be equal to mg sine theta, that is mg sine 45 degree, minus the frictional force, because frictional force will be opposing the motion. Frictional force will be acting opposite to mg sine theta. Okay. Now F net, that means mass into acceleration, is equal to mg sine 45 degree minus frictional force. What is the formula for frictional force? It is mu into n, where mu is the coefficient of friction and n is the normal force, right? So ma equals to mg sine 45 degree minus mu into n. Now again, in place of normal force n, we can write mg cos theta. So mu mg cos theta, because the normal force is balanced by mg cos theta. So mg cos 45 degree we can write. Okay. Now m is present on both the sides, so m can get cancelled. So this side we have acceleration. This side we have g sine 45 degree. Sine 45 degree means 1 by root 2. So g by root 2 minus mu g by root 2, because cos 45 degree is also 1 by root 2. Now here we can take g by root 2 common, and under bracket we will have 1 minus mu. So what is the acceleration in case of rough surface? That is equal to g by root 2 1 minus mu. Okay, and we can write mu k because it is the coefficient of kinetic friction. So this is the acceleration for rough surface. Similarly, we can find out the acceleration for smooth surface, but it will be easier than the rough surface. Okay, for smooth surface, here you can simply find the acceleration because there is no frictional force in this case. So F net will simply be equal to mg sine theta, mg sine 45 degree. Okay, there is no frictional force. Now F net is equal to mass into acceleration, and this side we have mg sine 45 degree means 1 by root 2. M can get cancelled and the acceleration A will be equal to g by root 2. So can you see that the acceleration in case of rough surface is g by root 2 under bracket 1 minus mu k, whereas in case of smooth surface the acceleration is just g by root 2. Okay. Now we have got the acceleration. Now here you have to remember one formula, that is S equals to ut plus half at square. Right? You all would be remembering this formula. So what will be the value of u? U is 0 because the body started from rest, right? So ut will be 0. That means S will be equal to half at square. If we take 2 this side and a this side, what do we get? We'll get 2s by a equals to t square. So from here we can say that t square is proportional to or inversely proportional to a, or t is inversely proportional to root a. Okay, so this you have to keep in mind. Now, it is given in the question that the time taken by the body to slide down the rough surface, that is TR, is 2 times the time taken by the body to slide down the smooth surface, 2 times TS. Now, let's write the time T in terms of acceleration A. So, we have seen the relation between the time and acceleration. T is inversely proportional to root A. So, in place of TR, we can write 1 by root AR, where AR is the acceleration in case of rough surface. And in case of TS, we can write 1 by root AS. So 2 times 1 by root AS. So if we find the square on both the sides, we will get 1 by AR equals to 4 by AS. So AS by AR will be equal to 4. Okay. AS by AR is equal to 4. Now, in the beginning, we had seen that the acceleration in case of smooth surface, that is AS, was equal to g by root 2, and the acceleration in case of rough surface was g by root 2 1 minus mu. So we can put these values here. So let's write it down here. G by root 2 upon g by root 2 1 minus mu equals to 4, right? Now g and by root 2 can get cancelled. Here we'll get 1 by 1 minus mu equals to 4. We can take 1 by mu this side. So 1 equals to 4 minus 4 mu. Okay, if we open the bracket, we will get this. So from here we can say that 4 mu will be equal to 3. So what will be the value of mu k? Here you can write mu or you can write mu k, both are same because we are talking about the coefficient of kinetic friction. So mu k will be equal to 3 by 4. And what will be the value of 3 by 4? It is equal to 0.75. So we have got the value of mu k, that is coefficient of kinetic friction. It is 0.75. So let's have a look at the options. It is given in the second option. Option B will be the correct answer. Next question. A full wave rectifier circuit with diodes D1 and D2 is shown in the figure. If input supply voltage V input is equal to 220 sine 100 pi t volt, then at time t equals to 15 millisecond, we have to check whether the diodes are forward bias or reverse bias, or which diode is forward bias and which is reverse bias. Okay. So what is given here? V equals to 220 sine 100 pi t. And what is the general equation for AC voltage? V is equal to V naught sine omega t, right? This is the general equation. So if we compare these two equations, we can say that the value of omega is 100 pi. Okay, omega is equal to 100 pi, and omega is equal to 2 pi by t, where t is the time period. 2 pi by t is equal to 100 pi. So from here pi can get cancelled, and we can say that t is equal to 2 by 100, that is 0.02 seconds. So what is 0.02 seconds? Time period. Okay, capital T. So we are using capital T for time period. And in the question it is given that at time 15 milliseconds. So small t, the time is given 15 millisecond. That means 15 millisecond means 0.015 seconds. Okay. So we have to find which diode will be forward bias and which will be reverse bias at time equals to 0.015 second. Okay. So if we find small t by capital T, that will be equal to 0.015 second upon what is capital T time period, 0.02 seconds. Okay. So let's solve this. Here we'll get 15 by 200 by 1000. Okay, if we remove the decimal, these are the values that we will get, and two zeros will get cancelled. 15 by 20, that means 3 by 4. So small t by capital T is equal to 3 by 4 or 0.75. So small t is equal to 0.75 times the capital T, 0.75 times the time period. Okay. Now we have to check the bias of the diodes. Okay, so suppose this is one cycle, one AC cycle. Okay, so we know that this is 0 time and this is time t. Then from 0 to time 0.5 t, this is a 0.5 t, half of the time. From 0 to 0.5 t, D1 will be forward bias and D2 will be reverse bias. Okay, and from 0.5 t to time t, D1 will be reverse bias and D2 will be forward bias, just opposite. Okay. So here we have got that the time t is equal to 0.75 times the time period. So where does 0.75 lie? It lies between 0.5 to t. Okay. It lies in this region. 0.75 lies in this region, and we know that in this region D1 will be reverse bias and D2 will be forward bias. So it is given in the last option. D1 is reverse bias, D2 is forward bias. Option D will be the correct answer. Next question says a uniform rod of mass 20 kg and length 5 meter leans against a smooth vertical wall making an angle of 60 degree with it. The other end rests on a rough horizontal floor. The frictional force that the floor exerts on the rod is. Okay. So let's understand this question with the help of a diagram, because it's very important to understand the diagram in physics. Suppose this is the smooth vertical wall. This is the rough horizontal floor. Okay. The wall is smooth, that means there will be no frictional force along the wall, and the floor is rough, so there will be frictional force along this floor. There is a uniform rod. So suppose these dotted lines represent the rod. So the rod has the mass 20 kg. So M is equal to 20 kg. and length L is equal to 5 meter. This rod leans along this wall or against this wall, making an angle 60° with the wall. So this angle is 60°. This angle will be 90°, the angle between the wall and the floor. So what will be this angle? This will be equal to 30°, because the sum of all the angles should be 180° in a triangle. Let's say this is point A, this is point B, and this is point C. So ABC is actually a right angle triangle with the length of the hypotenuse 5 meter. Okay, here the length of the rod is actually the length of the hypotenuse of this triangle. So hypotenuse is 5 meter. Now here you should remember one thing, that in a right angle triangle, if we know the length of hypotenuse and the angle theta, then we can find out the base as well as perpendicular. Okay, what is the formula for base? Base will be equal to hypotenuse into cos theta, and perpendicular will be equal to hypotenuse into sine theta. Okay, so this you have to remember. We will be using this at last. So first we will see what are the forces that are acting on the rod. So forces acting on the rod, suppose this is the rod, we have this point A, this is point B. Okay, so what are the forces that are acting at point A? There will be a normal force in the upward direction. Let's say this is N1 force, and then the rod will have the tendency to slide down towards right side. So there will be a frictional force along left side that will be opposing this motion. Okay, so at point A there will be an upward force N1 and a force along the left side, that is frictional force. Then at the center of the rod, the weight of the rod, that means mg, will be acting downward. And at point B, the wall will be acting as the base, so the normal force will be in this direction, that will be N2. Okay, there will be no frictional force at this point because the wall is smooth, not rough. So these are the forces that are acting on the rod. N1 in the upward direction, frictional force in the left direction, N2 in the right direction, and mg in the downward direction. Okay, so what are the vertical forces here? N1 and mg are the vertical forces, whereas N2 and frictional force are the horizontal forces. Now we want this system to be in equilibrium. We want the rod to be in its original position. So for that, equilibrium has to be maintained. Now two types of equilibrium are important here: translational equilibrium as well as the rotational equilibrium. So let's discuss the translational equilibrium first. Translational equilibrium, and this side we will discuss the rotational equilibrium. Okay, rotational equilibrium. For translational equilibrium, it is important that the vertical forces and the horizontal forces must be balanced. Okay, so vertical forces, what are the vertical forces? N1 and mg. So N1 should balance mg and vice versa. So N1 should be equal to mg. What about the horizontal forces? There are two horizontal forces, the frictional force in the left direction and N2 force in the right direction. So N2 should be balanced by the frictional force. So from here we can say that N1 is equal to mg. We can find the value of N1 simply by putting the values of m and g, and N2 should be equal to frictional force. We have to find out the frictional force in this question. So if we are able to find the value of N2, then we will also get the frictional force because both are equal, right? Now about the rotational equilibrium. So what is the condition for rotational equilibrium? The net torque should be 0. Okay, that means the torques should balance each other or cancel each other out. Okay, so the net torque should be equal to 0 for rotational equilibrium. That means the torque about point A should be equal to torque along point B. Now what is the torque along point A? We know that the torque is equal to force into R. Okay, F into R. So look at the point A in this diagram. Here we will understand this. There is a downward force mg acting in the middle of the rod, right? So let's connect these points. Suppose this is point O. So here we have a small triangle this side. Okay, this is a small triangle. Here we have to focus at this point. What is the force at point A? It is N1. Okay, the force at point A is N1. And what is R? R will be the distance OA. OA. Now how do we find the distance OA? We know that when we have hypotenuse and theta, then we can find out the base. This OA is the base here. and base is equal to h cos theta, we have discussed. Now what is the hypotenuse? The total length of the rod is 5 meter. So this half of the length will be 5 by 2. So hypotenuse will be equal to L by 2. Okay, L by 2 and cos theta. So 30 degree is the theta here. So L by 2 cos 30 degree will be the length of OA. Okay, so let's write these values in torque. Force into the distance OA. So force is N1 into the distance OA is L by 2 cos 30 degree. You understood? How do we find the base? Hypotenuse into cos theta. So here hypotenuse will be half the length of the rod. So L by 2 and theta is 30 degree. So cos 30 degree. This side torque at point B. If we consider torque at point B, then we have to consider this complete triangle. For that triangle, the base is BC. Okay. So here the base is BC. So that will be equal to hypotenuse into cos 60 degree. So hypotenuse is the complete length in this case, okay, because we are considering the complete triangle. So L, first of all, we'll write the force, right? So force is N2 at this point. At point B, the force is N2 into the distance BC will be equal to the hypotenuse length L into cos 60 degree. Cos 60 degree. Okay. So here N1 into L by 2 cos 30 degrees root 3 by 2, and this side we have N2 into L, and cos 60 degree is half. So some things can be cancelled out. L can be cancelled out, half can be cancelled out. So what is left here? N1 this side into root 3 by 2 is equal to N2. We have to find the value of N2. So N2 is equal to what? Root 3 by 2 N1. And in the translational equilibrium, we saw that the N1 should be equal to mg. So in place of N1, we can write mg. So root 3 by 2 into mg. M is the mass, that is 20 kg, and g is the acceleration due to gravity, that is 10 meter per second square. Okay. So now we can cancel them. 2 into 10 is 20. Now 10 into 10, 100. So that will be equal to 100 root 3. So from here we can say that N2 is equal to 100 root 3, and we know that N2 is equal to the frictional force. So the frictional force will be equal to 100 root 3. It is given in the last option. Option D will be the correct answer. 100 root 3 Newton. Next question is, two identical charged conducting spheres A and B have their centers separated by a certain distance. Charge on each sphere is Q and the force of repulsion between them is F. A third identical uncharged conducting sphere is brought in contact with sphere A first and then with B and finally removed from both. New force of repulsion between the spheres A and B is best given as. Okay, and we have to assume them as point charges. So what is given in the question? We have 2 point charges. Suppose this is charge A and this is charge B. Suppose the distance between them is R. Charge on each of the charges is Q. Okay, they are having same charge, that is equal to Q. What will be the force of repulsion? The formula is K into Q1 Q2 by R square, right? So K, which is a constant, into the product of charges, that means Q into Q, divided by the square of distance between them, R square. So F will be equal to KQ square upon R square. This is the force of repulsion. Okay. Then what happens? A third identical uncharged conducting sphere is brought in contact with A. So this is an uncharged conducting sphere. It is brought in contact with A. So what will happen? Initially this third uncharged conducting sphere had zero charge, right? Because it was uncharged, so the charge was zero. When it comes in contact with charge A, what will happen? The charge of A will be divided into both these conductors equally. Okay, so now the point charge A will have the charge Q by 2 and the third conductor will also have the charge Q by 2. Okay, so now it has Q by 2. Now this conducting sphere comes in contact with point B. So now it has already a charge of Q by 2. Then it comes with point B which has charge Q. So again they will be shared equally between them. So the third conductor had charge Q by 2. Then the point B has charge Q. Okay, so the total charge will be what? 3 by 2Q. Now this 3 by 2q charge will be divided equally between these two. So 3 by 2q divided by 2 will be equal to 3 by 4q. So now point B will have the charge 3 by 4q. Got it? So now what will be the force of repulsion? The new force of repulsion, let's say F dash, will be equal to K into the product of charges, that means q by 2 into 3 by 4q divided by the square of distance between them, so r square. Okay, the distance will remain same. So here we get k 3 kq square by 8 r square. Okay, this is the new force of repulsion. So F by F dash will be equal to kq square by r square divided by 3kq square by 8r square. So r square will get cancelled. Q square and k will also get cancelled. So here we will get 8 by 3. So F by F dash is equal to 8 by 3. So F dash, that is the new repulsive force, will be equal to 3 by 8F. Okay, 3 by 8 times the initial force of repulsion. So it will be 3 by 8F. Option B will be the correct answer. Next question is, two cities X and Y are connected by a regular bus service with a bus leaving in either direction every T minutes. A girl is driving scooty with a speed of 60 km per hour in the direction X to Y. Notices that a bus goes past her every 30 minutes in the direction of her motion and every 10 minutes in the opposite direction. Choose the correct option for the period T of the bus service and the speed of the buses. We have to assume that the speed of the buses are constant. So there are two cities, city X and city Y. These two cities are connected by regular bus service. That means buses are continuously moving between these two cities in both the directions. Okay. The bus leaves in either direction after every T minutes. Then there is a girl who's driving a scooty. Suppose the scooty is somewhere here. The speed of the scooty is 60 km per hour. And the girl who is driving the scooty in the direction X to Y notices that the buses which are coming in the same direction, that means from X to Y, cross her after every 30 minutes. Whereas the buses which are coming from the opposite direction, that means from Y to X, these buses cross her scooty after every 10 minutes. Okay. So we have to find the velocity of the bus and the time after which the bus leaves in either direction. So let's assume that the velocity of the bus is v km per hour. What is the velocity of the scooty? Velocity of the scooty is 60 km per hour. And we assume that the velocity of the bus is v km per hour. So what will be the relative velocity of the bus with respect to the scooty? Relative velocity of the bus with respect to the scooty. So it will be v minus 60 km per hour when both the bus and the scooty are moving in the same direction. Okay, so this is the case when they are moving in the same direction. But when they are moving in opposite direction, in that case the relative velocity will be equal to v minus 60. That is v plus 60 km per hour. Okay. This is the case when they are moving in opposite direction. So in both the situations, the relative velocity will be different. Now what will be the distance? We know that the formula for distance is velocity into time. So distance between two consecutive buses will be Vt, that means velocity of the bus into the time after which the bus leaves in either direction, equals to the relative velocity of the bus and the scooty and the time after which they cross each other. So relative velocity, that is v minus 60, into the time after which they cross each other, 30 minutes. Okay. So we have seen in the beginning that when they are moving in the same direction, then they are crossing each other after every 30 minutes. Okay, and in that case the relative velocity is v minus 60. There was another situation when they were moving opposite to each other. In that case vt will be equal to v plus 60 because the relative velocity was v plus 60, and after what time they were crossing each other? 10 minutes. So into 10 minutes. Okay, so these two situations are there. In the first case vt is equal to v minus 60 into 30, and in the second case vt is equal to v plus 60 into 10. So vt is same, that means both the equations are equal, so we can equate them. V minus 60 into 30 equals to v plus 60 into 10. Here we can get the value of v. Okay, 0 will get cancelled. This side we have 3v minus 180 equals to this side v plus 60. So 3v minus v equals to 60 plus 180. So 2v equals to 240. So from here we can say that the velocity will be equal to 240 divided by 2, that is 120. And the unit for velocity will be kilometer per hour. So the velocity is 120 kilometer per hour. Now here 120 kilometer per hour is given in the second option. So the second option should be correct, but we will check for the time as well. So how do we find the time? So we can put the value of v in any one of the equations. Okay, let's take this first equation. Vt equals to v minus 60 into 30. What is the value of v? 120 kilometer per hour. So let's put that value. 120 into t equals to again 120 minus 60 into 30. Okay, this 0 can get cancelled, and 3 into 4 is 12. So we can say that 4t is equal to 120 minus 60, that is 60. So t will be equal to 60 divided by 4. So here we'll get 15. 15 minutes will be the time after which a bus leaves in either direction. So the velocity is 120 kilometer per hour and the time is 15 minutes. So let's check. It is given in the second option. Okay, option B will be the correct answer. Next question, a container has two chambers of volumes V1 equals to 2 liter and V2 equals to 3 liters, separated by a partition made of thermal insulator. The chambers contain N1 equals to 5 and N2 equals to 4 moles of ideal gas at pressure P1 equals to 1 atmosphere and P2 equals to 2 atmosphere respectively. When the partition is removed, the mixture attains an equilibrium pressure of. So we have a container. Okay, suppose this is the container. There is a partition in between. On one side we have gas with volume V1 equals to 2 liter. Then N1, that is number of moles, is 5 and the pressure P1 is 1 atmosphere. On the other side, the volume of the gas is 3 liters. The number of moles N2 is 4 moles and the pressure P2 is 2 atmosphere. Okay, now it is asked that when the partition will be removed, then what will be the pressure of the mixture. Okay, so suppose the pressure of the mixture is P. Okay, and the new volume is V. So what will be the total volume of the mixture? Volume of the mixture will be V1 plus V2, right? So that will be equal to 2 liters plus 3 liters, that means 5 liters. So this will be the final volume of the mixture. We have to find the pressure of the mixture. Now here we have to assume that the temperature is constant. Okay, because only if we assume that temperature is constant, then we will be able to solve this question. Otherwise we cannot come to any solution. So since the temperature is constant, also the partition is made up of a thermal insulator. So again the temperature is constant. That means the case is isothermal. This situation is for isothermal situation. Okay, that means PV will be constant. We know that in case of isothermal condition, the value of PV is constant. So P1 V1 plus P2 V2 will be equal to P V1 plus V2, right? P1 is 1 atmosphere, V1 is 2 liters plus P2 is 2 atmosphere and V2 volume 2 is 3 liters. This side, pressure of the mixture we have to find out, and V1 plus V2 is 5 liters, right? 2 plus 3, 5. So we just have to solve it. 2 plus 6 equals to 5p. So 8 equals to 5p. So what will be the value of p? It will be equal to 8 divided by 5. That means 1.6 atmosphere. Pressure of the mixture will be 1.6 atmosphere. So option D will be the correct answer. Next question. De Broglie wavelength of an electron orbiting in the n equals to 2 state of hydrogen atom is close to. Bohr radius is given 0.052 nanometer. So we know that the radius of the nth orbit is given by the formula 0.052, that is Bohr radius, into n square. Okay, so let's find this out. 0.052 into n square, n is equal to 2 here. So 2 square is 4. So on solving this, we will get 0.208 nanometer. This is the radius of the nth orbit. Okay. Now we have to find out the wavelength, de Broglie wavelength. We know that the de Broglie wavelength fits the circumference of the orbit. So for example, this is the orbit of the electron. So wavelength is like this. This wavelength fits the circumference of the orbit. That means the wavelength, de Broglie wavelength, is directly related to the circumference or the radius of the orbit. Okay. So n into lambda is equal to 2 pi r. This is the formula. Okay. Here r is the radius of the nth orbit. So we can write Rn that we have calculated here. We have to find out the lambda. So lambda is equal to 2 pi Rn divided by n. Simply we have to put the values. So 2 into 3.14 into the radius of the nth orbit that we have calculated 0.208 divided by n. What is the value of n here? 2. So 2 can get cancelled. Simply 3.14 into 0.208. What do we get? We'll get 0.653 nanometer. So 0.653 is not given in the question. 0.67 is given. So we can say that this is approximately equal to 0.67 nanometer. So according to this, option D will be the correct answer. Next question is, to an AC power supply of 220 volt at 50 Hz, a resistor of 20 ohm, a capacitor of reactance 25 ohm and an inductor of inductance 45 ohm are connected in series. The corresponding current in the circuit and the phase angle between the current and the voltage is respectively. So basically this is an LCR circuit, okay, LCR, because inductor, capacitor and resistor all are present. These are connected in series. So the circuit will be something like this: inductor here, then the capacitor, and then the resistor. Okay. Then these are connected to an AC source. So we have an AC source here. The current will be flowing through this AC. This is inductor, this is capacitor, this is resistor. Now it is given that the resistor is of 20 ohms. So the resistance is equal to 20 ohm. Then the capacitor of reactance 25 ohm. So the reactance of the capacitor XC is equal to 25 ohm, and the reactance of inductor, that is XL, is 45 ohm. Right. So what is the formula for impedance? Impedance Z is equal to under root R square plus XL minus XC whole square. Right. So let's put the values. Under root resistance is 20 ohm, so 20 square, plus XL is 45 minus XC is 25 whole square. Okay. Under root square of 20 is 400, plus 45 minus 25 will be 20. So again square of 20, that is 400. So here we'll get under root 800, which will be equal to 20 root 2 ohm. So the impedance is 20 root 2 ohm. What we have to find out? We have to find out the current in the circuit and the phase angle. So for the current I, we can use the formula voltage by resistance. So here in place of resistance, we will have the impedance. Okay. Voltage is given 220 volt and the impedance we have calculated 20 root 2 ohm. Okay, so 2 will get cancelled, 0 will get cancelled, and 2 into 11 is 22. So 11 by root 2, the value of root 2 is 1.41. So if you solve this, you will get nearly 7.78 ampere. So the current is 7.78 ampere, or we can say 7.8 ampere. So it is given in option C and option D. Both have 7.8 ampere currents. So either C or D will be the correct answer. A and B are eliminated. Now we have to find the phase angle. So again, we have a simple formula to find the phase angle. We know that tan phi, where phi is the phase angle, is equal to XL minus XC divided by R. Okay, so tan phi will be equal to, what is the value of XL? XL was 45 and XC was 25 divided by the resistance, that is 20. So 45 minus 25 is 20 and upon 20. So here we'll get 1. Tan phi is equal to 1. So the value of phi should be 45 degree because tan 45 degree is 1. Okay. So the current is 7.8 ampere and the phase angle is 45 degree. So let's see, it is given in the last option. Option D will be the correct answer. Next question is, which of the following options represent the variation of photoelectric current with property of light shown on the x-axis? So let's have a look at the first graph. It is showing the relation between photoelectric current and intensity of the light, and this is a correct graph, okay, because photoelectric current is directly proportional to the intensity of the light. Actually, the photoelectric current directly depends on the number of photons, okay, number of photons hitting the material, hitting the material. And we know that more the number of photons, more will be the intensity of the light. So we can say that the photoelectric current is directly proportional to the intensity of the light. So this is absolutely correct graph. Now in the second graph, it is shown that the intensity is increasing, but the photoelectric current is constant. So if the intensity of light is increasing, then the photoelectric current should also increase. It cannot remain constant. So this is incorrect graph. In the third one, there is a relation between photoelectric current and frequency of the light. So this is incorrect because there is no such relation between photoelectric current and frequency. In the last graph also, the relation between current and frequency is shown, which is incorrect. So what is the role of frequency? There is only a small role of frequency here. There is a threshold frequency below which no photoelectric effect will be seen. Okay, only when the threshold frequency is reached, then photoelectric current can be observed. Okay, so but after this threshold frequency is reached, there is no relation between the current and the frequency. Okay, so only one graph is correct, that is the first one, A only. So option C, A only, will be the correct answer. Next question is related to wave optics, and the question is, a pipe open at both ends has a fundamental frequency f in the air. The pipe is now dipped vertically in water drum to half of its length. The fundamental frequency of the air column is now equal to. So there are two situations. Initially there was an open pipe, okay. So a pipe like this. This is an open pipe. So what is the fundamental frequency of an open pipe? Open pipe, it is equal to V by 2L, V by 2L, right? Now, this open pipe is dipped vertically in water. So suppose this is the water, this is the water. When this pipe is dipped vertically like this, then this open pipe will start behaving like closed pipe, okay? Because one end, the lower end of the pipe, will get closed by water, okay? And what is the length here? L by 2, okay? Because half of the length is immersed in water, so only L by 2 will be above the water. So what is the fundamental frequency? Let's say F dash for a closed pipe. For the closed pipe, so the formula is V by 4L, right? So V by 4L, but this time the L is L by 2. So in place of L, we'll write L by 2, which will again become V by 2L. Okay, so you can see in both the cases the frequency comes to be same, equal, V by 2L. So we can say that the F is equal to F dash. Okay, both the frequency are same. So it will be equal to F only. Option D will be the correct answer. Next question is related to spring mass system, and the question is two identical point masses P and Q suspended from two separate massless springs of spring constants K1 and K2 respectively oscillate vertically. If their maximum speeds are the same, the ratio AQ by AP of the amplitude AQ of mass Q to the amplitude AP of mass P is. So we have two massless springs. Suppose this is spring 1, this is spring 2. Point masses are suspended from these springs. This is point mass P and this is point mass Q, right? What will be the amplitude? The amplitude of the mass P, it will be AP, and the amplitude of mass Q is AQ. We have to find the ratio AQ of AQ and AP, right? Now it is given in the question that the maximum speed is same. Their maximum speed or maximum velocity is same. What is the formula for maximum velocity? It is A omega. So A omega is same. That means AP omega P is equal to AQ omega Q, right? So AQ by AP by AP will be equal to omega P by omega Q. But here we have to write the ratio in terms of K1 and K2, not omega P and omega Q. So we know that the omega is equal to under root K by M, right? So omega P will be equal to under root K1 by MP, or we know that the mass of both P and Q are same because these are point masses. So simply we can write M. So so omega P will be equal to under root K1 by M, and similarly omega Q will be equal to under root K2 by M. Okay, because the spring constants are K1 and K2 respectively. So let's put these values here. In place of omega P we can write under root K1 by M, and in place of omega Q we can write under root K2 by M. So here we'll get M by K2 because this has to be divided. Okay, so M will get cancelled. What will be left? Under root K1 by K2. So AQ by AP is equal to K1 under root K1 by K2. So let's see, it is given in the second option. Option B will be the correct answer. Next question is from semiconductor electronics, and the question is the output Y of the given logic implementation is similar to the output of a dash gate. Okay, so here we can see we have a NOR gate first, then below the NOR gate we have a NAND gate. Let's say that the output coming out from the NOR gate is Y1 and the output coming out from the NAND gate is Y2. Then we can see that these Y1 and Y2 are entering an AND gate, and we get the final output Y. So we have to find the final output Y. Okay, so Y1 and Y2 are entering into the AND gate. So obviously the final output Y will be equal to Y1 dot Y2, isn't it? Now what will be the Y1? It is coming out from NOR gate. So for OR we write A plus B. So for NOR it will be A plus B bar. Similarly, what will be Y2? For AND gate we write A dot B, right? So for NAND we will write A dot B bar. Now the final output Y will be the product of Y1 and Y2, Y1 dot Y2, because this is an AND gate. So let's put the values here. Y1 is equal to A plus B bar and Y2 is equal to A dot B bar. Now we have to multiply them. So how can we multiply them? In order to multiply, we will have to break the bars. Okay. So according to the rule, if we break A plus B whole bar, then we will get A bar dot B bar. Okay. Similarly, if we break A dot B whole bar, then we will get A bar plus B bar. So plus will change into dot and vice versa. Okay. So let's break them. A plus B whole bar will change into A bar dot B bar, into this will change into A bar plus B bar, right? Now we can easily multiply them. So if we multiply A bar dot B bar with A, we will get A bar, B bar, A bar. Okay. Plus now we will multiply it with B. So A bar, B bar, B bar. So in the first one we get A bar 2 times, in the second one we get B bar 2 times. Now according to the rule, if we multiply A bar with A bar, we will get A bar only. Okay, same. Similarly, if we multiply B bar with B bar, we will get B bar. This is the rule that you have to remember. So A bar into A bar will become A bar only. So A bar B bar, plus this side again B bar into B bar will become B bar. So A bar B bar. So we have got A bar B bar plus A bar B bar. This can be written as A bar dot B bar. And it can also be written as A plus B whole bar. Okay, so this is the final output. Now which gate it is related to? We know that A plus B is written for OR gate, right? So A plus B bar is written for NOR gate. So the output is similar to that of a NOR gate. So let's have a look at the options. Second option, NOR, will be the correct answer. Next question is, an oxygen cylinder of volume 30 liter has 18.20 moles of oxygen. After some oxygen is withdrawn from the cylinder, its gauge pressure drops to 11 atmospheric pressures at temperature 27 degrees Celsius. The mass of oxygen withdrawn from the cylinder is nearly equal to. The value of R is given, molecular mass of oxygen is given, and 1 atmospheric pressure is equal to 1.01 into 10 to the power 5 Newton per meter. Okay. So we will be using the formula PV equals to nRT to get the number of moles that are left in the cylinder. Okay. So number of moles will be equal to PV by RT. Now what will be the pressure? Here we will be using the absolute pressure. Okay. So absolute pressure P will be equal to the gauge pressure plus the atmospheric pressure. Okay. Gauge pressure is given as 11 atmospheric pressure. So 11 atm, and atmospheric pressure is 1 atm. Okay. So total will be 12 atmospheric pressure. But here we will be using the unit Newton per meter for pressure. So it is given 1 atmospheric pressure equals to 1.01 into 10 to the power 5 Newton per meter. So the pressure will be 12 into 1.01 into 10 to the power 5 Newton per meter. So this we will be using in place of pressure. So let's put this value here, 12 into 1.01 into 10 to the power 5 into the volume. What is the volume? It is 30 liter. Again we will convert the volume into meter cube. Okay, we know that 1 liter is equal to 10 to the power minus 3 meter cube. So 30 liters will be equal to 30 into 10 to the power minus 3 meter cube. Okay, divided by R. What is the value of R? It is given 100 by 12 joule per mole per Kelvin. So 100 by 12, 100 and 12 will come on the numerator side. Then we have temperature T. So temperature is given as 27 degrees Celsius. We will convert it into Kelvin. So it will be 27 plus 273 Kelvin, that is 300 Kelvin. So in place of temperature we will write 300. Now you just have to solve it to get the number of moles that are left in the cylinder. So here you will get 14.54 moles. Okay, you can try to solve it yourself. I am not solving it here. I am writing the answer only. So 14.54 moles. Actually you will get 1454.4 into 10 to the power minus 2. Okay, so that will be equal to 14.54 moles. Now this is the number of moles of oxygen that is left in the cylinder. So initial number of moles that is given in the question is 18.20, I think. Let's check. It was, yes, 18.20 moles of oxygen. Now the final number of moles is 14.54. So how many moles are removed? Number of moles removed is initial number of moles minus final number of moles. That means 18.20 minus 14.54. So here you will get around 3.66 moles. Okay. So this is the number of moles of the oxygen gas removed, but we have to find the mass of oxygen removed. So we will convert this number of moles into mass. So mass will be equal to number of moles into the molecular mass of the oxygen. Number of moles is 3.66 and molecular mass of oxygen is 32. So here you will get around 117.12 grams. Okay. And in the options, the unit is kg, not grams. Okay. So we will convert this into kg again. That means we will divide it by 1000. Okay. So equals to 117.12 divided by 1000 kg. That will be equal to 0.117 kg. So if this exact answer is not given, then we can write the nearest answer, 0.117. So which answer is nearest to it? 0.116 kg. This is the nearest answer. So option A will be the correct answer. Next question is from optics, and the question is, in a certain camera, a combination of four similar thin convex lenses are arranged axially in contact. Then the power of the combination and the total magnification in comparison to the power P and magnification M for each lens will be respectively. So it is given that there are four similar convex lenses and they are arranged axially. That means there is series combination of the lenses. Series combination. And we know that for series combination of the lenses, the effective power will be the sum of all the powers, P1 plus P2 plus P3 plus P4. Now they are similar, that means they have the same power. So it will be P plus P plus P plus P, that means 4P. So this will be the power. And what will be the effective magnification? That will be the products of all the magnifications. So M1 into M2 into M3 into M4. Again, these are identical, so the magnification is also same. So M1 into M2 into M3 into M4 will be equal to M to the power 4. So power is 4P and magnification is M to the power 4, which is given in the first option. So option A will be the correct answer. Next question is from thermodynamics, and the question is, two gases A and B are filled at the same pressure in separate cylinders with movable pistons of radius RA and RB respectively. On supplying an equal amount of heat to both the systems reversibly under constant pressure, the pistons of gas A and B are displaced by 16 centimeter and 9 centimeter respectively. If the change in their internal energy is same, then the ratio RA by RB is equal to. So we have two separate cylinders. Okay, suppose this is cylinder 1 and this is cylinder 2. Different gases are filled. Gas A is filled in the first cylinder and gas B is filled in the second cylinder. Okay, these cylinders have a movable piston. Okay, suppose this is the piston. And the radius of the piston is RA and RB. For the first one, the radius is RA and the radius of the second piston of the second cylinder is RB. Now an equal amount of heat is supplied. So first it is given that the gases are at same pressure. So pressure is same, right? That means PA is equal to PB. Then equal amount of heat is supplied to both the systems. That means delta Q will be same. What else is given? Internal energy is also same. It is given in the last line of the question. So delta U, that is internal energy, is also same. So these things are same. What are the distance which are moved? So for the first one, it is 16 centimeter. 16 centimeter is the distance for A, and the distance moved by the molecules of B will be 9 centimeter. Okay, because the pistons are displaced by these distances. That means these are the distances that are traveled by the molecules. Now let's use the first law of thermodynamics. So using the first law of thermodynamics, we can say that delta Q is equal to delta U plus the work done. Okay, delta Q is the heat, delta U is the internal energy, and W is the work done. Now here it is given that delta Q is same and delta U is same. That means work done will also be same. So work done in case of A will be equal to work done in case of B. Okay, since delta Q and delta U are same. Now work done is equal to P delta V. So for work done in case of A, we can write P delta V A will be equal to work done in case of B, that means P delta V B. Again, pressure is also same. It is given in the question, pressure is same. So delta VA will be equal to delta VB because the pressure is same. Now what will be the volume? We know that the volume is equal to the cross-sectional area into the distance traveled by the molecules. Okay, so delta VA is equal to area, cross-sectional area of A into the distance traveled by the molecules of A equals to delta VB, means the cross-sectional area of B into the distance traveled by the molecules in B. Okay. Now area is equal to pi r square, so pi r A square into dA is equal to pi rb square into dB. I hope you understood what is RA and RB. RA is the radius of the piston of cylinder A and RB is the radius of the piston of cylinder B. We have to find the ratio of these two. Okay, we have to find the ratio RA by RB. And dA is the distance traveled by the molecules of gas A and dB is the distance traveled by the molecule of gas B. Now here pi can get cancelled. So RA square by RB square will be equal to dB by dA. What is the dB? That is distance traveled by the molecules in B. It is given in the question. That is the same distance that is moved by the piston. Okay, so 9 centimeter in case of B and 16 centimeter in case of A. So here we'll write 9 by 16. So this is the RA square by RB square, but we have to find RA by RB. So this will be equal to under root 9 by 16. That means 3 by 4. Okay, so 3 by 4, is it given in the options? Yes, it is given in the last option. So option D will be the correct answer. Next question is from the chapter Units and Dimension, and the question is: a balloon is made of a material of surface tension S and its inflation outlet from where the gas is filled in it has small area A. It is filled with a gas of density rho and takes a spherical shape of radius r. When the gas is allowed to flow freely out of it, its radius r changes from r to 0 in time t. If the speed v of the gas coming out of the balloon depends on r as r to the power alpha and t is proportional to s to the power alpha, a to the power beta, rho to the power gamma and r to the power delta, then. So basically here in this expression, S is the surface tension, A is the area, rho is the density and r is the radius, right? We have to find the value of alpha, beta, gamma and delta. So what is given here? T is proportional to S to the power alpha, A to the power beta, rho to the power gamma and r to the power delta. Now what is the dimension of surface tension? S is equal to force by length. Okay, force per unit length. So force is mlt minus 2. The dimension of force is mlt minus 2 and the dimension of L is L. Okay, so L will get cancelled out. It will be mt minus 2. So here we can write that the dimension of time is m0 L0 t1 and it is proportional to s to the power alpha. What is the dimension of s? mt minus 2 we have seen right now. This to the power alpha. Then area to the power beta. Okay, area has the dimension L2 or L square. So this to the power beta. Then rho is the density. So we know that density is equal to mass by volume. So mass has the dimension m, volume has the dimension L cube. So the dimension of density will be ml to the power minus 3, right? So ml to the power minus 3 to the power gamma. And at last we have the radius r whose dimension is L. So L to the power delta. Okay, so this is already given in the question. Now let's solve them further. On the left side we have m0 L0 t1. On the right side we have mt to the power minus 2 to the power gamma. So let's open the brackets. We will get m to the power gamma t to the power minus, m to the power alpha into t to the power minus 2 alpha. Then L square to the power beta, that means L to the power 2 beta. Then here, if we open this one, third one, we get m to the power gamma into L to the power minus 3 gamma. And at last we have L to the power delta. So we can bring m together, L together and t together. Okay, so how many m are there? One m this side and the other m this side. So m to the power alpha plus gamma into L to the power 2 beta minus 3 gamma. 2 beta minus 3 gamma into t to the power minus 2 alpha. Okay, and this side we have m0 L0 t to the power 1. Now we can equate them and then we can find out the value of alpha, beta and gamma. Look at the dimension of time. So for time t, on the left hand side we have t to the power 1 and on the right hand side we have t to the power minus 2 alpha. That means minus 2 alpha will be equal to 1. So what will be the value of alpha? Alpha will be equal to minus 1 by 2. So now we have got the value of alpha, that is minus half. Now minus half is given in the first option, right? In the second option it is plus half, so it is not the correct answer. In the third option again plus half, and in the last option minus half. So minus half is given in the first and the fourth option. So either option A will be correct or option D will be correct. Let's check for other quantities. Now let's have a look at the mass, the dimension of mass. On the left side the dimension of mass is 0, or on the right side the dimension of mass is m to the power alpha plus gamma. Okay, that means alpha plus gamma will be equal to 0, right? So gamma will be equal to minus alpha, and we know that alpha is equal to minus half, so this will be equal to minus into minus half, that is plus half. Okay, so gamma is equal to plus half. Now out of A and D, in which one gamma is equal to plus half? In the first option gamma is plus half. In the last option it is minus half, so it is incorrect. So now only we have understood that option A is the correct answer. Okay, now if you try to find out the value of beta and delta, you will not be able to do that, because in the dimension of L both beta and delta are given and both are unknown. So you will not be able to find out the value of beta or delta. We have just got the value of alpha, that is minus half, and that of gamma, that is plus half. From here only we have found the correct answer. Now you can use hit and trial method by putting the values in the expression. Okay, for example, if we know that option A is the correct answer, so you can put the value of beta and delta that is given in option A in the expressions and check if it is correct. Okay, so option A will be the correct answer. Next question is, a bob of heavy mass m is suspended by a light string of length L. The bob is given a horizontal velocity v0 as shown in figure. If the string gets slack at some point P, making an angle theta from the horizontal, the ratio of the speed v of the bob at point P to its initial speed v0 is. So there is a bob whose mass is m and that bob is suspended by a light string of length L. Okay, the bob is given a horizontal velocity v0. So the initial velocity of the bob is v0. Okay, initial velocity is v0. And what is the final velocity? That means the velocity at point P. At point P it is v. We have to find the ratio of v and v0. Okay, what else is given here? At point P the string gets slack. That means the tension will become 0 at point P. And the string is making angle theta from the horizontal at point P. So let's see here. This is point O. This is point P. This is the string which gets slack at this point. This is the horizontal. The angle made by the string at this point is theta. This is the curved portion. So there will be a downward force acting on the bob. This is the bob, okay, at point P. There will be a downward force that will be equal to mg. What will be the components of the force? There will be an mg cos theta in this direction and mg sin theta in this direction. Okay. That means this OP will be equal to mg sin theta. Okay, mg sin theta will be acting inwards along the OP, right? Also, there will be a centrifugal force acting in the outward direction that will be equal to mv square by L. So here mg sin theta should balance out mv square by L. So we can write that at point P, mg sin theta should be equal to mv square by L. M will get cancelled. So we can say that G into L will be equal to V square by sin theta. Let's say this is equation number 1. We will be using this equation at some point to get the final answer. Okay. So G into L is equal to V square by sin theta. Another important thing that you have to note is that if this is the triangle at point P, this is point P, this is point O. This OP is equal to L. Okay. This is the length of the string. And here we have the angle theta. So here you can see that L is the hypotenuse of this triangle, right? So what will be the length, this vertical length? This will be equal to L sin theta. Okay, because for this right angle triangle, this is the perpendicular. So we know that if we know the length of the hypotenuse and the angle, then the perpendicular will be equal to L sin theta. Okay. Now let's use the conservation of mechanical energy. So by conservation of mechanical energy, the total energy should be conserved. That means at this lowest point, let's say this is point Q in this given diagram. So at point Q, the total energy at point Q, should be equal to the total energy at point P, right? At point P. Now at point Q, this is the lowest most point. So there will be kinetic energy only, no potential energy. Okay. So what will be the kinetic energy at point Q? It will be half mv0 square because the initial speed is v0. This side we have total energy at point P. So we know that at point P there will be kinetic energy as well as potential energy. So kinetic energy will be half mv square because the speed at this point is v, plus the potential energy. We know that the formula for potential energy is mgh, where h is the height. So here the height that we will measure is from the lowest most point to this point P. Okay. So this distance is L sin theta. Just now we saw perpendicular of this triangle L sin theta, and this length is L. So the height will be equal to L plus L sin theta. Okay, the total height. So mgh and h is equal to L plus L sin theta. Okay. Now we just have to solve them and then we will get the required answer. Okay. Here you can see that m will get cancelled. So this side we have v0 square by 2 and this side we have v square by 2 plus g into L plus L sin theta. Okay. Now let's solve it further. We can take L outside the bracket. So V0 square by 2 equals to V square by 2 plus GL, and under bracket we will have 1 plus sin theta. Okay. And in equation 1 we have saw that we have seen that GL is equal to V square by sin theta. Okay. At the beginning GL is equal to V square by sin theta. So we can put that value. This side we have V0 square by 2. This side V square by 2 plus V square by sin theta in place of GL, and this side we have 1 plus sin theta, right? Now we can open the bracket. So V0 square by 2 equals to V square by 2 plus, if we open this bracket, what do we get? V square by sin theta plus V square, because sin theta will get cancelled. Okay. So V0 square by 2 equals to V square by 2 plus V square will be equal to 3 by 2 V square. Okay. So 3 by 2 V square plus V square by sin theta. So here we can take V square by 2 common on the right hand side. Under bracket what will be left? 3 plus 2 by sin theta. Okay. So we have V naught square by 2 on the left hand side, and on the right hand side we have V square by 2, 3 plus 2 by sine theta. So the solution is lengthy, okay? It's not difficult, but it's lengthy. So half will get cancelled. This side we have V naught square, this side we have V square, and if you solve this part, we will have sine theta and 3 sine theta plus 2, right? So V naught square by V square will be equal to 3 sine theta plus 2 upon sine theta. But we have to find V by V naught, okay? So we have to reverse them. So V square by V naught square will be equal to the reverse of this, that means sine theta by 3 sine theta plus 2. But this side it is in square. So V by V naught will be equal to under root of sine theta by 3 sine theta plus 2. So let's check under root sine theta by 3 sine theta plus 2. It is given in the second option, okay? Under root means the power will be half, okay? So sine theta by 2 plus 3 sine theta, okay? In option D, it is 1 by 2 plus 3 sine theta. So this is incorrect because on the numerator side, we should have sine theta, okay? So option D is the correct answer. Next question is a physical quantity P is related to 4 observations A, B, C and D as follows. So this relation is given. According to this relation, P is directly proportional to A cube. So what is the power on A? It is 3. Then P is directly proportional to B square. What is the power on B? 2. Then P is inversely proportional to C. That means the power on C is 1. And P is inversely proportional to root D. Here we don't have to focus whether it is on the numerator side or denominator side, or whether it is directly proportional or inversely proportional. We just have to see what is the power on A, B, C and D. So A has the power 3, B has the power 2, C has the power 1 and D has the power half. Okay, because it is under root. So the power will be half. So these powers you have to keep in mind. Now we have to find the percentage error, maximum percentage error in P. So that will be equal to delta P by P into 100. This is the percentage error. Now if we write them in terms of A, B, C and D, then the percentage error will be 3 times the percentage error of A. That means delta A by A into 100 plus 2 times the percentage error of B plus 1 time the percentage error of C plus half times the percentage error of D. You understood why we wrote 3 times the percentage error of A? Because the power on A is 3. Okay. 2 times the percentage error of B because the power on B is 2. Okay. P is proportional to B square. Then only 1 times the percentage error of C because it is the power on C is 1. Similarly, the power on D was half. It was under root. So half times the percentage error of D. So 3 times the percentage error of A. What is the percentage error of A? It is 1%. So 3 into 1 plus 2 times the percentage error of B. What is the percentage error of B given? 3%. So 2 into 3 plus what is the percentage error of C? It is 2%. Okay. Percentage error of C is 2% plus half times the percentage error of D. Percentage error of D is 4. So half times 4. 2 into 2 is 4. So here we get 3 into 1 3 plus 3 into 2 6 plus 2 plus 2. So 6 plus 3 9 plus 11 plus 13. 13% will be the maximum percentage error in the pressure. So option A will be the correct answer. Next question is the sun rotates around its center once in 27 days. What will be the period of revolution if the sun were to expand to twice its present radius without any external influence? Assume the sun to be a sphere of uniform density. Okay, so it is given that the sun rotates around its center once in 27 days. It means the time period of the sun is 27 days. Okay. Then we have to assume that the sun is a sphere of uniform density. That means it is a solid sphere. We know that for a solid sphere, the moment of inertia I is equal to 2 by 5 mr square. So we have different formula for moment of inertia according to the shapes. So for solid sphere, it will be 2 by 5 mr square. Okay. It is also given in the question that the sun has to expand twice its present radius. That means if initial radius is r, then the new radius r dash will be 2 times the initial radius r. Okay. So if the new radius is 2r, then what will be the new moment of inertia I dash? That will be equal to 2 by 5 m into 2r square. Right. So let's use the conservation of angular momentum. According to the conservation of angular momentum, the angular momentum will remain same. Okay, the angular momentum will remain constant. What is the formula for angular momentum? It is equal to I into omega. I is the moment of inertia and omega is the angular velocity. So that will remain constant. So it means that I dash omega dash will be equal to I omega. I dash means new moment of inertia, omega dash means new angular velocity. So let's write down the values. The new moment of inertia is 2 by 5 m 2r square. And new omega is equal to 2 pi by t dash, because the omega is equal to 2 pi by t, right? This is the formula for omega. So 2 pi by t dash is the new time period that we have to find out. On the right hand side, we have the initial moment of inertia, that is 2 by 5 mr square into the initial angular velocity, that is 2 pi by t. Okay, so 2 pi will get cancelled, m will get cancelled, and 2 by 5 will also get cancelled. What is left on the left hand side? We have 4 r square by t dash, and on the right hand side we have r square by t. So again r square will get cancelled. From here we can say that t dash is equal to 4 times the time t. Okay, t dash, that means the new time period, is 4 times the initial time period. And what was the initial time period? 27 days. So it is 4 times 27. Okay, 4 into 27 days. What do we get on multiplying? We get 108 days. So the new time period will be 108 days. Option B will be the correct answer. Next question is from the chapter Gravitation, and the question is, the radius of Martian orbit around the Sun is about 4 times the radius of orbit of Mercury. The Martian year is 687 Earth days. Then which of the following is the length of 1 year on Mercury? So basically we are comparing two planets here. One is the planet Mars and the other is the planet Mercury. It is given that the radius of the Martian orbit around the Sun is 4 times the radius of the orbit of Mercury. That means if the radius of orbit of Mercury is r, then the radius of orbit of Mars will be 4r, right? The Martian year is 687 Earth days. Martian year means the time taken by Mars to orbit around the Sun once. So the time taken by Mars is 687 Earth days. We have to find the time taken by the Mercury to orbit around the Sun once. That means we have to find out the length of 1 year on Mercury. Okay, so time and radius, these two things are mentioned here. So we can use the Kepler's law. Okay, Kepler's law, according to which t square is proportional to r cube. Okay, so here t square, so that means the time taken by Mars by the time taken by Mercury to orbit around the Sun whole square will be proportional to the radius of orbit of Mars by the radius of orbit of Mercury whole cube, right? So let's put the values. What is the time taken by Mars? It is 687 Earth days. Okay, time taken by Mercury, that we have to find out, whole square, is proportional to the radius of orbit of Mars, that is 4r, radius of orbit of Mercury is r whole cube. So r cancelled, 4 to the power cube, that means it will be proportional to 64. Okay, so 687 by the time taken by mercury will be proportional to square root of 64, that is 8. So the time taken by the mercury to orbit around the sun will be equal to 687 divided by 8. That will come out to be about 85.88. So 85.88 days, it is not mentioned in the given options, but the nearest answer will be 88 Earth days. So option C will be the correct answer. Next question is, a wire of resistance R is cut into 8 equal pieces. From these pieces, 2 equivalent resistances are made by adding 4 of these together in parallel. Then these two sets are added in series. The net effective resistance of the combination is, okay. So we have a wire. Suppose this is the wire of resistance R. This wire is cut into 8 equal pieces. So what will be the resistance of each piece of wire? Resistance of each piece of wire will be equal to R by 8. Okay, because all the pieces would be initially in series combination. Okay, that's why they made a complete wire, right? So the each of the pieces of wire will have the resistance R by 8. Now out of these 8 pieces, 2 equivalent resistances are made by adding 4 of these together in parallels. Okay, so basically there are 8 pieces. So there were 2 groups containing 4 pieces each. This is one wire, this is 2, this is 3, this is 4. And one more group of 4 wires or 4 pieces of wires, 1, 2, 3 and 4. Okay. And all these were connected in parallel. So there is parallel combination in each set. Now the resistance of each of them is R by 8. So what will be the effective resistance of this set? The effective resistance of this set of wire will be 1 by 4 times R by 8. Similarly, for the another set, the effective resistance will be 1 by 4 times the resistance of each piece, that is 1 by 4 times R by 8. So this side we have R by 32 and the another set will also have the resistance R by 32. Now these two sets are connected in series. Okay, these two are connected in series. So the net effective resistance will be equal to R by 32 plus R by 32. That means 2R by 32. And 2 into 16 is 32. So R by 16. This will be the final resistance. So R by 16, option A will be the correct answer. Next question, a photon and an electron of mass m have the same energy E. The ratio of their de Broglie wavelength is, c is the speed of light. Okay, so for photon, what is the formula for energy? Energy will be equal to hc by lambda. So hc by lambda p. Lambda p means the wavelength of the photon. Similarly for electron, we will be using lambda e. Okay, so from here, the wavelength lambda p of the photon will be equal to hc by e. So let's say this is equation 1. Now for electron, lambda is equal to h by p, right? Where h is the Planck's constant and p is the momentum. So p will be equal to, the momentum p will be equal to h by lambda e, right? And what will be the energy of the electron? It is equal to p square by 2m. So we have the formula for energy, p square by 2m. So let's put the value of p as h by lambda e. So h by lambda e whole square 1 by 2m. Okay. So energy is equal to h by lambda e whole square 1 by 2m. Let's take 2m on the left hand side. Then we will get 2me equals to h by lambda e square. If we remove the square, we will have to add a root on the left hand side. So under root 2me will be equal to h by lambda e. So what will be the wavelength lambda e of the electron? Lambda E of the electron will be equal to h by under root 2me, under root 2me. So now we have the wavelength of the photon. Wavelength of the photon. What was the wavelength? Hc by E, right? Hc by E. And now we also have the wavelength of the electron, that is equal to h by under root 2me. We just have to find the ratio of these two wavelengths. So lambda of photon by lambda of electron will be equal to Hc by E into under root 2me by h. So h will get cancelled. Now here we have C into under root 2m under root E. Why I have written root E separately? To cancel that out with the denominator E. Okay. And on the denominator side we have E. So we can write it as root E into root E. Okay. So 1 root E will get cancelled. We will get C into under root 2m by E. So this will be the ratio of the wavelengths of photon and electron. C into under root 2m by E. This is given in the first option. Option A will be the correct answer. Next question is from the rotational motion, and the question is a sphere of radius r is cut from a larger solid sphere of radius 2r as shown in the figure. The ratio of moment of inertia of the smaller sphere to that of the rest part of the sphere about y-axis is. So you can see that there is a smaller sphere which is cut out from the larger solid sphere. Okay, radius of the larger sphere was 2r and the radius of the smaller sphere is r, right? We have to find the ratio of moment of inertia of the smaller sphere to the rest part of the sphere. That means the remaining part of the sphere. So let's find out the moment of inertia. But before we find the moment of inertia, we need to find the relation between the masses of both the spheres, because in moment of inertia, we use the mass. Okay. So one thing we know that both the spheres are made up of same material. So the density of both will same. So density of the larger sphere will be equal to the density of the smaller sphere, right? Density is equal to mass by volume. So mass of the larger sphere by volume of the larger sphere will be equal to mass of the small sphere by the volume of the smaller sphere. Here we are using capital M for mass of the larger sphere and small m for the mass of the smaller sphere. Similarly, capital V for the volume of the larger sphere and small v for the volume of the smaller sphere. So mass of the capital sphere is m by what is the volume of the larger sphere? 4 by 3 pi r cube. So 4 by 3 pi, and the radius for larger sphere is 2r. So 2r cube, right? And this side we have mass of the smaller sphere divided by the volume of the smaller sphere, that is 4 by 3 pi r cube, because for smaller sphere the radius is r. Okay. So 4 by 3 can get cancelled, pi can get cancelled. What do we get here? Capital M by 8 r cube, and this side we get small m by r cube. So r cube will be cancelled, and we can say that the mass of the smaller sphere, small m, is equal to capital M by 8. That means mass of the smaller sphere is 1 by 8 times the mass of the larger sphere. So you have to remember this relation. Now we have to find the moment of inertia. Okay, so let's find out the moment of inertia of the larger sphere first. Moment of inertia. Moment of inertia. First, for the larger sphere. Larger sphere. We know that this is a solid sphere. So the moment of inertia for a solid sphere about an axis passing through the center is equal to 2 by 5 mr square. So 2 by 5 m into 2r square, because the radius is 2r. Okay, for the larger sphere. So 2 by 5 m into 4r square. So here we get 4 into 2 8, 8 by 5 mr square. So this is the moment of inertia of the larger sphere along the y-axis, right? Now we'll find the moment of inertia of the smaller sphere. So for the smaller sphere, here you have to keep one thing in mind, that for smaller sphere, the y-axis is not passing through the center. right? It is passing through the tangent. So we will use the theorem of parallel axis. And for this sphere, the moment of inertia will be equal to 2 by 5 mr square plus mr square, right? Here small m is the mass of the smaller sphere. So 2 by 5 and small m is equal to capital M by 8. So we'll write that capital M by 8 into r square plus again small m is equal to capital M by 8 r square. So here you have to focus. Otherwise you'll get confused between small m and capital M. So we get 2 by 40 mr square plus m by 8 r square. Okay. Now if you add them, what do we get? 7 by 40. Okay. 7 by 40 mr square. So this is the moment of inertia of the smaller sphere along the y-axis. The larger sphere, the moment of inertia is 8 by 5 mr square. For smaller sphere, it is 7 by 40 mr square. So we can find out the remaining part, right? Moment of inertia of the remaining part. For remaining part, it will be equal to moment of inertia of the larger sphere minus the moment of inertia of the smaller sphere. That means 8 by 5 mr square minus 7 by 40 mr square. If you solve them, what do we get? We get 57 by 40, okay, because the LCM, the denominator will be 40 and 5 into 8 is 40, so 64 minus 7, that is 57. 57 by 40 mr square. This is the moment of inertia for the remaining part. So now we have three moment of inertia of the larger sphere, moment of inertia of the smaller sphere, and moment of inertia of the remaining part. Okay, we have to find out the ratio. So let's find out the ratio here. Ratio of the moment of inertia of the smaller to the remaining part, to that of the remaining part. This is what we have to find out in this question. So moment of inertia of the smaller is 7 by 40 mr square, and moment of inertia of the remaining part is 57 by 40 mr square. So mr square cancel, 40 cancel. What do we get? 7 by 57. This is the ratio of moment of inertia of the smaller sphere to the moment of inertia of the remaining part, 7 by 57. So it is given in the first option. Option A will be the correct answer. Next question is, an electron moving with a speed c by 100, where c is the speed of light, is injected into a magnetic field vector B of magnitude 9 into 10 to the power minus 4 Tesla, perpendicular to its direction of motion. We wish to apply a uniform electric field vector E together with the magnetic field so that the electron does not deflect from its path. Then we have to find the magnitude of the electric field and also check whether the electric field and magnetic field are perpendicular to each other or parallel to each other. So we know that according to the question, there should be no deflection in the path of the electron. So for no deflection of electron, what is the condition? The magnetic force vector FB should be equal to the electric force vector FE, right? And what is the formula for magnetic force? That is equal to QVB, okay? QV cross B. Here Q is the charge. So in this case, the charge is due to electron. So we will write the charge on the electron E into V cross B, okay? So we can add minus sign because the charge on electron is negative, okay? So E into V cross B, vector V cross vector B. That will be equal to the electric charge, that is equal to Q into E, okay? So charge is minus E and vector E is the electric field. So minus E will get cancelled on both the sides. From here we can say that the electric field vector E will be equal to the velocity vector cross magnetic field, okay, vector B. So from here we can say that the electric field and magnetic field are perpendicular to each other. Electric field and magnetic field are perpendicular to each other because cross sign is there. That means they are perpendicular to each other. Now let's find out the magnitude of electric field, so that will be equal to V cross B, that means VB sine theta. Okay, and they are perpendicular to each other, so theta will be 90 degree. The angle between them will be 90 degree. Now let's put the values. What is the value of V, or the speed? So speed is given c by 100, where c is the speed of light. So 3 into 10 to the power 8 meter per second by 100. Okay, because the V is equal to c by 100 and c is 3 into 10 to the power 8 into the magnetic field, that is given as 9 into 10 to the power minus 4 Tesla into sine theta. So theta is 90 degrees, so sine theta will be equal to 1, right? Now let's solve it. Here we'll get 27 into 10 to the power 4 divided by 10 to the power 2. Okay, so 10 to the power 4 minus 2 will be 10 to the power 2. So we will get 27 into 10 to the power 2, and the unit of electric field will be volt per meter. So 27 into 10 to the power 2. Let's see. First option is that vector E is parallel to B, so this is incorrect because they are perpendicular. Second option also parallel, so incorrect. In the third one, vector E is perpendicular to B and its magnitude is 27 into 10 to the power 4, so this is incorrect because it is 27 into 10 to the power 2. In the last option, vector E is perpendicular to vector B and its magnitude is 27 into 10 to the power 2. So yes, this is the correct answer. Option D will be the correct answer. Next question is related to electromagnetic wave, and the question is the electric field in a plane electromagnetic wave is given by. Then the expression for corresponding magnetic field is. Okay, so expression for electric field is given here. We have to find the expression for corresponding magnetic field. Here subscripts denote the direction of the field. That means we have Ez, right, in the expression, in the given expression. So Z is the subscript which denotes the direction of the field. It means the electric field is in the direction of Z axis. Okay, this is the direction of the electric field, Ez. Then by looking at the given expression, here you can see under bracket we have 5x plus 1.5 into 10 to the power 9. So x is given, that means the direction of propagation of the wave is along the x direction. Okay, this is the x axis. So the wave is propagating in this direction, like this. So what will be the direction of the magnetic field? We know that the magnetic field, electric field and the direction of propagation of the wave all will be perpendicular to each other. That means the magnetic field should be perpendicular to the electric field, that is Ez, and the direction of the wave, direction of propagation of the wave. So it should be perpendicular to Z axis as well as X axis. That means the direction of B magnetic field is Y axis. Okay, it is along the Y axis. So the subscript for B will be Y, By. So if you look at the options, the first option will be eliminated because here the subscript is Z. In the second option we have Y, third option we have Y. In the fourth option again X is there, so it will be incorrect because the direction of B should be perpendicular to X as well as Z. So it can either be option B or option C. So let's check for the value of B. So we know that B naught is equal to E naught by C, right? So let's put the values. What is the value of E naught? That is electric field. It is given in the expression 60. Okay, 60 cos 5x plus 1.5. So 60 is the E naught value. So in place of E naught we can write 60 divided by C. C is the speed of light. So 3 into 10 to the power 8. If you solve this, you will get 20 into 10 to the power minus 8, or we can say 2 into 10 to the power minus 7. So this should be the magnitude of magnetic field. Okay, B naught value. So By should be equal to 2 into 10 to the power minus 7, and all the other things will be same as that of the electric field, that is cos 5x plus 1.5 into 10 to the power 9t. Okay, so it is given in the third option. Okay, option C will be the correct answer. Next question is, a body weighs 48 Newton on the surface of the earth. The gravitational force experienced by the body due to the earth at a height equal to 1/3 the radius of the earth from its center is. So suppose this is the earth with a radius r. Okay, Then this is the height, which is equal to 1/3 the radius of the earth, that means r by 3. Okay, so what will be the total distance of this point from the center? It will be r plus r by 3. Okay, so r plus h will be equal to r plus r by 3. That means 4r by 3. This will be the value of r plus h. Now we know that the gravity g is equal to gm by r square, and the gravity at height h is equal to gm by r plus h whole square, right? So this will be equal to gm by, what is the value of r plus h? We have calculated 4r by 3. 4r by 3 whole square. So here we will get 9 gm by 16 r square. Okay. Now here we have to find out the gravitational force experienced by the body. So gravitational force means we have to find out the value of mg, or weight of the body at height h. Okay. So we know that the weight is equal to mg. So weight of the body at height h by the weight of the body at the surface will be equal to m into g at the height h by m into g at the surface. Okay. So m will be cancelled. Here we'll get g at height h by the g at surface. What is the g at height h? It is equal to 9 gm by 16 r square. So let's write it down here. 9 gm by 16 r square divided by the gravity at surface, that is equal to gm by r square. Okay, so gm by r square will get cancelled. This side we have the weight at height h and divided by the weight at the surface. Okay, so weight at height h divided by, what is the weight at the surface? It is given as 48 newton. 48 newton. This side we have 9 by 16. So weight at height h will be equal to 9 by 16 into 48. So 16 into 3 is 48. So 9 into 3, 27. And the unit will be Newton. So 27 Newton will be the answer. Option D is the correct answer. Next question is, an unpolarized light beam traveling in air is incident on a medium of refractive index 1.73 at Brewster's angle. Then, so what is Brewster's angle? It is a specific angle of incidence, at which the reflected light is totally polarized, okay, or completely polarized, and the transmitted light or the refracted light is partially polarized. Okay, partially polarized. Let's understand this with the help of an example. So suppose this is the surface of a water. Okay, this is the normal n, this is the angle of incidence, right? Now if this angle of incidence is equal to the polarizing angle, that is theta p, then the reflected light will be completely polarized. Okay, it will be completely polarized, and the refracted light, this is the normal, this is the refracted light or the transmitted light, this will be partially polarized. So this is the condition. Now it is given that the refractive index of the medium is 1.73. Now according to the Brewster's law, the refractive index mu is equal to tan theta p, where theta p is the polarizing angle. Okay, so mu is given as 1.73, so that will be equal to tan theta p, and 1.73 is equal to root 3, right? So that will be equal to tan theta p. We know that tan 60 degree is equal to root 3, right? Tan 60 degree is equal to root 3. That means here the theta is 60 degree. Okay, theta p is equal to 60 degree. Now let's have a look at the given options. The first option says that both reflected and transmitted light are perfectly polarized, which is incorrect because only the reflected light will be perfectly polarized. The transmitted one will be partially polarized. Okay. Second option is transmitted light is completely polarized. Again incorrect because transmitted light will be partially polarized. Third option says that reflected light is completely polarized and the angle of reflection is close to 60 degrees. So this is correct option. Okay. The last option says reflected light is partially polarized. Again incorrect because we know that the reflected light will be completely polarized and the transmitted light will be partially polarized. So out of the given options, the third option, option C, will be the correct answer. Next question is a constant voltage of 50 volt is maintained between the points A and B of the circuit shown in the figure. The current through the branch CD of the circuit is. So you can have a look at the given circuit. Now we have to find the current flowing through the branch CD. So for that, first we need to find the total current flowing through the circuit. And to find the total current, first we need to find the equivalent resistance of the circuit. So how will we find the equivalent resistance of the circuit? For that, we will have to assume that point C and D are a common point. So let's say this is the common point C. Okay. Then on the left side, we have 1 ohm resistance here and a 3 ohm resistance below. And on the right side, we have a 2 ohm resistance here and a 4 ohm resistance below it. Right? So let's find out the equivalent resistance. Here on the left side, there are two resistances, 1 ohm and 3 ohm, which are in parallel combination. So the equivalent resistance of this part or this side of the circuit will be 1 plus 3 upon 1 into 3. That means 4 by 3. Okay. Let's write it down here, 4 by 3 ohm. Similarly, on the right side of the point C, we have a 2 ohm resistance and a 4 ohm resistance connected in parallel. So the equivalent for this part will be 2 plus 4 upon 2 into 4. So 6 by 8, or we can say 3 by 4. Okay. 2 into 3 will be 6 and 2 into 4 will be 8. So 3 by 4. Now these two parts, left side and right side, these are connected in series, side by side. So these will be added to get the equivalent resistance of the circuit. So 4 by 3 plus 3 by 4, if you will solve, you will get 25 by 12 ohm. Okay. Now let's separate this part of the screen from the rest of the screen. Now we will find the current flowing through the circuit. So first, total current flowing through the circuit. What will be the total current flowing through the circuit? That will be equal to the voltage of the circuit, voltage given upon the equivalent resistance. So the voltage is 50 volt. It is shown in the diagram, 50 volt, and the equivalent resistance we have calculated 25 by 12. So here we will get 12 into 2, that is 24. 24 ampere is the total current flowing through the circuit. Now we have to find the current flowing through each resistance or each branch of the circuit, right? So let's first discuss the left side of the branch CD. Okay, left side of the branch CD. So here we have two resistances, a 1 ohm resistance here and a 3 ohm resistance here. Okay, and this is the branch CD. So here you can see that we have a 1 ohm resistance, and there is a 3 ohm resistance. Now we know that the current is inversely proportional to the resistance, right? Total resistances are 1 ohm plus 3 ohm, that means 4 ohm. So the total current will also divide into 4 parts to flow through these resistances. But out of 4 parts, you might think that 3 part will flow through 3 ohm resistance and 1 part will flow through 1 ohm resistance. But this is not the case. In fact, 3 parts will flow through the 1 ohm resistance and 1 part will flow through the 3 ohm resistance because the current and the resistance are inversely proportional to each other. Got it? So the current that will flow, or the current flowing through 1 ohm resistance will be 3 by 4 into 24. Okay, that means 3 into 6, 18 ampere. So 18 ampere will current will flow through the 1 ohm resistance. Similarly, the current flowing through the 3 ohm resistance will be how much? 1 part out of the 4 parts. So 1 by 4 of 24. That means 6 ampere current. Similarly, on the right side, we can find out how much current is flowing through the 2 ohm resistance. So the current flowing through 2 ohm resistance. How much current? See, on the right side, we have 2 ohm plus 4 ohm. That means 6 ohm. Right? That means the total current will be divided into how many parts? 6 parts, out of which 4 part will flow through the 2 ohm resistance and 2 parts will flow through the 4 ohm resistance, right? So through the 2 ohm resistance, 4 parts, right? So 4 out of 6 parts of 24 will flow through the 2 ohm resistance. 6 into 4 is 24, so 4 into 4, 16. 16 ampere current will flow through the 2 ohm resistance. Now we can find out the current flowing through the 4 ohm resistance as well, but here only we can find out the answer from the given data. You can see that from point A to B, how much current entered? Total 24 ampere current entered, out of which 18 ampere current flow through the 1 ohm resistance and 6 ampere current this side through the 3 ohm resistance. Now through 2 ohm resistance, how many ampere? 16 ampere. So you can see that the current that came here on the upper branches was 18 ampere. Okay, 18 ampere current flew through the upper branch, but this side only 16 ampere current passed. So 2 ampere current must have passed through the branch CD, right? So answer will be 2 ampere. Option D will be the correct answer. If you did not understand this, let me explain it once again. We have a circuit. This is 1 ohm resistance. This is 3 ohm resistance, right? This side we have a 2 ohm resistance and this side we have a 4 ohm resistance. Now this is the branch CD. So we saw that the total current that came was 24 ampere. Now this current divided, 18 ampere went towards this 1 ohm resistance and 6 ampere went towards this 3 ohm. Now just focus on the upper current, the current flowing through the upper branch. 18 ampere came this side, but this side only 16 ampere current flew. So the 2 ampere current, where did it go? It must have gone downward and passed through the branch CD. Therefore 2 ampere will be the correct answer. Option D is the correct answer. Next question is, the plates of a parallel plate capacitor are separated by distance d. Two slabs of different dielectric constants K1 and K2 with thickness 3 by 8 d and d by 2 respectively are inserted in the capacitor. Due to this, the capacitance becomes 2 times larger than when there is nothing between the plates. If K1 is equal to 1.25 K2, then the value of K1 is. So we have to find the value of K1. Right, according to the question, we have a parallel plate capacitor. Suppose this is one of the plates of the parallel plate capacitor and this is the other plate. Okay, the total distance between them is small d. Now there are two different dielectrics which are inserted between the plates. So suppose this is the first dielectric from here to here, and the thickness of this dielectric, that is T1, is 3 by 8d. 3 by 8d. Dielectric constant of this dielectric is K1. Then there is second dielectric, suppose from here to here. Okay, the thickness of this second dielectric is d by 2, and the dielectric constant is K2. Okay, now if we add the thickness of these two, that means 3 by 8d and d by 2, you will see that we will get 7 by 8d. Okay, 3 by 8d plus d by 2. What do we get? We get 7 by 8d. That means the total space occupied by these two dielectrics is equal to 7 by 8d. That means still 1 by 8d distance is left. Okay, this distance, that is equal to 1 by 8d, or d by 8 is not filled by the dielectrics. So we will assume that this space is filled by air, which can act as a dielectric with the dielectric constant K3. Okay. So basically we have to assume in this question that there are three dielectrics placed between two parallel plates of the capacitor. Okay, two dielectrics which are mentioned in the question, and the third dielectric is the air. Okay, now assuming this, let's start solving this question. First we will find the equivalent capacitance of this setup. So equivalent capacitance in the presence of dielectric is equal to epsilon naught A by D minus T plus T by K. Okay. In the presence of dielectric, this formula is used. But this formula will be valid when there is only one dielectric. Okay. Or when there is one thickness or one dielectric constant. But in this case, we have three dielectrics with three different thickness and three different dielectric constants. So for that, let's write it down. For three different dielectrics, so you have to remember which formula has to be used in which condition. So when there are more than one dielectrics with different dielectric constants and different thickness, in that case the equivalent capacitance will be equal to epsilon naught A by D minus T1 plus T2 plus T3. That means the sum of the thickness of all the three dielectrics plus T1 by K1 plus T2 by K2 plus T3 by K3. So by looking at this, you can understand that the solution is going to be quite lengthy. Okay, you just have to put the formula and solve them. That's it. But it will take time. So let's solve it. Epsilon naught A by D minus T1 plus T2 plus T3. So the total thickness of all the three dielectrics will become equal to D. So D minus D plus T1 by K1. So what is T1? T1 is equal to 3 by 8 D. So T1 by K1 will be equal to 3 by 8 D by K1. Okay. Plus T2. T2 was equal to D by 2. D by 2. So in place of T2 by K2, we will write D by 2K2. Plus T3. What is the thickness of the third one? That is air. It was 1 by 8 D. Okay. Or D by 8. So T3 by K3, that means D by 8 K3. So here D will get cancelled. And what do we get? Epsilon naught A by, we know that K1 is equal to 1.25 K2. This is given in the question, last line of the question. So in place of K1, we can write 1.25 K2. So here 3 by 8 D, here 8 into 1.25 K2, we can simply write 10. Okay, 8 into 1.25 is 10. So simply we can write 3 by 10 K2 plus D by 2 K2 plus D by 8 K3, and we know that K3 is the dielectric constant of the air, that is equal to 1. So simply we can write 3 by 8. Okay. So this is the equivalent capacitance of this setup. Now, according to the question, the new capacitance, that is C equivalent, will be equal to 2 times the initial capacitance. Initial capacitance is the capacitance in the absence of the dielectrics, that is equal to epsilon naught A by D, right? So this equivalent one, that means epsilon naught A by D by 10 K2 plus D by 2 K2 plus D by 8 will be equal to 2 times epsilon naught A by D, right? So epsilon naught A will be cancelled. On the left hand side, we can take D common. So 1 by D, here we have D also. So 3 by 10 K2 plus 1 by 2 K2 plus 1 by 8. And this side we have 2 by D. So D will also get cancelled. Now how to solve this? So we can cross multiply, right? We can take this complete thing on the right side. So what do we get? 1 equals to 2 into 3 by 10 K2 plus 1 by 2 K2 plus 1 by 8. Now you just have to solve them and then you will find the value of K2. Okay. So 1 equals to, here we will get 2 into 3 by 10 will be 3 by 5. So 3 by 5 K2 plus 1 by K2 plus 1 by 4. Okay, if we take 1 by 4 this side, we will have 1 minus 1 by 4, and this side we have 5 K2 and 3 plus 5, that is 8 by 5 K2, and this side we have 3 by 4. Okay, 1 minus 1 by 4 will be 3 by 4. So 3 by 4 equals to 8 by 5 K2. So we can find out the value of K2. K2 will be equal to 8 by 5 into 4 by 3. So that will be equal to 32 by 15. So now we have got the value of K2, but we have to find K1. So according to the question, K1 is equal to 1.25 times K2. So that will be equal to 1.25 times 32 by 15. Okay. Okay. So you can directly solve them. 1.25 into 32 divided by 15. When you will do that, you will get the value 2.66. Okay. Even if you don't get the exact value, you will get the approximate 2.66. So let's see, it is given in the third option. Option C will be the correct answer. Next question is, consider the diameter of a spherical object being measured with the help of a vernier calipers. Suppose its 10 vernier scale divisions are equal to its 9 main scale divisions. The least division in the main scale is 0.1 centimeter and the 0 of vernier scale is at x equals to 0.1 centimeter when the jaws of vernier calipers are closed. If the main scale reading for the diameter is m equals to 5 centimeter and the number of coinciding vernier divisions is 8, the measured diameter after zero error correction is. So it is given in the question that 10 vernier scale divisions, that is 10 VSD, are equal to 9 main scale divisions, that means 9 MSD. So from here we can say that 1 VSD will be equal to 9 by 10 MSD, right? So 1 vernier scale division will be equal to 9 by 10 times main scale division. Now we need to find the least count. So least count. What is the formula for least count? This is simple. 1 MSD, 1 main scale division minus 1 vernier scale division. 1 main scale division minus 9 by 10 main scale divisions, because just now we saw that 1 vernier scale division will be equal to 9 by 10 main scale division. So in place of vernier scale division, we can write 9 by 10 main scale division. Okay. So that will be equal to 1 by 10. 1 by 10 main scale division. Now what is main scale division? In this question it is given the least division in the main scale is 0.1 centimeter. That means one main scale division is 0.1. So it will be equal to 1 by 10 into 0.1, and 1 by 10 is nothing but 0.1. So 0.1 into 0.1 will be equal to 0.01 centimeter. This is the least count. Okay. Now we have to find out the reading. So how do we find the reading? The reading is equal to main scale reading plus vernier scale reading minus the error. Now what is main scale reading here? In this question you can see in the last line it is given the main scale reading is 5 centimeter. Okay, so let's put this value 5 here plus vernier scale reading. How do we find the vernier scale reading? So the vernier scale reading is equal to n into least count. Okay, what is n here? N into least count. N is, you can see in the last line, the number of coinciding vernier division is 8. So this is n. Okay, n is the number of coinciding vernier division. So n times least count. So vernier scale reading will be equal to 8 into the least count, that is 0.01. Okay, so that is equal to 0.08. So let's put this value here, 0.08 minus what is the error? So you can see here it is given that the least division in the main scale is 0.1 centimeter and the 0 of vernier scale is at x equals to 0.1 centimeter when the jaws of the vernier calipers are closed. So when the jaws of the vernier calipers are closed and the 0 of vernier scale is at x equals to 0.1 centimeter, it means there is a positive zero error of 0.1. So the error is plus 0.1. Okay, so let's put this value here, minus plus 0.1. Now just we have to solve it. 5 plus 0.08 minus 0.1. So if you solve it, what do we get? You will get 4.98 centimeter. So this is the answer. Option A will be the correct answer. Next question. A 2 ampere current is flowing through two different small circular copper coils having radii ratio 1:2. The ratio of their respective magnetic moments will be. So the ratio of radii is given. We have to find the ratio of magnetic moments. So we know that the magnetic moment of current carrying circular loop is equal to current into area. Okay. So the magnetic moment is directly proportional to the area, and area is equal to pi r square, right? Area is equal to pi r square. That means the magnetic moment will be directly proportional to r square. So m1 by m2 will be equal to r1 by r2 whole square. R1 by R2 is given 1 by 2. Okay, 1:2 is the ratio. So square of this will be 1 by 4. So this is the ratio of the magnetic moments, M1 by M2. 1:4. Option C will be the correct answer. Now we have come to the last question, and the question is, consider a water tank shown in the figure. It has one wall at x equals to L and can be taken to be very wide in the z direction. When filled with a liquid of surface tension S and density rho, the liquid surface makes angle theta naught, which is much less than 1, with the x-axis at x equals to L. If yx is the height of the surface, then the equation for yx is. So these type of questions are meant to be skipped, okay, because most of you would not have studied these concepts, right? So you should skip such questions in the exam, otherwise they will consume your time, okay? But still, let's see how to solve it. So this given graph represent a water tank, right, where one of the wall is at x equals to L. Okay, so this is the x-axis. This is a point. This is a point L on the x-axis. The wall is here. Okay, and this is your y-axis. We have a liquid that goes curve like this. Okay, it is given in the question that the wall can be taken to be very wide in the z direction. Z direction means somewhere this side. Okay, or you can assume that the z direction is coming out of the screen towards you. Okay, so here when the water tank is filled with a liquid of surface tension S and density rho, the liquid surface makes an angle theta with the x-axis at x equals to L. Okay, so this is your x-axis. At this point x equals to L, the angle made by the liquid is theta naught, which is much less than 1. If yx is the height, so suppose this is the point y, this is yx. So yx is the height of the surface. We have to find the equation for this height, right? So we need to find the curvature for that, curvature. And what is the formula for curvature? Curvature is equal to 1 by the radius of curvature. Okay, curvature is the inverse of radius of curvature. And what is the formula for radius of curvature? This is equal to 1 plus dy by dx square whole to the power 3 by 2 upon d square y by dx square. Okay, so this is the formula that you need to remember. Okay, so this is the radius of curvature, and curvature will be the inverse of this. That means d square y by dx square upon 1 plus dy by dx square whole to the power 3 by 2. So it looks difficult, but according to the question, theta naught is much less than 1. Okay, and look at this last line of this question. Take theta, x equals to sine theta equals to tan theta. Okay, so we know that theta will be equal to dy by dx, right? Theta will be equal to dy by dx, and theta is very small, so sine theta or tan theta will be approximately equal to 0. Okay, so dy by dx will also be equal to 0. Okay, approximately 0. So in place of dy by dx, you can write here 0. So the denominator part will become 1. Okay, 1 plus 0 to the power 3 by 2, that means 1 only. Okay, so this curvature will simply become equal to d square y by dx square. Okay, so now it has become simple. Now here you have to know about an important formula that is known as Young-Laplace formula. Okay, Young-Laplace formula or Young-Laplace concept, according to which the pressure difference delta P is equal to the surface tension into the curvature. Okay, so here what is the pressure difference? We know that the pressure is equal to rho g h, where h is the height, so rho g, and height in this case is yx. Okay, so y is equal to rho g y will be equal to surface tension S into the curvature. So we have seen curvature is equal to d square y by dx square. Okay, so we had to find the expression for y. Okay, so d square y by dx square will be equal to rho g y by S. This will be the expression. So it is given in which option? Option D. D square y by dx square equals to rho g y by S. So option D is the correct answer. So here we have completed all the physics questions from NEET 2025. We will be back with another session soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice the same questions from our website www.examsnet.com. And for more information, you can download our app from the link given in the description box. Thank you so much. Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. In this session, we are going to discuss NEET 2025 chemistry paper, and we have 45 questions here. So let's start with the first question of chemistry, that is from organic chemistry. And the question is, identify the suitable reagent for the following conversion. So you can see this reaction here. On the reactant side, we have an ester, and on the product side we have an aldehyde. So an ester is getting reduced into an aldehyde. So this is the case of selective reduction. Okay, selective reduction. So ester has to be reduced selectively in order to form an aldehyde. So which reagent can be used for selective reduction? There is a common reagent that is known as dibyl H. Dibyl H. Okay, it is a versatile and selective reducing agent that is used in organic chemistry. It is selective reducing agent. What is the full form of dibyl H? It is diisobutyl aluminium hydride. Aluminium hydride. It can also be written as AlH and under bracket this diisobutyl. Okay, so this reagent is primarily employed to reduce esters, lactones and nitriles into aldehydes, and it can also reduce ketones into secondary alcohols. Okay, it can also reduce ketones into secondary alcohol, right? And it can reduce aldehydes into primary alcohols. Aldehydes into primary alcohol. Okay, so you should remember this, the name of this reagent, diisobutyl aluminium hydride. So the correct answer is option number D, last one. Okay, water will also be used. Option D is the correct answer. Next question is, the correct order of decreasing acidity of the following aliphatic acids is. So we have carboxylic acids here. Now we have to arrange them in the correct order of decreasing acidity. Okay. So we know that the presence of electron donating group, decreases the acidity of carboxylic acid. Okay. Decreases the acidity of carboxylic acids. So we know that methyl group is an electron donating group. It is an electron donating group. So more the number of methyl group in the acid, lesser will be the acidity. Okay, because the methyl groups will decrease the acidity. So look at the first option. Here the first one is formic acid, the simplest carboxylic acid. Here we have no methyl group, so it will have the highest acidity. Then the second one is ethanoic acid. Here we have one methyl group. It will decrease the acidity to some extent. Then the third one, we can see we have two methyl groups. It will further decrease the acidity of the acid. And then at last we have three methyl groups. So the number of methyl groups is getting increased, right? So the acidity will go on decreasing. So the first one is the correct order of decreasing acidity. In the second option, you can see first one is most acidic. Yes, this is correct. But second one, we have three methyl groups. In the next one, we have only two methyl groups. So how can the acidity decrease? It will increase, right? So this is incorrect. In the next options also you can check like this, but only the first one is the correct one, correct order. Okay. So option A will be the correct answer. Next question is, which one of the following reactions does not belong to Lassane's test? So what is Lassane's test used for? So this test is used for the detection of nitrogen, halogen, sulfur and phosphorus. Okay, sulfur and phosphorus. Now let's check the options. In the first option we have halogen along with sodium, right? This X is halogen. So this is a test for halogen. Okay. So yes, this is related to Lassane's test. This belongs to Lassane's test. Then the next one, you can see we have carbon with copper. Okay, carbon and copper are there on the reactant side. We have none of these elements, nitrogen, halogen, sulfur or phosphorus. So one of these should be present for Lassane's test. So here we don't have these elements, so this is incorrect. In the third option, you can see we have nitrogen on the reactant side. Okay, carbon and sodium are also there, but nitrogen is there. Then in the fourth reaction, we have sulfur, right? So in the first option, third option and fourth option, we have one of these elements, but in the second option, we don't have any of them. So second one does not belong to Lassane's test. Option B will be the correct answer. Next question is from chemical kinetics, and the question is, if the rate constant of a reaction is 0.03 per second, how much time does it take for 7.2 mole per liter concentration of the reactant to get reduced to 0.9 mole per liter? The value of log 2 is given. Okay, so the rate constant K is equal to 0.03 per second. Then the initial concentration is 7.2 mole per liter. Final concentration or concentration at time t is 0.9 mole per liter, and the value of log 2 is given. Log 2 is equal to 0.301. We have to find out the time required for this reaction. So the time required formula is 2.303 upon K log initial concentration upon final concentration, right? So let's put the values here. 2.303 upon K. What is the value of K? 0.03 per second. Log initial concentration is 7.2 mole per liter and final concentration is 0.9 mole per liter. So if we solve this, here we'll get 8. Okay. So 2.303 upon 0.03 log 8. Now in place of log 8 we can write 3 log 2. Okay, 3 times log 2. So it is equal to 2.303 upon 0.03 into 3 log 2. And what is the value of log 2? It is given 0.301. Okay, so you just have to solve this. 2.303 upon 0.03 into 3 into what is the value of log 2? 0.301. So when you will solve this, you will get 69.3 and the unit of time is second. So 69.3 second, that means option C will be the correct answer. Next question is from chemical bonding and molecular structure. Two statements are given here. The first statement says that a hypothetical diatomic molecule with bond order 0 is quite stable. So is this statement correct? No, because for stable molecule the bond order must be positive. Okay, so if the bond order is positive, then the molecule will be stable. Okay, if it is negative, it will definitely be unstable. Now if it is 0, then also it is considered to be unstable. Why? Because when the bond order is 0, let's write it down here. When the bond order is 0, then it indicates that the number of electrons in the bonding orbitals is equal to the number of electrons in the anti-bonding orbitals. Okay, electrons in the anti-bonding orbitals, then only bond order will be 0, right? So if the number of electrons in the bonding orbital is equal to the number of electrons in anti-bonding orbitals, then there will be no net attractive force. No net attractive force. Attractive force between the atoms, right? And when there is no attraction between the atoms, there will be no stability. Okay, so this will be unstable, not stable. So this statement is incorrect. Now the second statement says that as bond order increases, the bond length increases. So both are increasing. No, this is incorrect, because we know that bond order is inversely proportional to the bond length. Okay, if bond order will increase, then the bond length will decrease, not increase. So both the statements are incorrect. Option D, both statement 1 and statement 2 are false. This will be the correct answer. Next question is from coordination compound, and the question is, out of the following complex compounds, which of the compound will be having the minimum conductance in solution? So we have to see, check for the conductance, and we know that the conductance depends on the number of ions. It is directly proportional to the number of ions, okay, that will be produced by the complex. So let's check for the number of ions. In the first one, if we break this, we will get cobalt NH3 6. This is one ion plus 3 chloride ions. So total 4 ions. Okay. Then second one will give cobalt NH3 5 Cl. This is one ion plus 1 chloride ion outside the sphere. So 1 chloride ion. So total 2 ions. Okay. Everything that is inside the coordination sphere will be considered as one ion. Okay. Then in the third and fourth, you can see there is nothing outside the coordination sphere, right? So the overall charge on the third and fourth is 0. So we can say that both will have same conductance. Okay, definitely first option will not be the correct answer because it has maximum number of ions, so it will have maximum conductance. The second one has lesser number of ions than the first one, so it will have lesser conductance from the first one. But third and fourth are both having minimum conductance because both have 0 charge. Okay, so both C and D can be the correct answer. Next question is from the chapter solutions, and the question is, which of the following aqueous solution will exhibit highest boiling point? Okay, so we know that delta TB, that means elevation in boiling point, is equal to I into KB into small m, right? Here delta TB is the elevation in boiling point, elevation in boiling point. I is the Van 't Hoff factor, KB is a constant, and small m is the molality, right? Molality. Now, we also know that delta TB equals to TB minus T naught B, where TB is the boiling point of the solution, boiling point of solution, and T naught B is the boiling point of pure solvent. Okay. So here the question is about the boiling point, and we know the formula for elevation in boiling point, right? So from here we can relate them. We can say that more the elevation in boiling point, more will be the boiling point of the solution. Okay. From this formula, this one, you can see that delta TB will be proportional to TB. Okay. So more the delta TB, more will be the TB. Okay. So from here we can use this formula. Delta TB equals to I into KB into M. So KB will remain constant because in all the given options, the solvent is same, that is water. Okay. It is an aqueous solution. They are all aqueous solution. So the value of KB will be same. So we can say that the delta TB will be proportional to I into small m. Okay. Now, here in all the options, molality is not given, molarity is given. Okay. There is difference between molarity and molality. Here capital M is given in the options, that means molarity. So we can assume that molarity is same as the molality, okay, because the units are same in all the given options, so we can consider them to be the molality. Now let's check each one. The first one, in the first one we have 0.01 molar Na2SO4. Okay, so if it gets dissociated, it will give us 2 sodium ions and 1 sulfate ion, right? So how many ions? 3 ions will be there. So number of ions is 3. We are assuming that there is 100% dissociation. So number of ion is 3. That means the value of I will be 3 here. Okay. The Van 't Hoff factor will be 3 in this case. And molality, we are assuming molarity to be the molality. So here the molality is 0.01. So 3 into 0.01. What will we get? We'll get 0.03. So the value of delta TB is 0.03. For the second one, we have C6H12O6. So this is glucose, right? And glucose is non-electrolyte, so it will not get dissociated. So we have the number of ion only 1. So the value of I will be 1 here. Okay. And the molality is 0.015. This is 0.015. So what will be the value of delta TB? This will be equal to 1 into 0.015. So here we will get 0.015. This is the value of delta TB. Now for the third one. Third one we have 0.01 molar urea. So for urea, again urea is a non-electrolyte. So the Van 't Hoff factor will be 1 for urea and the molality is 0.01. So delta TB will be equal to 1 into 0.01. That will be equal to 0.01 only. And now the last one. We have 0.01 molar KNO3. So it will give us 1 potassium ion and 1 nitrate ion. So the number of ions will be 2. Okay. So Van 't Hoff factor will be 2 here and the molarity is 0.01. So the delta TB value will be 2 into 0.01, that is 0.02. So which one of them have highest value of delta TB? The first one, right? First one 0.03. This is the highest value of delta TB. That means the value of boiling point will also be highest for this one, the first one. So option A will be the correct answer. Next question is from haloalkanes and haloarenes. There are two statements. One is assertion and the other is reason. According to the assertion, this compound undergoes SN2 reaction faster than this compound. So the first compound has iodine and the second compound has chlorine. Okay. We know that the size of iodine is greater than the size of the chlorine. Right. So this is correct statement because size matters in case of SN2 reaction. Okay, the size of the leaving group is important factor in the SN2 reaction. So iodine is the leaving group in the first one, so it will undergo SN2 reaction faster. The reason given here is iodine is better leaving group because of its large size. This is also correct statement and it is correct explanation of the assertion. Because of the large size of iodine, it is a better leaving group, because the large size of the iodine will stabilize the negative charge that will develop during the reaction's transition state. Okay, so this stabilization will make the departure of the leaving group easier and faster, therefore increasing the rate of SN2 reaction. Okay, so both assertion and reason are correct, they are true, and reason is the correct explanation of assertion. Option C will be the correct answer. Next question is, consider the following compounds. So three compounds are given here. The oxidation state of the underlined elements in them are respectively. So the first compound is KO2. Here the underlined is potassium. Okay, potassium is underlined here. So we know that potassium is an alkali metal. It is an alkali metal. And you would have read the rules in your NCERT book that alkali metals always show +1 oxidation state. Always, there is no exception. Okay, so it will have +1 oxidation state, which is given in option A and option C. Okay, so B and D are already eliminated. Then the second compound is H2O2. So here the oxygen is underlined. Now, in general, we assume that oxygen has -2 oxidation state, but this is not always the case. Okay, unlike the alkali metals, which have always +1 oxidation state, oxygen can have different oxidation state in different cases. Okay, so here let's calculate. The hydrogen will have +1 oxidation state, right? So two hydrogens are there, that means +2. So +2 for hydrogen, plus suppose the oxygen has X oxidation state. So two oxygens are there, so it will have 2X oxidation state, and the sum of both the oxidation states will be 0. Okay, the sum is always 0. So 2 plus 2X is 0. So 2X is equal to -2 and X will be equal to -2 upon 2, that is -1. Okay, so here the oxidation state of oxygen will be -1, which is shown in the third option. But still, let's check for the third one also. H2SO4 is the third compound. Here sulfur is underlined. Okay. Now the oxidation state of hydrogen is +1, right? Always. So two hydrogens are there. So it will be +2 plus. Suppose the oxidation state of sulfur is X. So we are writing X for sulfur, plus 4 oxygens are there, and we assume that the oxidation state of oxygen is -2. So for 4 oxygen it will be -8. Okay, so -8. The sum will be 0. So 2 plus -8, that means -6, plus X equals to 0. So what will be the value of X? It will be +6. So the oxidation state of sulfur in this compound will be +6. So in option C you can see that oxidation state of potassium is +1. In the second compound, that of oxygen is -1, and in the third compound, the oxidation state of sulfur is +6. So option C will be the correct answer. Let's come to the next question. Here we have to match the list 1 with list 2. The first one is Haber's process. So what is Haber process? It is an industrial method for the synthesis of ammonia, okay, from nitrogen and hydrogen, and it uses iron catalyst. So it is already matched with iron catalyst. So A will be matched with number 1. Second one is Wacker oxidation. Wacker oxidation is a chemical reaction that oxidizes alkenes to ketones or aldehydes. Okay, alkenes to ketones or aldehydes. Okay, and this process uses the palladium catalyst and a copper co-catalyst. So it is matched with palladium catalyst, right? Palladium chloride, it is the catalyst that is used in the Wacker oxidation. So B will be matched with number 2 only. Then the C is Wilkinson's catalyst. What is Wilkinson's catalyst? It is a coordination complex of rhodium. Okay, rhodium, it will contain rhodium. So again, it is already matched here with the correct formula. Okay, with the correct compound. This is the Wilkinson's catalyst. Here RH means rhodium. Okay, and it is generally used as a hydrogenation catalyst in the organic chemistry. So C is already matched with number 3 correctly. Then the last one is Ziegler catalyst, which is also known as Ziegler-Natta catalyst, which is again a type of coordination catalyst that is used for polymerization of alkenes. Okay, polymerization of alkenes. And here the catalysts that are used are a combination of a transition metal such as titanium tetrachloride, which is given here, and an organometallic compound such as triethyl aluminium or trimethyl aluminium. So here trimethyl aluminium is given. So D is matched with number 4 correctly. So all are correctly matched here. A will be matched with number 1, B with 2, C with 3 and D with 4. Option A will be the correct answer. Next question is from P block elements. Two statements are given here. The first statement says that like nitrogen can form ammonia, arsenic can form arsine. Okay, so we know that both nitrogen and arsenic belong to group 15 elements. Okay, they belong to group 15 of the periodic table, right? And we know that all the elements of the group 15 can form the hydrides of the type EH3. Okay, so nitrogen can form NH3, that is ammonia. Similarly, arsenic can form ASH3, that is arsine. So this statement is absolutely correct. Then let's come to the second statement. It says that antimony cannot form antimony pentoxide. So antimony again belongs to group 15. And we know that group 15 elements can form two types of oxides. So two types of oxides can be formed by the group 15 elements. And what are these two type of oxides? One is E2O3 and the other is E2O5. Okay, that means both trioxides and pentaoxides can be formed by the group 15 elements. So antimony, that means Sb, can also form pentoxide Sb2O5. But this statement says that it cannot form antimony pentoxide, which is incorrect because it can form pentoxide. So first statement is correct, but the second one is incorrect. Option A will be the correct answer. Next question is from D block elements. Again, two statements are given here. The first statement says that ferromagnetism is considered as an extreme form of paramagnetism. So this is a correct statement. Okay, we know that the substances which are attracted very strongly in applied magnetic field are termed as ferromagnetic. In fact, ferromagnetism is extreme form of paramagnetism. So this is definitely correct statement. Then let's come to the second statement. It says that the number of unpaired electrons in chromium 2 plus ion, whose atomic number is 24, is the same as that of neodymium 3 plus ion with atomic number 60. Okay, so let's check for the chromium 2 plus ion first. What will be the electronic configuration? It will be 3d4 4s0. Okay, so how many unpaired electrons are there? Number of unpaired electrons is 4. Okay, now in case of neodymium 3 plus with atomic number 60, the electronic configuration will be 4f3 6s0. So here the number of unpaired electrons is 3, right? So is the number of unpaired electrons same? No, they are different. So this statement is incorrect. First statement is correct, second one is incorrect. option A will be the correct answer. Next question is from hydrocarbons, and the question is, which one of the following reactions does not give benzene as the product? So let's check. In the first option we have acetylene, that is reacting with a red hot iron tube at very high temperature. Okay, 873 Kelvin is a high temperature. So which type of reaction will take place? Cyclic polymerization reaction. Okay, this is known as cyclic polymerization. Cyclic polymerization will take place and benzene will be formed. Okay, so in this reaction benzene will be formed. In the second one, the reactant is a disonium salt. Okay, we have disonium salt on the reactant side and it is reacting with warm water. So what will happen? As a result, phenol will be formed. Okay, phenol. That means this is the benzene ring and here we have OH. This is the phenol. Other than that, nitrogen and HCl will be formed. Okay, so in this reaction benzene will not be formed. Phenol will be formed, not benzene. So this can be the correct answer. Let's check other options as well. In the third one, we have this sodium salt of benzoic acid that is reacting with soda lime. So this will also give the benzene. Okay, it will also give benzene. This is known as decarboxylation reaction. Decarboxylation reaction. So this part will be removed from the benzene ring and benzene will be formed. Okay. Now let's come to the last option. Here we have normal hexane that is reacting with molybdenum oxide. Okay. The temperature is 773 Kelvin, pressure is 10 to 20 atmospheric pressure. So the same reaction you can get in the NCERT. Okay. This reaction is known as aromatization. It is known as aromatization or reforming reaction. Reforming reaction. And this reaction will also give you a benzene. So the only reaction where we are not getting a benzene as the product is the second option. So option B will be the correct answer. Next question is from P block elements. Here we have to match list 1 with list 2. So the first one is xenon O3. Xenon O3 trioxide. Okay. So let's see the structure. Here we have xenon. Then we have 3 oxygen atoms attached to it. So double bond O and double bond O. And one lone pair will be there on the xenon. So total 4 orbitals are there, 1 s orbital and 3 p orbitals. So the hybridization will be sp3. And what will be the shape? The shape will be pyramidal. Pyramidal shape. So A will be matched with number 2. Okay. A will be matched with number 2. Then the second one, xenon difluoride. Xenon difluoride. So let's see the structure. This is xenon. 2 fluorine atoms are there. One this side and second this side. Okay. And then there will be 3 lone pairs of electron. So total number of orbital is 5. Okay. 1 s orbital, 3 p orbital and 1 d orbitals. So the hybridization will be sp3d. This is the hybridization. And what will be the shape? The shape will be linear. Okay, linear. Look at this shape. Xenon difluoride. This is a linear shape, right? So B will be matched with number 1. Then let's come to the third one. Xenon OF4. So let's see the structure. This is xenon. We have double bond O, then 4 fluorine atoms. 1, 2, 3, 4. Okay. 4 fluorine atoms are there. 1, 2, 3, 4. Can you see this? So how many orbitals are there? Total 6 orbitals are there. 1 s, 3 p and 2 d orbitals. So the hybridization is sp3d2, right? And the shape is square pyramidal. It is square pyramidal. So C will be matched with number 4. C will be matched with number 4. And now let's come to the last one, number D. Here we have xenon hexafluoride. 6 fluorine atoms are there. So the shape is like this. Xenon, 6 fluorine atoms. So 1, 2, 3 and 3 on the other side. 4, 5, 6. Okay. So 6 fluorine atoms are there and there will be one lone pair here. So the hybridization will be sp3d3. Okay. Total 7 orbitals are there. And what is the shape? The shape is distorted octahedral. Why distorted? Because of the presence of the lone pair of electron. So D will be matched with number 3. So according to this, the correct answer will be option C. Okay. Now next question is how many products including stereoisomers are expected from monochlorination of the following compound. So we have this compound, it has to undergo monochlorination. Mono means one and chlorination means addition of chlorine. So one chlorine has to be added to this compound. Okay, so one chlorine will replace one hydrogen. So let's see how many products are possible including the stereoisomers. So the first possibility is that the chlorine will get added to the first carbon from the right hand side. Okay. So if we write letter R for methyl group, it will be easier for us. Okay. So the first possible product is R. R is the methyl group. Okay. CH, CH2, then CH2Cl. Okay. This is the first product possible. And this product has one isomer. It will have only one isomer. Then the next possibility is that the chlorine will get added to the second carbon from the right hand side. So the product that will be made is RRCH, then CHCl, okay, and then here we have the methyl group R. Now the carbon to which the chlorine has been added is a chiral carbon, right? That means all the 4 groups which are connected to this carbon are different. So since this is chiral carbon, therefore it will have 2 isomers because it can have R configuration as well as S configuration. So it will have 2 isomers. That means 2 products are possible from this. Then the third possibility is that the chlorine will get added to the next carbon, that is the carbon to which 2 methyl groups are added. Okay, so the product that we will get is R, and here we will have CCl. Okay, one H will be replaced by chlorine, and then the rest of the carbons will be same, CH2 and CH3, that is R. Okay, so again this will have only one isomer, that means one product. And then the last possibility is that the chlorine can get added to one of the methyl groups added to the last carbon. Okay, so let's add it to the first methyl group, CH2Cl. Okay, this is one methyl group to which chlorine has been added, and the second methyl group will remain as it is. Then this is CH. Then rest of the carbons will be same, CH2, CH3. Now again this carbon is a chiral carbon. Okay, all the 4 groups are different. So chiral carbon, that means again it can have R configuration as well as S configuration. So it will have 2 isomers or 2 products from here. Okay, so how many products in total? 1 plus 2 plus 1 plus 2. That means total 6 products are possible including the stereoisomers. So option B, 6 will be the correct answer. Let's come to the next question. Which of the following statements are true? So we have to find out the correct statement. The first statement says that unlike gallium that has a very high melting point, cesium has a very low melting point. So is it correct? Gallium has the melting point 303 Kelvin, whereas that of cesium is 302 Kelvin, which are approximately same. So both are having low melting point. So this statement is incorrect. Okay. Then let's come to the second statement. It says that on Pauling scale, the electronegativity values of nitrogen and chlorine are not the same. Again, incorrect statement because the electronegativity value of nitrogen and chlorine will be same on the Pauling scale, that is 3. Okay, 3.0 or 3. Now let's come to the third statement. Argon, potassium ion, chloride ion, calcium ion and sulfide ion are all isoelectronic species. Isoelectronic means having same number of electrons. So we know that the number of electrons is equal to the atomic number, right? So for argon, what is the atomic number? It is 18. So the number of electron will also be 18, right? Now for potassium ion, so we know what is the atomic number of potassium? It is 19. But it is potassium ion with one plus sign, K plus. That means one electron has been removed from it. So 19 minus 1, that is 18. Again, it has 18 electrons. Then the next one is chloride ion. So we know that chlorine atom has the atomic number 17, but this is chloride ion with one minus sign. That means one electron will be added to it. So 17 plus 1, that is 18. So you can check that all of these are having same number of electrons, that is 18. Okay, you can check for calcium, the atomic number is 20 and then 2 electrons are removed from it, so 18. So this statement is correct that they are all isoelectronic species because they have same number of electrons, that is 18. Okay, so till now only the statement C is correct. Let's check other statement. The fourth statement is the correct order of the first ionization enthalpies of sodium, magnesium, aluminium and silicon is. So here you can see this order. Is this order correct? No, because the correct order will be silicon, then magnesium, then aluminium and then sodium. So the position of magnesium and aluminium will be exchanged. And why is it so? Let's check. For magnesium, the electronic configuration is 1s2, 2s2, 2p6, then 3s2. Okay, this is the electronic configuration of magnesium. In the last orbital, you can see that is the 3s orbital. How many electrons are there? 2 electrons. That means there is complete, the orbital is completely filled. Okay, so 2 electrons, that means the electrons are paired. Okay, and the orbital is completely filled. Whereas in case of aluminium, the electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p1. So what is the last orbital here? 3p. And how many electrons are there? Only one electron, one unpaired electron. So it will be easier to remove this unpaired electron from aluminium, right? Which one will have higher ionization enthalpy? Magnesium, because it will be difficult to remove electron from the 3s orbital because this orbital is completely filled and the electrons are paired. Okay, so magnesium will have higher ionization enthalpy, first ionization enthalpy. So correct order given in this statement is incorrect. Okay, this is not the correct order. I have written the correct order. Then let's come to the last statement. It says that the atomic radius of cesium is greater than that of lithium and rubidium. So we know that lithium, rubidium and cesium all belong to the same group. Okay, lithium, then comes rubidium and then comes cesium. Okay. Now we know that as we move down the group, the size of the atomic radii increases. Okay, so cesium comes after lithium and rubidium. So definitely it will have the greater atomic radius. So this statement is correct, right? So out of the 5 statements given here, only 2 statements are correct, statement C and statement E. So option D will be the correct answer. Next question is from thermodynamics and the question is the standard heat of formation in kilocalorie per mole of barium ion is. Then some data are given here. Standard heat of formation of sulfate ion is given, minus 216 kilocalorie per mole. Then standard heat of crystallization of barium sulfate is given and standard heat of formation of barium sulfate is given. Okay. And we have to find out the standard heat of formation of barium ion. Now, heat of crystallization of barium sulfate is given. That means the barium sulfate crystal is being formed in the reaction. Okay, so how will this crystal be formed? From the barium ion and the sulfate ion, right? So the reaction will be barium ion plus sulfate ion will give barium sulfate crystal, right? This is the reaction. Barium ion and sulfate ion are in aqueous solution, whereas the barium sulfate that is formed is solid, right? Because it is crystal. Now, we know that this is a crystallization reaction. So in this case, the heat of reaction will be equal to heat of crystallization or standard heat of crystallization of the barium sulfate. Now the formula that we will use to solve this question is heat of the reaction is equal to standard heat of formation of the product minus standard heat of formation of the reactant. This is the formula that we have to use. Okay. So now what is the product here? The product is nothing but the barium sulfate. It is the barium sulfate. And what are the reactants? There are two reactants. And one is barium ion and the other is sulfate ion. So two reactants are there. So what will be the heat of reaction in this case? The heat of crystallization of barium sulfate. Okay, so that is given as minus 4.5 kilocalorie per mole. And this side, standard heat of formation of the product. Product is barium sulfate. So what is the standard heat of formation of barium sulfate? It is given in the question. Minus 349 kilocalorie per mole. Minus standard heat of formation of the reactant. So here we have two reactants. So the standard heat of formation of the reactant will be the sum of the heat of formation of both barium ion and sulfate ion. So standard heat of formation of the barium ion, which is unknown, we have to find out this, plus the standard heat of formation of the sulfate, which is given in the question. It is minus 216 kilocalorie per mole. Now we just have to solve this. If we take this minus 349 this side, we will get 344.5. Okay, minus 4.5 plus 349 will give 344.5. And on the right hand side we have minus standard heat of formation of barium ion. And here we will open the bracket, so it will become, this is minus plus minus, and when the bracket will open it will become plus. Okay, so plus 216. Now we have to find out this standard heat of formation of barium ion. So standard heat of formation of barium ion will be equal to 216 minus 344.5, and the unit will be obviously kilocalorie per mole. So on solving this, what do we get? We'll get minus 128.5 in kilocalorie per mole. So let's see, minus 128.5 is given in which option? It is given in option C. Option C will be the correct answer. Next question is match list 1 with list 2. So the first one is humidity. What is humidity? It is the presence of water vapor in the air. Okay, water vapor in the air. Now water vapor is liquid and air is gas. So humidity is nothing but the mixture of liquid and gas. So A will be matched with number 2, liquid and gas. Then the second one is alloys. What are alloys? These are metals which are made by mixing two types of metals together. Okay, so it is mixing of two types of metals together. That means metal plus metal, so solid plus solid. Okay, these two metals will be solid. So it is a mixture of solid and solid. That means B will be matched with number 1. Okay, then the third one is amalgam. What is amalgam? It is an alloy of mercury. It is an alloy of mercury with another metal. And we know that mercury remains at room temperature. So it is liquid at room temperature. That means the amalgam is mixing of a liquid with another metal that is solid. So mixing of liquid with solid. So liquid and solid, it is given in the fourth one. So C will be matched with number 4. Okay, and The last one is smoke. So smoke is mixture of gases. It is mixture of gases such as carbon monoxide or nitric oxide, etc., and solid particles. Solid particles such as unburnt carbon. So gases in solid or solid in gas. So D will be matched with number 3. So according to this, the correct answer will be option D. Okay, option D is the correct answer. Next question is, a reaction is given here, carbon plus hydrogen gives methane. The enthalpy of the reaction is given minus 74.8 kilojoule per mole. Which of the following diagrams gives an accurate representation of the above reaction? Okay, so we know that the enthalpy of a reaction is equal to enthalpy of the product minus enthalpy of the reactant, or we can say that it is equal to activation energy of the forward reaction minus enthalpy energy of the backward reaction, right? Now here in this question you can see that the enthalpy of the reaction is minus 74.8 kilojoule per mole. That means this enthalpy is negative. So the reaction is exothermic in nature, right? So this difference, activation energy of the forward reaction minus activation energy of the backward reaction, is negative. This is negative, and it will be negative only if the first part is less than the second part. That means activation energy of the forward reaction must be smaller than the activation energy of the backward. Then only this difference will be negative. Okay. So if we have the graph here, two types of graphs are possible. Either this one like this, the first part will be smaller, second part will be longer, or second possibility is that the first part will be longer and the second part will be smaller, right? But here the first part that is going up, this on the left hand side, this shows the activation energy of the forward reaction, whereas the second part that is coming down shows the activation energy of the backward direction. Okay, so we know that here the activation energy of forward reaction must be smaller than the activation energy of the backward direction. Therefore, the first part should be smaller and the second part should be longer. Okay, so the graph will look something like this. This one. This should be the correct graph. And what is the enthalpy? Enthalpy is the difference between the activation energy of the forward and backward. That means this difference between the graph, this distance, will give you the enthalpy, that is 74.8 kilojoule per mole. Okay, so which is the correct representation? In the first option you can see that 74.8 is written here. So this means that this distance is equal to 74.8, which is not true. Okay, in the second option, the activation energy of the forward is shown longer, right? It is more. So this is incorrect because the forward activation energy should be smaller. In the third one, forward activation energy is smaller and the backward activation energy is more. So yes, this is true, and the difference is 74.8. So this is correct representation. Okay, last option cannot be correct because here again the product side, the activation energy is smaller, so this is not correct. Option C is the correct answer. Next question is from biomolecules, and the question is, sugar X is found in honey, is a keto sugar, exists in alpha and beta anomeric forms, and it is levorotatory. Now all the options given here, maltose, sucrose, D-glucose and D-fructose, all can be found in honey. Okay, but out of the given option only one is keto sugar, that is fructose. Keto sugar means containing a ketone group in the molecule, right? So all the others do not contain ketone group, so they are not keto sugars. Only fructose is the keto sugar. So we are sure that the fructose will be the correct answer. It exists in alpha and beta anomeric forms. Yes, it is correct that fructose can exist in alpha and beta anomeric forms. Let's draw these forms. First, let's draw the alpha form. So we have 1, 2, 3, 4, 5 sides here. We have oxygen. Now this side we have CH2OH and on the lower side OH. Now here we have OH and H. Then here we have H on the upper side and OH on the lower side. And then here CH2OH, CH2OH, and this side H. So this is the alpha D form. Okay, alpha D fructofuranose. Fructofuranose. Now let's draw the beta form. So similar structure, 1, 2, 3, 4, 5. Here we have oxygen. Now the difference will be only in this part. This side we have OH on the upper side and CH2OH on the lower side. This is the only difference. Other things will be same. So OH, H, then here HOH, here CH2OH and H. Okay, so the difference is only in this part in the alpha and beta forms. Now the last point is it is levorotatory. What is levorotatory? It means that the compound will rotate the plane polarized light in anti-clockwise direction. Rotate the plane polarized light anti-clockwise. So out of the given option, only fructose is levorotatory. It is levorotatory. All the other options are dextrorotatory. Okay, dextrorotatory. Maltose, sucrose and glucose are dextrorotatory because they can rotate the plane polarized light in clockwise direction, whereas fructose can rotate the plane polarized light in anti-clockwise direction. So it is levorotatory. So now we are confirmed that the correct answer is D, fructose. That means option D is the correct answer. Next question is related to isomerism, and the question is total number of possible isomers, both structural as well as stereoisomers of cyclic ethers of molecular formula C4H8O is. Okay, so we have to make a cyclic ether of C4H8O. Okay, ether has to be cyclic, and since it is an ether, O must be part of the ring. So O must be part of the ring or a member of the ring. Okay, and we have to count the number of structural as well as stereoisomers. So first of all, let us calculate double bond equivalent. Double bond equivalent is equal to, we have the formula for that, 2C plus 2 plus N minus X minus H upon 2. Here C is the number of carbons. So how many carbons are there? 4. So 2C means 2 into 4, 8 plus 2 plus N means number of nitrogen. So no nitrogen is there, so it will be 0. Minus X, that means halogen. X is the halogen. So again, the compound does not have any halogen, so it will be 0. Minus number of hydrogen, H for hydrogen. So how many hydrogens are there? 8. Okay, divided by 2. So 8 and minus 8 will get cancelled, and 2 upon 2, that will give you 1. So the value of double bond equivalent is 1. It means either it will have one ring, either the compound will have one ring, or it will have one pi bond. Okay, only one will be possible. Either it will have one ring or it will have one pi bond. Both of them cannot be possible. Now we know that we are talking about the cyclic ethers. That means ring is compulsory. The presence of ring is compulsory. So it will not have any pi bond because there can be only one possibility. So the ring is compulsory. So pi bond is absent in the compound. That means only single bonds will be present. Okay. Now let's draw the possible structures. So we'll start with the 5-membered ring. 5-membered ring looks something like this, and we know that O, that is oxygen, has to be one of the members of the ring. Okay, now at other corners carbon are present. So this is one structure. It will have only one isomer. There are no more isomer for this compound. Then another possibility is that a 4-membered ring can be formed. 4-membered ring can be formed. Here oxygen is one part and one carbon can be taken outside the ring as the methyl group. Okay, now here this carbon is a chiral carbon, so it will have two isomers. Okay, so two structures are possible from here. Then another possibility is that it is a 4-membered ring and we will rotate the position of the methyl group. So first it was here, now it can be here at this point. Okay, so again it will have one isomer only because this carbon is not chiral carbon. Okay, so this has only one structure possible. Then next possibility is we can have a three-membered ring. So one oxygen and two more members, and two methyl groups can be taken outside the ring. Again, this will have only one structure. Then another possibility is three-membered ring like this. Here we have the oxygen, one methyl group this side and the other methyl group this side. Okay, so this time we have changed the position of both the methyl groups. Now here we have two chiral carbons, one chiral carbon at this point and the other chiral carbon at this point. So it should have four isomers, but since it is a meso compound, its mirror image will be identical. So instead of four structures, it will give only three structures. Okay, so three structures are possible from this one. And then the last possibility is a three-membered ring like this with an ethyl group as the substitute. Okay, so we are taking ethyl group as outside the ring. So again, it has one chiral carbon at this position. So it will have two isomers from here. So now let's count the total number of structures. 1 plus 2, 3 plus 1, 4 plus 1, 5 plus 3, 8 plus 2, 10. So 10 structures are possible. Okay. So option A, 10 will be the correct answer. Next question is from chemical kinetics, and the question is for the reaction. This reaction is given. The backward reaction rate constant is higher than the forward reaction rate constant by a factor of 2500 at 1000 Kelvin. Given is the value of R. Kp for the reaction at 1000 Kelvin is. So temperature is also given. We have to find the value of Kp. We know from the question that the backward reaction rate constant is higher than the forward reaction rate constant by a factor of 2500. That means Kb upon Kf is equal to 2500. Okay, Kb is the backward reaction rate constant and Kf is the forward reaction rate constant. So from here we can say that Kb is equal to 2500 into Kf. Okay, now we have to find out the value of Kp. So Kp is equal to, what is the formula for Kp? Kc into RT to the power delta Ng. So let's put the values. What is the value of Kc? We do not know what is the value of Kc. We have to calculate that. So we know that Kc is equal to Kf upon Kb. Okay. Forward reaction rate constant upon backward reaction rate constant. So let's solve this. Kf upon Kb. We know that Kb is equal to 2500 into Kf according to the information given in the question. So Kf cancelled. The value of Kc will be 1 by 2500. Okay, so let's put this value here, 1 by 2500. Now what will be the value of delta Ng? Delta Ng is equal to number of moles of product minus number of moles of reactant, right? So how many products are there? 2, and the reactant is only 1. Okay, you can see this reaction. The reaction is A and it is giving 2 moles of B. So the number of moles of product is 2, number of moles of reactant is 1. So 2 minus 1 is 1. So delta Ng value is 1, right? Now, what is the value of R? It is given in the question, 0.0831. And what is the temperature T? It is 1000 Kelvin. Okay, so if we multiply these, we'll get 83.1. and here we have 2500. So let's divide this. If you divide this, you will get the value 0.033. So this will be the value of Kp. Option A will be the correct answer. Next question is related to structure of atom, and the question is the ratio of wavelengths of the light absorbed by a hydrogen atom when it undergoes n equals to 2 to n equals to 3 and n equals to 4 to n equals to 6 transitions respectively is. So basically we have two cases. in the first case, the N1 is equal to 2 and N2 equals to 3. And in the second case, N1 equals to 4 and N2 equals to 6. We have to find the wavelength in both the cases. In the first case, it will be lambda 1. In the second case, the wavelength will be lambda 2. And then we have to find the ratio of lambda 1 and lambda 2, right? So let's start with the first case. In the first case, there is transition between n equals to 2 to n equals to 3. So in this case, n1 is equal to 2 and n2 is equal to 3, right? Now we know the formula 1 by lambda equals to r into z square 1 by n1 square minus 1 by n2 square, right? Here z is the atomic number. So we are talking about the hydrogen atom. So the value of z will be 1, okay? So 1 by lambda 1. For this wavelength, we are writing lambda 1. So 1 by lambda 1 is equal to r and z square is 1. So let's ignore that. Then here we have 1 by n1 square, that means 1 by 4 minus 1 by n2 square. So 3 square is 9. Okay. Let's solve it further. Here we'll get r and here 9 minus 4 upon 4 into 9. Okay. So this will be equal to 5r by 36. Okay. So 1 by lambda 1 is equal to 5r by 36. So we can say that lambda 1 is equal to 36 upon 5r. This is the value of lambda or the wavelength in this case. Now let's come to the second case. Similarly, we can find out the wavelength in that case. Case 2. In this case, N1 is equal to 4 and N2 is equal to 6. So again, we'll use the same formula. 1 by lambda 2. In this case, the wavelength is lambda 2. So 1 by lambda 2 is equal to rz square. Okay, again z square is 1. So we'll just write r. And then here we will have 1 by n1 square, that is 4 square, minus 1 by n2 square, that is 6 square. That means r 1 by 16 minus 1 by 36. Okay, if we solve this, what do we get? Here we'll get r 36 minus 16 this side, and here 16 into 36. Okay, so 1 by lambda 2 will be equal to 20r upon 16 into 36, right? So what will be the value of lambda 2? It will be just reverse of this, that means 16 into 36 upon 20r. So this is the wavelength in the second case. Now simply we have to find the ratio of these two wavelengths, that means lambda 1 by lambda 2. So we have lambda 1 and lambda 2, you can see here. So lambda 1 by lambda 2, this ratio is equal to 36 by 5r, this is lambda 1, into 20r upon 16 into 36, right? So 36 cancelled, r cancelled, 5 into 4 is 20. So we have 4 by 16, that is 1 by 4. So this ratio is equal to 1 by 4. Now let's see the options. 1 by 4 is given in second option. So option B will be the correct answer. Next question is from the chapter electrochemistry, and the question is, if the molar conductivity of a 0.050 mole per liter solution of a monobasic weak acid is 90, its extent or degree of dissociation will be. Here the conductivity of cation is given and the conductivity of anion is given. Okay, so from here we can find out the value of limiting molar conductivity, that is lambda m naught. That will be equal to the conductivity of the cation plus the conductivity of the anion. Okay, that means 349.6 plus 50.4. Okay, on solving this we'll get 400. Okay, unit will be same as the molar conductivity. So this is the limiting molar conductivity, lambda m naught. Now we have to find out the degree of dissociation, that is alpha, which is equal to molar conductivity upon the limiting molar conductivity. So the molar conductivity of 0.050 mole per liter solution is given 90, right? And the limiting molar conductivity that we have calculated is 400. So on solving this, what do we get? We'll get 0.225. So option A will be the correct answer. Next question is from the chapter solutions, and the question is 5 moles of liquid X and 10 moles of liquid Y make a solution having a vapor pressure of 70 torr. The vapor pressures of pure X and pure Y are 63 torr and 78 torr respectively. Which of the following is true regarding the described solution? Option A, the solution is ideal. Option B, the solution has a volume greater than the sum of individual volumes. Option C, the solution shows positive deviation, and option D, the solution shows negative deviation. So what is given? We have two liquids, liquid X and liquid Y. Okay, the number of moles of X is 5 and number of moles of Y is 10. So what will be the total number of moles? 5 plus 10, that is 15, right? This is the total number of moles. So what will be the mole fraction of X? Mole fraction of X will be the number of moles upon the total number of moles. So 5 by 15, that is 1 by 3. This is the mole fraction of X. Similarly, the mole fraction of Y is the number of moles of Y, 10, upon the total number of moles, 15. So we'll get 2 by 3. This is the mole fraction of Y. Okay. What else is given? The vapor pressure of pure X. Vapor pressure of pure X is given as 63 torr, and the vapor pressure of pure Y is given as 78 torr. So according to the given data, let's calculate the vapor pressure of the solution. Okay. So the vapor pressure of the solution that is calculated will be equal to P naught X into XX. That means the vapor pressure of pure X into the mole fraction of X plus the vapor pressure of pure Y into the mole fraction of Y. Okay, this is the formula. So the vapor pressure of pure X is 63 torr into the mole fraction of X is 1 by 3, right? Plus this side for Y, vapor pressure of pure Y 78 torr into the mole fraction of Y is 2 by 3. So if you solve this, here we'll get 21 and this side we will get 52. Okay, so on adding these we'll get 73. So 73 torr is the calculated vapor pressure of the solution. But in this question it is given that the vapor pressure of the solution is 70 torr. Okay, so P calculated is 73 torr and P observed is 70 torr. So which one is more? The calculated pressure is more than the observed pressure, right? P calculated is more than the P observed. So this shows that the solution will show negative deviation. It will show negative deviation. If the observed pressure will be more than the calculated one, in that case it will show positive deviation. But in this case, the calculated one is more, so the negative pressure deviation will be shown by the solution. So option D will be the correct answer. The solution shows negative deviation. Next question is from mole concept, and the question is, among the following choose the ones with equal number of atoms. Okay, so here we have to calculate the number of atoms. We know that the number of atoms is equal to the number of moles into atomicity into the Avogadro number. Okay, and number of moles can be written as given mass by molar mass. Okay, so let's use this formula to calculate the number of atoms for each one of them. For the first one, we have given mass 212 gram, 212 upon the molar mass is given 106 grams, right? Into the atomicity, that means the number of atoms is 6. Okay, 2 sodium, see Na2CO3 means 2 sodium atoms plus 1 carbon atom plus 3 oxygen atoms. So total 6 atoms are there. This is atomicity. So into 6 into the Avogadro number. So on calculating this, we'll get 12 into the Avogadro number. The value of Avogadro number will be same, so we do not need to write the value of Avogadro number. Then the second one, given mass is 248 grams upon the molar mass is given 62 grams into the atomicity, that is number of atoms here is 3, 2 sodium and 1 oxygen, okay, into the Avogadro number. So here we'll get again 12 Avogadro number. Then the third one is given mass 240 grams, molar mass is 40 grams. So here we have 6 into the number of atoms will be 3 again, 1 sodium, 1 oxygen and 1 hydrogen for NaOH. Then Avogadro number. So here we'll get 18 into Avogadro number. Fourth one is given mass 12 grams, molar mass 2 grams into the number of atom is 2, okay, 2 hydrogen atoms into Avogadro number. So here we have 6 into 2, that is 12. 12 into Avogadro number. And then the last one is 220 grams given mass and 44 grams molar mass, okay, into carbon dioxide has how many atoms? 3 atoms, 1 carbon and 2 oxygens into the Avogadro number. So here we'll get 11 into 4, 44 and 11, 2, 0, okay. So 5 into 3, 15. 15 times Avogadro number. So here you can see that 3 have same this number of atoms. First one, second one and the third one, okay. So first one, second one and fourth one. So A, B and D, they have same number of atoms, that is 12 times the Avogadro number. So A, B and D is given in the fourth option, last option. So option D will be the correct answer. Next question is, which of the following are paramagnetic? So we know that for compound to be paramagnetic, the presence of unpaired electron is must. Unpaired electrons should be present, right? So let's check one by one. In the first one, we have nickel Cl4 2 minus, that means nickel 2 plus ion, whose electronic configuration is 3d8. So if we fill the 3d orbitals, 5 orbitals are there, 1, 2, 3, 4, 5, and 8 electrons are to be filled. So 1, 2, 3, 4, 5, then 6, 7, 8. So here you can see it has 2 unpaired electrons, right? And we have chloride ion as the ligand here. So this is a weak field ligand, okay? Chloride is a weak field ligand. That means no pairing will take place. If the ligand is weak field ligand, then no pairing will take place. If it will be strong field ligand, then pairing up will take place, okay. So in this case, no pairing, that means these 2 electrons will remain unpaired. That means this compound will be paramagnetic in nature. Now let's check for the second one, B. Here we have nickel CO4. So this time we don't have nickel ion, we have pure nickel, right, with oxidation state 0. What will be the electronic configuration? It will have the electronic configuration 4s2 3d8, right? So this time we have 3d orbital as well as one 4s orbital, okay. So in 4s orbital we have 2 electrons and in d orbitals we have 8 electrons. So 1, 2, 3, 4, 5, then 6, 7, 8. Again, this time we have 2 unpaired electrons in the 3d orbital, right? But since nickel is in pure state and CO is a strong field ligand, so the 2 electrons present in the 4s orbital will also participate in this bonding and they will pair up with the unpaired electrons of the 3d orbitals, okay? So it will become something like this. In 3d orbitals, all the electrons will be paired, okay, and then 4s orbital will become empty, okay. So again we have no unpaired electrons, no unpaired electrons. That means this compound will be diamagnetic in nature. It will be diamagnetic. Now let's check the third one. Here we have nickel CN4 2 minus. So we have nickel 2 plus ion That means the electronic configuration will be 3d8. So let's draw the, let's fill the electrons in the orbitals. 1, 2, 3, 4, 5 and 6, 7, 8. So again you can see two unpaired electrons are there, but this case is different from the first one because in the first one there was weak field ligand, but in this case cyanide is present, which is a strong field ligand. Okay, so strong field ligand is present. So this will lead to the pairing up of these two electrons. Okay, so it will become like this. It will look something like this. Okay, all the electrons will be paired ones. So this will make this diamagnetic in nature. Okay, now let's check for the fourth one. Here we have nickel and then water, H2O6 2 plus. So nickel 2 plus ion is there, right? And the electronic configuration is same, that is 3d8. This case is same as the first case. Okay, 1, 2, 3, 4, 5, then 6, 7, 8. Okay, in the first case also there was weak field ligand. In this case also water is the ligand, which is a weak field ligand. So no pairing will take place. No pairing, and two electrons will remain unpaired. So this will be a paramagnetic complex or paramagnetic compound. Now only the last one is left. So let's check the last one. Here we have nickel PPH3 4. So again nickel is in zero oxidation state. Okay, no charge is there. So zero oxidation state, and the electronic configuration is 4s2 3d8, just like the second case. So this will be similar to the second case. Okay, that means this will be diamagnetic in nature. Just have a look at the second case where we had Ni nickel CO4. Okay, the same thing will happen here and the compound will be diamagnetic in nature. So only two compounds are paramagnetic, A and D. Okay, A and D. So option A will be the correct answer. Next question is from the chapter Chemical Kinetics, and the question is, if the half-life for a first order reaction is 1 minute, then the time required for 99.9% completion of the reaction is closest to. Okay, so the half-life is 1 minute, right? We know that the half-life is equal to 0.693 by k, where k is the rate constant. So from here we can find out the value of k, that will be equal to 0.693 divided by the half-life, and half-life is 1 minute. So 0.693 by 1, that is simply 0.693. So this is the value of k. This is the one thing that we have to keep in mind. Then there is 99.9% completion of the reaction. That means if the initial concentration A naught is 100, then the concentration at time t or after time t, AT will be equal to 100 minus 99.9, that is 0.1 or 1 by 10. Okay, so this is the concentration at time t, and the initial concentration will be assumed to be 100. Okay, now we have to find the time required for this reaction. So we'll use the formula K equals to 2.303 by T log A naught by AT. Okay, A naught is the initial concentration and AT is the concentration after time T. We have to find out the value of T, right? So we'll take T this side, and here we'll get 2.303 by K log A naught by AT. Now let's put the values. T will be equal to 2.303 divided by K. What was the value of K? We had seen in the first step 0.693. Okay, this is the value of K. So 0.693. Then log A naught, initial concentration is assumed as 100, and AT, that means after time t, it is 0.1 or 1 by 10. So this 10 will go up. Okay, so here we'll get 2.303 by 0.693 into log 1000 or 10 to the power 3. Okay, so log 10 to the power 3 means what? 3 log 10, and log 10 is equal to 1, so this will be equal to 3. Okay, so this value will be equal to 3. So 2.303 into 3 divided by 0.693. Now on the numerator side, we will have 6.909, and here we have 0.69. Okay, 693. So this, if you calculate this, it will be approximately equal to 10. Okay, and the unit of time is minute. So 10 minutes will be the correct answer. Option B is the correct answer. Next question is, energy and radius of the first Bohr orbit of helium ion and lithium ion are, the value of RH is given, the value of A naught is given. Okay, so here we can use the simple formula for energy in the nth orbit, that is minus 2.18 into 10 to the power minus 18 into z square upon n square. Here z is the atomic number, and n is the number of orbit, which is 1 in this case because we are talking about the first Bohr orbit. So n will be equal to 1. So n is 1. So n square will also be 1. Okay. So let's check for the lithium ion first. Okay, because in the options that of lithium is given first. So for lithium ion, whose atomic number is 3, the value of Z is 3. The energy will be equal to minus 2.18 into 10 to the power minus 18 into 3 square, that is 9, and n square will be 1. So on solving this, we'll get minus 19.62 into 10 to the power minus 18, and the unit of energy will be joule. Okay, let's calculate for helium ion. For helium ion, the value of Z is equal to 2. So the energy will be equal to minus 2.18 into 10 to the power minus 18 into the square of 2, that is 4. So on calculating this, we'll get minus 8.72 into 10 to the power minus 18 joule. So let's match the value of energy in the options. In the first option, the energy of lithium is given minus 19.62 into 10 to the power minus 16. So it will be minus 18. So it is incorrect. Okay, minus 18, not 16. In the second option also, 10 to the power minus 16 is given. So incorrect. In the third option, it is minus 19.62 into 10 to the power minus 18. So this is correct. Okay. In the second option, the first value is also wrong. Okay, minus 8.72. That is not the value of energy for lithium. It is minus 19.62. Okay. So first, second options are incorrect. Third one seems to be correct. Okay. And the fourth one is also incorrect. Minus 8.72. This is incorrect because it is minus 19.62 for lithium. So from here only we can say that option C is the correct answer, but still we'll check for the radius also. Okay. So what is the value of radius in the nth orbit? It is 52.9 into n square upon z. Okay, and the unit will be picometer. So let's check for lithium. For lithium ion, z is equal to 3, right? So the radius will be equal to 52.9 into n square, that is 1. Okay, because n is equal to 1 here, and upon z, that is 3. So on solving this, we'll get the value 17.63 picometer. Similarly, we can calculate for helium ion. So for helium ion, okay, here I have done a mistake. It is helium plus, not helium 2 plus. Okay. So for helium ion, Z is equal to 2. So radius will be equal to 52.9 divided by 2. So solving this, what do we get? We'll get 26.45 picometer. So let's match all these with the option 3, with the option C. Okay. Here you can see all are correctly given. So option C will be the correct answer. Next question is from organic chemistry, and the question is, among the given compounds 1 to 3, the correct order of bond dissociation energy of carbon hydrogen bond marked with star is. So we have three compounds here and we have to find the correct order of their bond dissociation energy, right, of the carbon hydrogen bond. So suppose this is the carbon hydrogen bond that is marked with star. Okay, now in case this bond gets broken, then what will happen? Free radical will be formed. Okay, after the breaking of this bond, carbon hydrogen bond, free radical will be formed, right? So the bond dissociation energy will be inversely proportional to the stability of that free radical. Okay, so let's write it down here. Bond dissociation energy will be inversely proportional to the stability of the free radical that is formed after homolytic fission of carbon hydrogen bond. Okay, after homolytic fission of carbon hydrogen bond. Okay, so if this carbon hydrogen bond is broken homolytically, then the free radical that is formed, the stability of that free radical will be inversely proportional to the bond dissociation energy or vice versa. Okay, so let's check the stability of each of these radicals. The first compound we have is a benzene ring and a hydrogen is attached to one of the carbons of the benzene ring. Okay, so suppose this bond is broken. In that case, what radical will be formed? We will have this radical, a benzene ring and then one radical here. Okay, so this is first radical. The second radical will be formed when this bond is broken. So the radical will look something like this. This is the benzene ring. Here we have carbon and then triple bond carbon, and this is the free radical. Okay, so this side this time the radical is on a triply bonded carbon. Okay, in the first case the radical is on a doubly bonded carbon. Okay, the carbon is double bonded. In the second case the carbon is triple bonded. Okay, and in the third one we have this triangular shape, one bond here, and here we have this radical, one of the hydrogens is removed. Now, in these three compounds or in these three radicals, which one will be most stable? This is the first one, this is the second one, and this is the third one. Okay. Now, in the third case, you can see that resonance will be present, right? And due to the presence of resonance, this third radical will be most stable. Okay. In the first compound or the first radical, you can see that the radical is on a carbon that is doubly bonded. Okay, that has double bond. So we know that when the radical is present on a doubly bonded carbon, this is an unstable compound or unstable radical. Okay, so this is unstable as compared to the third one. And the second one is also unstable because here the carbon is triple bonded. But which one between 1 and 2 is more stable and which one is less stable? So we know that the carbon which is triple bonded is more electronegative as compared to the doubly bonded carbon. So the second one will be the least stable one. Okay, the stability of the second one will be even lesser than that of the first one. Okay, so here the most stable one will be the third one, then the first one, and then the least stable will be the second one because the carbon is triply bonded and that is more electronegative and as compared to the doubly bonded carbon, so it is even less stable than the doubly bonded carbon. Okay, so this is the order of stability of the radical. But we know that the bond dissociation energy is inversely proportional to the stability of the free radical. Okay, so the order of bond dissociation energy will be just the reverse of this. That means the second one will be having the highest bond dissociation energy, then the first one, and then the third one. So this will be the correct order of the bond dissociation energy: second, then first, then third, in the decreasing order. Okay, so this is given in the third option. So option C will be the correct answer. Next question is Dalton's atomic theory cannot explain which of the following? Option A, law of multiple proportions. Option B, law of gaseous volume. Option C, law of conservation of mass. And option D, law of constant proportion. So we know that the Dalton's atomic theory can explain the laws of chemical combination, right? Laws of chemical combination. So under the laws of chemical combination comes law of multiple proportion, law of conservation of mass and law of constant proportion. So all these three, the first one, third one and fourth one can be explained by Dalton's atomic theory, whereas the law of gaseous volume cannot be explained by the Dalton's atomic theory. So option B will be the correct answer. Let's come to the next question. Identify the correct orders against the property mentioned. So some orders are shown here. We have to check which are correct orders. Okay. So the first one is water, then ammonia, then CHCl3 chloroform. Okay. And the property is dipole moment. Dipole moment. So is this a correct order of dipole moment? See, we know that the water is a bent molecule, right? It is a bent molecule. Ammonia is trigonal pyramidal in shape, right? And here the water molecule has oxygen in it, whereas ammonia has nitrogen. So which one is more electronegative out of oxygen and nitrogen? Oxygen is more electronegative as compared to nitrogen. So due to the higher electronegativity of oxygen, water will have higher dipole moment as compared to ammonia. Okay, so this part is correct. Now let's compare the dipole moment of chloroform with these two. So in chloroform, the shape will be tetrahedral, and there will be symmetrical arrangement of chlorine, right? So the overall molecule is symmetrical, okay, and this will reduce the polarity of this molecule compared to the other two molecules, that is water and ammonia. So this is the correct order of dipole moment which is shown. Water will have the highest dipole moment, then ammonia, and then chloroform. If we mention the dipole moment, then for water it will be 1.85, for ammonia it will be 1.47, and for chloroform it will be 1.04. So clearly this is a correct order of dipole moment which is shown in the question. So A is definitely correct. Then let's come to the second order that is shown here is xenon F4, then xenon O3, then xenon F2. And the property is number of lone pairs, on the central atom. So according to this question, xenon F4 has maximum number of lone pairs, then xenon O3 and then xenon F2. So let's check. First we'll draw the structure of xenon F4. So this is xenon. We have 4 fluorine atoms like this. Okay. And we will have 2 lone pairs, one this side and the other this side. Okay. So how many lone pairs? 2 lone pairs. It has 2 lone pairs. Then the second one, xenon O3. So this is xenon. We have 3 oxygens, one this side, and the other this side. And there will be 1 lone pair above the on the top part. Okay. So it has only 1 lone pair. So from here we can see that the first one has 2 lone pairs, second one has 1. So yes, it is in decreasing order. For the third one, let's check xenon F2. So this is xenon, 1 fluorine this side, 1 fluorine this side, and it will have 1 lone pair here and 2 lone pairs on another side. So how many lone pairs? 3 lone pairs. According to the question, xenon F2 will have minimum number of lone pairs, but actually we saw that it has maximum number of lone pairs. So this order which is shown is incorrect. Okay, B is incorrect. Now let's check the third one. What is the third one? Here we have oxygen hydrogen, then carbon hydrogen, and then nitrogen hydrogen. So oxygen hydrogen, then carbon hydrogen bond, and then nitrogen hydrogen bond in the decreasing order. Okay. And what is the property mentioned there? The property is bond length. Bond length. Now, if we compare the bond length of oxygen-hydrogen bond and carbon-hydrogen bond, from here we can see that one of the atom is same, that is hydrogen is same. The difference is only between oxygen and carbon. Which one is smaller in size? Oxygen is smaller in size. Okay, oxygen is smaller in size as compared to the carbon. Okay, right? The atomic radius of oxygen is smaller than the radius of carbon. And we know that the lesser the atomic radii, the smaller will be the bond length, right? So from here only we can say that the bond length of oxygen hydrogen will be lesser as compared to the carbon hydrogen. But in this question it is shown that the bond length of oxygen hydrogen will be more than the carbon hydrogen. So the first part itself is incorrect. So C is also incorrect. Till now only A is correct, B and C are incorrect. Now the last one. What is the last property that is shown here? Nitrogen, oxygen and hydrogen and bond enthalpy. So what is the bond order of nitrogen? If we talk about the bond order, then for nitrogen the bond order is 3. For oxygen the bond order is 2, and for hydrogen molecule the bond order will be 1. Okay, so nitrogen, then oxygen, then hydrogen. This is the decreasing order of the bond order, and we know that bond enthalpy is directly proportional to the bond order. So this will be the same order for bond enthalpy as well. So this is correctly shown. Okay, so out of the 4 properties that are shown here, only first one and last one are correctly shown. A and D are correct. That means option C, A and D only will be the correct answer. Next question is from biomolecules. Here we have to match the name of the vitamins with the deficiency disease. So the first one is vitamin B12. So which disease is associated with vitamin B12 deficiency? It is pernicious anemia. Okay. So A will be matched with number 4. Then B. B is vitamin D. The deficiency of vitamin D causes rickets. Rickets. So B will be matched with number 3. Then C is vitamin B2. What is the disease caused by the deficiency of vitamin B2? Chelosis. Okay. So C will be matched with number 1. And the last one is vitamin B6. So the deficiency of B6 leads to convulsions. So D will be matched with number 2. So according to this, the correct option is the last one. Option D will be the correct answer. Next question is from the chapter amines, and the question is the correct order of the decreasing basic strength of the given amines is. So we have to compare the basic strength of the given amines. Now we know that the bases are electron donors. So more the electron density on the nitrogen atom, better will be the basic character or basic strength of the amine. Okay, so we have to basically compare the electron density on nitrogen in the given amines. Okay, so first of all we should remember one thing, that the aliphatic amines are better electron donors, or the aliphatic amines have more basic strength as compared to the aromatic amines. Aromatic amines. What is the reason? In case of aliphatic amines, we have alkyl group attached to the nitrogen, right? And alkyl group has plus I effect. That means it donates electron towards the nitrogen, right? So the nitrogen in this case will have more electron density. These electrons are provided by the alkyl groups, right? So the nitrogen will have more electron density, so the electrons will be more readily available for donation, right? So it will be better bases. And aromatic amines are having less basic strength. Why? Because in this case we have the aryl groups. Okay, we have the aryl groups attached to the nitrogen. So we know that the aryl groups are electron withdrawing in nature. They are electron withdrawing in nature. So they will withdraw electrons from the nitrogen. So nitrogen will, the electrons will be less available for donation, right? Also, the electrons which are available on nitrogen will be involved in the resonance, right? So they will be less readily available. So one thing you understood, that aliphatic amines will be better bases, or they will have more basic strength as compared to the aromatic amines. So in the given options, you can see that we have two aliphatic amines and two aromatic amines. So first we will write the aliphatic amines. There are again two types of aliphatic amines. One is N-ethyl ethane amine, and the second one is ethane amine. So these two are aliphatic, so definitely they will come first. Now we will compare which one of them are better bases. So in case of N-ethyl ethanamine, the structure will be something like this: C2H5, then NH, and then again C2H5. Two ethyl groups are attached to the nitrogen in this case. We know that the alkyl groups have plus I effect, they will donate electron. So here electron will be donated towards the nitrogen from both the sides. Okay, so both the alkyl groups are giving electrons to the nitrogen. So the nitrogen has more electron density here because of the presence of two alkyl groups, whereas in ethanamine there will be only one alkyl group. Okay, C2H5, then NH2. So here also alkyl group is present, which will give electron towards the nitrogen, but in the first case there were two alkyl groups, so the electron density will be more in which case? The first case. Okay, so obviously the first one will be having more basic strength, okay, than the second one. Now we will come to the aromatic amines. So there are two aromatic amines here: N-methylalanine, N-methylalanine, and benzenamine. Benzenamine. So let's see the structure of N-methylalanine. Here we have this benzene ring. Benzene ring will be present in both. In the N-methylalanine, we have a methyl group attached to the nitrogen as well. Okay, whereas in benzenamine there is no methyl group attached, there is just NH2 here. Okay. Now, what is common in both of them? The presence of benzene ring, right? Both are electron withdrawing in nature, so they will withdraw electron. So the electrons will be less readily available for donation on the nitrogen. But in the N-methylalanine, there is one methyl group as well, which will give electron to the nitrogen. So here the electron will be more as compared to the benzenamine, right? Because in benzenamine, there is no group that is giving electron towards nitrogen. So N-methylalanine will be a better base as compared to the benzenamine. So the correct order will be this one. That means the first option is the correct one. Okay. This is the correct order of the basic strength. In other options, you will not find this sequence. For example, in the second option, it is given that benzenamine has highest basic strength. Okay, it is the best base among all, which is incorrect because in fact this is having the least basic strength, right? Because of the presence of the benzene ring. Okay. Similarly, for the third option, N-methylalanine has been shown to be the best base among all, which is incorrect because N-methylalanine is aromatic in nature and it will come after the aliphatic ones. Okay, so all the options you can check, only the first option is the correct sequence. I have explained it well. So option A will be the correct answer. Next question is from the chapter Coordination Compound, and the question is the correct order of the wavelength of light absorbed by the following complexes is. So we have to write the correct order of the wavelength of light that will be absorbed by the given complexes. Now we know that stronger the ligand, more will be the splitting, right? More will be the splitting, and more the splitting, more will be the energy. Okay, more energy. That means the energy is directly related to the strength of the ligand, right? So strength of the ligand is directly proportional to the energy, and we know that the energy is equal to hc by lambda. So from here we can say that energy is inversely proportional to the wavelength lambda, right? So more the strength of the ligand, more will be the energy and lesser will be the wavelength of light absorbed. Okay, because wavelength is inversely proportional to the energy. Now let's check the strength of the ligands in the given complexes. So which complexes have strong field ligands? The first and second complexes, ammonia and cyanide, both are strong field ligand, right? But cyanide is stronger field ligand as compared to the ammonia, right? And then comes water, which is a weak field ligand. So water is a weak field ligand. Both ammonia and cyanide are strong field ligand, but cyanide is stronger field ligand. So this is the order of the strength of the ligands, right? Now here you can see that the third and fourth complexes both have water as the ligands. So which one will have more strength? So for that, you should remember that the splitting in case of the octahedral complexes is more as compared to the splitting in the tetrahedral complexes. So in the third complex, here the coordination number is 4. That means this is a tetrahedral complex. And in the last one, the coordination number is 6. So this is octahedral complex. So which one will have more splitting? The octahedral complex. Okay. So let's write them in order, in the correct order of strength of the ligands. So the first one will be the one complex having cyanide. That means B will have maximum strength. Then comes the ammonia ones, that is A. And then the octahedral complex with water as the ligand. So D, and then the tetrahedral complex with water as the ligand. So C. This is the correct order of the strength of the ligand, right? And this is this is also the order of the energy, because both are directly proportional. But energy is inversely proportional to the wavelength. So the order of wavelength will be just the reverse of this. That means B will be least, there will, and then A, and then D, and then C, like this. Okay. So this will show the correct order of the wavelength of light absorbed. So C will have the maximum wavelength of light absorbed, okay, and B will have the minimum wavelength of light absorbed. So let's check which option has this. This is given in the last option. Option D is the correct answer. Next question, which of the following compounds does not decolorize bromine water? So we know that this is related to the bromine water test. Bromine water test, and bromine water test is basically a test for unsaturation. Okay, it is a test for unsaturation. We know that bromine water is reddish orange in color, right? It is reddish orange or brownish in color. Now what happens in this reaction when the bromine gets added to the unsaturation site, to the unsaturation site, then the reaction takes place and the color of the bromine water discharges. Okay, so decolorization is observed. Okay, bromine will get added to the unsaturated site and there will be decolorization of the bromine water. Okay, so from here you can understand that for this reaction to take place, the presence of an unsaturation site is must. Okay, that means the compound must be unsaturated. So the unsaturated compounds will show the reaction, or they will give the reaction, whereas the saturated compounds will not give the reaction. Okay, so they will not show this reaction, and when there will be no reaction, there will be no decolorization. Okay, so it is asked in the question that which one of them will not decolorize the bromine water. Obviously the one which does not have an unsaturation site will not decolorize the bromine water. So out of the given option, there is only one compound that is not unsaturated. Okay, there is only the third compound that is saturated, not unsaturated. Okay, so it will not give this reaction, so there will be no decolorization in this case. So option C will be the correct answer. Let's check the products that will be formed in the other reactions. In the first one, what product will be formed? This is the benzene ring. Here we will have CHBr and then CH2Br. This is the product that will be formed in this case, and obviously there will be decolorization of the bromine water. In the second case, we have aniline. So what product will be formed? Suppose this is the benzene ring. So this is the NH2. Now here 2,4,6 tribromoaniline will be formed. 2,4,6 tribromoaniline will be formed. Okay, and then in the third one, obviously no reaction will take place, so no product. And in the fourth one, the same thing will happen. This is the benzene ring, this is OH, and 2,4,6 tribromophenol will be formed. 2,4,6 tribromophenol. So these are the products, and the correct answer is option C. It will not give the reaction and there will be no decolorization. Next question is from organic chemistry, and the question is predict the major product P in the following sequence of reactions. So let's see, we have a compound like this. Okay, this is a 5-carbon compound. We have a double bond here and a methyl group at this position. Now in the first reaction, it will react with HBr in the presence of benzoyl peroxide. Benzoyl peroxide. Now here addition reaction will take place. Bromine will get added to this compound, right? And benzoyl peroxide is also present. So we know that in the presence of peroxide, the reaction will take place according to the anti-Markovnikov's rule. Anti-Markovnikov's rule. And what does anti-Markovnikov's rule say? According to this rule, in our if there are two double bonded carbons, then the bromine will get added to that carbon which has more number of hydrogens attached to it. Okay, so here we have two double bonded carbons. This is carbon number 1 and this is carbon number 2. Right, so bromine will get added to which carbon? It will get added to carbon number 1, because this carbon will have one hydrogen, whereas the carbon number 2 will not have any hydrogen. Okay, so what will be the product that is formed? This is a 5-carbon cycle. The double bond will be removed, right? Here we have methyl group and here we will have bromine attached to it. Okay, so this is the first reaction. Now in the second reaction, this product will react with KCN. We know that cyanide is a nucleophile, right? So here nucleophilic substitution reaction will take place. Nucleophilic substitution reaction. So bromine will be the leaving group here and cyanide will substitute the bromine. So the product that is formed is something like this. Here we have the methyl group, and here in place of bromine what will come? Cyanide group will come. So substitution reaction has taken place, nucleophilic substitution reaction. And at last this is going to react with sodium amalgam. Okay, sodium amalgam in the presence of ethanol, C2H5OH. So what will happen? Reduction will take place. Reduction of cyanide will take place, and let's see what will be the final product. So this is the cycle. Here we have the methyl group. Methyl group will remain unaffected. Here the reduction of cyanide will take place. So two hydrogens will get attached to the carbon of the cyanide and two hydrogens will get attached to the nitrogen. So we have CH2 and NH2. Okay, this is the final product or the major product. So let's see which is the correct option. Option number C is the correct answer. Okay, in option number D, both the groups are attached to the same carbon, which is incorrect. So option C is the correct answer. Next question, here we have to match the given mixtures with the correct method of separation that is used to separate them. So the first mixture is chloroform and aniline. So which method will be used to separate them? A simple distillation method is used, right? Because they have significant difference in their boiling points. If we talk about the boiling point of chloroform, it is only 61.2 degrees Celsius, whereas the boiling point of aniline, C6H5NH2, this is aniline, the boiling point is high, okay, 184 degrees Celsius. So you can see there is a significant difference in the boiling points. So when we use the simple distillation, then the chloroform is selectively vaporized and collected, leaving the aniline behind. So A will be matched with number 4, simple distillation. Okay, so option A and option B are eliminated from here. Then let's discuss the second one. We have crude oil in the petroleum industry. So we know that the petroleum industry uses fractional distillation to separate the crude oils components, because in crude oil there are various hydrocarbons present, and different hydrocarbons have different boiling points, right? So fractional distillation is the best method to separate them. So B will be matched with number 3. Okay. Then let's come to the third one, glycerol from the spent lye. So for this, the method that is used is distillation under reduced pressure, because we know that glycerol, when it reaches its boiling point at that temperature, it is decomposed. Okay, it will decompose at the boiling point. Let's write it down here. The glycerol decomposes at its boiling point. Therefore, we have to separate it below its boiling point, right? Therefore, the distillation under reduced pressure is used to allow it to be separated at a lower temperature than its normal boiling point. Okay, so C will be matched with number 1. And the last one is aniline water. So for this, steam distillation will be used. Okay, this method works because aniline is steam volatile and it is immiscible in water. Okay, so D will be matched with number 2. Which option will be the correct one? Option C. Option C is the correct answer. Next question is from inorganic chemistry, and the question is, which among the following electronic configurations belong to the main group elements? Okay, so what are main group elements? The elements which belong to S and P block of the periodic table. Okay, so all the elements belonging to S block and P block are referred to as main group elements. So let's check. The first one electronic configuration is neon 3s1. So this is the electronic configuration of sodium, which is an S block element, right? So definitely this is the main group element. Then the second one, argon 3d34s2. This is the electronic configuration of vanadium, which is a D block element. So this is not the main group element. Third one is krypton 4d10 5s2 5p5. So this is the electronic configuration of iodine. Okay, and iodine is a P block element. So this is the main group element. So A and C. Then D, argon 3d10 4s1. This is the electronic configuration of copper, which is a D block element. Again, this is not the main group element. The last one is the electronic configuration of thorium, which is an F block element, right? So the only elements which belong to S and P block out of the given ones are the first one, that is sodium, and the third one, that is iodine. Okay, so A and C only. Option D will be the correct answer. Next question, which one of the following compounds can exist as cis-trans isomers? Okay, so what are the conditions for the existence of cis-trans isomers? There are two conditions. First, there should be restrictive rotation. Restrictive rotation, right? Then the second condition is that there should be different groups attached to the terminal carbon. Okay, different groups should be present at the terminal carbon, or we can say different groups should be present at the carbon where restrictive rotation is taking place. So let's check one by one. The first compound is 1,1-dimethyl cyclopropane. So this is cyclopropane and 1,1-dimethyl. That means two methyl groups attached to the same carbon. So you can see at this carbon, the two groups that are attached are same. Okay, both are methyl groups. So no cis-trans isomers will be shown. Okay, because both the groups are same, but the condition is that the group should be different. Okay, then the second compound is 1,2-dimethyl cyclohexane. So this is cyclohexane, 1,2-dimethyl, one methyl group here and the other methyl group here. Okay, now at this carbon, suppose this is carbon number 1, this is carbon number 2, this is carbon number 3, 4, 5 and 6. Okay, so at carbon number 1 there is one methyl group and there will be one hydrogen, right? So both the groups are different, one is methyl, the other is hydrogen. At carbon number 2 as well, one is methyl and the other will be hydrogen. So both the groups are different, so it will show the cis-trans form or cis-trans isomers. Okay, So B should be the correct answer. Let's check other options as well. The third one is pent 1-ene. So 5 carbon compound, CH3, CH2, CH2, then CH, double bond CH2. This is pent 1-ene. Pent 1-ene. Now let's focus on the terminal carbon that is having the double bond, this carbon. Here you can see two hydrogens are attached. So both the groups are same. Okay, both the groups are same, that is hydrogen. So it will not show cis transform because the groups should be different. Now let's check the last option, that is 2-methyl hex 2-ene. So let's draw the structure. CH3, CH2, CH2, then CH double bond C and 2 methyl groups here. This is 2 methyl, this is the carbon number 2, 2 methyl hex 2-ene, hex 2-ene, because there is double bond at the second position. Okay, now you can see again both the groups are same. This is methyl group, this is methyl group. Both the groups are same, that is methyl groups. So it will not show cis trans isomers. Only in the second option, one carbon is having two different groups. One is hydrogen and the other is methyl group. So option B will be the correct answer. Next question is from ionic equilibrium, and the question is phosphoric acid ionizes in 3 steps with their ionization constant values Ka1, Ka2 and Ka3 respectively, while K is the overall ionization constant. Which of the following statements are true? So let's write down the reactions first. The first step is the ionization of H3PO4, that is phosphoric acid. It will ionize to give one H plus ion and then H2PO4 minus ion. Okay, the ionization constant for this step will be Ka1. Here you have to keep in mind that the reaction will be reversible. Okay, this is a reversible reaction. So the reaction can take place in both the directions. H3PO4 can give H plus ion and H2PO4 minus, and at the same time H2PO4 minus can also gain this H plus ion to form H3PO4. Okay, so the reaction can take place in both the directions. So from here, can you say which one is a stronger acid, H3PO4 or H2PO4 minus? Obviously H3PO4 will be a stronger acid because this is just giving the H plus ion, which is the property of an acid, right? But H2PO4 minus can give one H plus ion and it can take one H plus ion as well. Okay, so this will be weaker than the H3PO4. Now let's proceed with the second step. In this, the ionization of H2PO4 minus will take place. It will give one H plus ion and HPO4 2 minus ion. In this case, the ionization constant will be Ka2. And the third and the last step is the ionization of HPO4 2 minus. This will give one H plus ion and then PO4 3 minus ion. The ionization constant will be Ka3 of this step. Okay, so these are the ionization constant of each of the steps. If we add these reactions, this side H2PO4 minus will cancel out H2PO4 minus, HPO4 2 minus will cancel out HPO4 2 minus. What will be left on the left hand side? H3PO4 will be left, and on the right hand side 3 H plus ions and 1 PO4 3 minus ions, right? The overall ionization constant is K. Now, according to the rule, the overall ionization constant K will be equal to the product of the ionization constants of each of the steps. Okay, so K will be equal to Ka1 into Ka2 into Ka3. Okay, multiplication of each of the ionization constants, right? Now, in the first statement given in the question, the log is given. Okay, it is given in the form of log. So let's add log. So log K will be equal to log under bracket Ka1 into Ka2 into Ka3. Okay, if we open the bracket, then according to the rule, we will get log K equals to log Ka1 plus log Ka2 plus log Ka3. So if log is added and we open the bracket, then multiplication will change into addition. Okay, this is the rule. So this is the first statement is correct. Okay. Then we come to the second statement. H3PO4 is stronger acid than H2PO4 minus and HPO4 2 minus. So we have already discussed that H3PO4 is a stronger acid because The role of H3PO4 is to give H plus ion only, which is the property of an acid. But H2PO4 minus can take one H plus ion as well. Okay, it can give H plus ion as well as it can take H plus ion. Similarly, HPO4 2 minus can also give and take H plus ion both. Okay, so if we write down the strength of these acids, the H3PO4, the first one will be the strongest acid, then H2PO4 minus will be weaker than this, and the weakest one will be HPO4 2 minus. Okay. Now we know that the ionization constant in this case is Ka1. In the second one it is Ka2. In the second one, the third one it is Ka3. So obviously these Ka1, Ka2 and Ka3 will also be in the decreasing order. Okay. So the third statement will also be correct. First, second and third, all three statements are correct. Whereas in the last statement it is given that Ka1 is equal to Ka3 plus Ka2 upon 2, and there is no such condition. Okay. We don't use this formula anywhere. So only the first three statements are correct. The last one is incorrect. So option B will be the correct answer. A, B and C only. Now in the next question we have to match the ions with the group number in cation analysis. So according to the cation analysis, cobalt 2 plus belongs to which group? It belongs to group 4. Okay. Then magnesium 2 plus ion belongs to group 6. Then lead 2 plus ion belongs to group 1 and aluminium 3 plus ion belongs to group 3. So according to this, A will be matched with number 3, then B will be matched with number 4, C will be matched with number 1 and D will be matched with number 2. So the correct answer is option D. Option D is the correct answer. Next question is from thermodynamics, and the question is higher yield of nitric oxide in this reaction N2 plus O2 2NO can be obtained at. So we have to determine the conditions for higher yield of the product nitric oxide in the given reaction. Now we know that yield of the product in a reaction depends on three factors mainly. First is temperature, second is pressure, and third is concentration. Okay, concentration of the reactants and products. So three factors can affect the yield of the product. Now here you can see that the enthalpy value is given plus 180.7 kilojoule per mole, and we know that a positive enthalpy delta H value shows that the reaction is endothermic. Okay, it is an endothermic reaction. Endothermic reaction. Now we know that in case of endothermic reaction, an increase in temperature shifts the equilibrium in the forward direction. Okay, so increase in temperature shifts the equilibrium in forward direction. And if the equilibrium will shift to forward direction, that means more products will be formed, right? That means for more products to be formed, there should be higher temperature. Okay, a higher temperature is required for more product yield. So higher temperature required, higher temperature. Also, for an endothermic reaction, an increase in concentration of the reactants will shift the equilibrium in the forward direction. Okay. Second point is increase in concentration of the reactants. Reactants will also shift the equilibrium in forward direction. And what are the reactants here? Nitrogen and oxygen. Okay. So higher concentration of nitrogen N2 and O2 is also required for higher yield of the product. So there are two conditions: higher temperature, higher concentration of N2 and O2. So let's see. A is higher temperature. This will be correct. A. Then B is lower temperature. No, this is incorrect because only higher temperature is required. Third one is higher concentration of N2. Yes, C is correct. And D is higher concentration of O2. This is also required. Higher concentration of both the reactants are required. So A, C and D only. Option B will be the correct answer. Next question is from the chapter amines. Two statements are given here. The first statement says that benzene diazonium salt is prepared by the reaction of aniline with nitrous acid at 273 to 278 Kelvin it decomposes easily in the dry state. So yes, this is a correct statement. What is the method of preparation of benzene disonium salt? The reaction of aniline with nitrous acid. So let's write down the reaction. We have to write aniline first, C6H5NH2. This is the aniline, plus nitrous acid. How is nitrous acid formed? It is formed by the reaction of sodium nitrite NaNO2 with HCl. Okay, so NaNO2 and HCl will react to form nitrous acid, and this nitrous acid will react with aniline to give the benzene disonium salt, and this reaction has to take place at the temperature around 273 to 278 Kelvin. Okay, what is the product? Benzene disonium salt, C6H5, then N2 plus Cl minus. Okay, other than benzene disonium salt, there will be NaCl and water. Okay, now let's read the second statement. It says that insertion of iodine into benzene ring is difficult, and hence iodobenzene is prepared through the reaction of benzene disonium salt with potassium iodide. Okay, so this is also correct statement. You cannot directly insert iodine into the benzene ring. Okay, so if you want to introduce or add iodine into the benzene ring, then you have to react the benzene disonium salt with potassium iodide. So let's see the reaction. This is the benzene ring, right? Here we have N2 plus X minus. Okay, X can be any halogen. Okay, mostly it is chloride. It can be other halogen as well. Now we have to add iodine in this place, right? So it will react with potassium iodide. Then this iodine will come here. Okay, and this N2 will come out to form N2 gas. Okay, so both the statements are correct. Option C, both statement 1 and statement 2 are correct. This will be the correct answer. Now we have come to the last question, and the question is the major product of the following reaction is. So we have a compound. Let's draw the structure. It has a benzene ring. Here we have carbon oxygen double bond. Then here we have carbon triple bond with nitrogen. Okay, cyanide. It is reacting with excess of Grignard reagent CH3MgBr, and it is present in excess amount. So what will happen? The Grignard reagent will attack the carbons having multiple bonds. So there is one carbon having double bond with oxygen and the other carbon having triple bond with nitrogen. Both these carbons will be affected. Okay, the methyl group will get added to the carbons and MgBr will get added to the oxygen and nitrogen. So let's see the product that is formed. It is a benzene ring here. Then here we have carbon, methyl group attached to the carbon, and MgBr will get added to the oxygen. So OMgBr. Similarly, here we have cyanide. So the methyl group will get added to the carbon and MgBr will get added to the nitrogen. Okay, NMgBr. Okay, and earlier there was triple bond. Now there is double bond between carbon and nitrogen. Now the last step is the reaction with H3O plus. So this MgBr will get replaced by the hydrogen. Okay, so let's see. Here we have carbon, methyl group, here OH. Okay, then this side carbon, methyl group, and this side we have double bond O. Here NMgBr will be replaced by the oxygen. Okay, so this will be the final product. Let's see which option represent the correct answer. So I think the last option, option D, shows the correct answer. You can match it with the structure that I have drawn. So option D is the correct answer. So here we have completed all the questions from NEET 2025 chemistry paper. We will be back with another session soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice the same questions from our website www.examsnet.com, and for more information, you can download our app from the link given in the description box. Thank you so much.